Hello everybody. Before starting our course, we have to ensure that we have a convenient working environment and a clear mindset for the course. Let's start to obtain these facts step by step. Initially, we need to set up our environment. Our first need for this course is HTML5 supported web browser. You can check your browser's HTML5 capabilities from html5test.com. This is the website that you can check your browser's capabilities. And I'm strongly suggesting that you should check this part of the website. You should get yes answer from your browsers in this website. Second, we need to enable JavaScript in your browsers. It's very important fact because Canvas API requires JavaScript enabled. You can also check your browser's JavaScript situation from the website enableJavascript.com. You should get this message from your browsers. Otherwise, you should enable JavaScript by following these instructions. You should check this website, enable JavaScript in your browsers. There are many different browsers and there are many different manuals in this website. You should check it. And lastly, we need a text editor to writing our codes. I will be using Atom editor throughout the course, and I'm strongly suggesting you to use it. You can download it from atom.io. You can open the website from atom.io address, and you can download Atom editor from this website and set up in your environment. It's your preference, but I'm suggesting you to use Atom editor. Now we will talk about what we need to know. You don't need to know a programming language at advanced level for this course, but it's very nice to know an object-oriented programming language or any related programming language. However, it's a must that you should have HTML or HTML5 knowledge, CSS knowledge, and JavaScript knowledge for this course, at least basic understandings on these technologies. Or you should have an interest on these technologies. This can be also okay for this course. Lastly, beyond technical facts, what do we really need? We need curiosity for learning this powerful technology. We need energy for completing this long journey because this course will be a long journey for you. And lastly, we need a motivation for building modern and crazy web application with Canvas. If you are okay for now, we are ready to start. Let's start! What is Canvas? Interactivity and attractiveness are always demanding and popular in web development throughout the internet history. In the past, Flash was meeting these needs. You may hear or not, but it was the leading dominant technology in the past. Then, two remarkable developments has been occurred. Spread of internet and smartphones, smart devices revolution. The needs of the internet have changed radically. Portability of the web applications has become a major need. The website should work properly on mobile, desktop, tablets, and now on smart TVs. Flash, also Java, Silverlight, and other old technologies were working with plugins and extra softwares. They are not universally supported by mobile. Then, a new standardization was appeared, HTML5. It has come to solve all of this portability and dependency issues. It has come with several revolutionary APIs and technologies. You should visit developer.mozilla.org HTML5 section and see all of these APIs and technologies. Canvas API is one of these revolutions. It does the same thing like a physical canvas, but instead of using brushes and palettes, we are using JavaScript to send drawings. It's the shining star of modern web development. It has been used in many areas for a long time. It's very popular for comprehensive drawing applications like this, highly interactive and visually powerful, this kind of rendering tools, chart and graph libraries, games, and other areas without any plugin or extra software. The only thing you need is just HTML5 supported web browser, and that's it. It's the best time to learn this edge technology. Welcome to Introduction lesson. We will create our first Canvas application in this lesson. Let's start. This is our basic project structure. We have index.html, style CSS, canvas scripts.js. First thing we need to do is we should add the canvas to our index.html. Let's add the canvas. Canvas. We should define an ID for canvas to handle it. Hello world canvas, and close the canvas tag. Now we have a canvas in our project. This is the fact I mentioned before. No plugin needed. That's it. As a nature of canvas, it's totally white at the beginning. Totally white. Let's add a border to canvas and set some default values to make it meaningful and visible. First, we should handle it with its ID, hello world canvas. We should add a border, 1 pixel solid black. Let's check it out. Oh, it's visible now. You can see the canvas here. This is the canvas we will work it on. Let's make more changes on it. I would like to align my canvas center of the browser. Center, align. First, I would like to make it display below, and I would like to make it more wider and higher with 600 pixel, height 300 pixel. Let's check it out. And I would like to make it centered, margin 0, auto. Let's check it out. Oh, you can see it's centered, it's larger, and it's very nice canvas now. Now we have a canvas. Let's draw a blue rectangle on it. The first thing we need to do is we should handle the canvas object in our JavaScript file. Let's do it. We should first define canvas, and we should handle canvas document get elements by ID, and we should write our canvas ID hello world canvas. And now we should handle the context var context equals canvas get context, two-dimensional context. There is also 3D context, but in this course we will use two-dimensional context. Now we have canvas and context. These are the core objects we will use in everywhere. Now we will draw the rectangle. Blue rectangle. As you know, canvas is a drawing activity, therefore we should first handle the brush with a color. Let's take the brush with the color. Context dot fill style blue. Now we have a blue brush, and then we can draw our rectangle with this blue brush. Context fill rect. This fill rectangle function is taking 4 arguments. First 2 arguments are the coordinates, last 2 arguments are the width and heights. Let's start with 10, 40, and 30 and 70 with a height. Now we draw our blue rectangle with our blue brush. Let's check it out. Now we have the blue rectangle on our canvas. As you can see, we can draw something on our browser without any dependency or any plugin. We are just writing simple JavaScript codes. If you want to draw one more rectangle with different color, you should take different color brush in your hand. Let's draw a yellow rectangle. Yellow rectangle. First, we should have different color brush in our hands. Fill style equals yellow. Now we can draw our rectangle, fill rect, with the coordinates 50, 30, and 60, and 30. Let's check it out. As you can see, we have different colored rectangle now. What did we do is we change our brush's color. The context fill style is the selection of the color of the brush. One more last thing I want to mention is the fallback of canvas. Canvas element has a fallback to be displayed in older not supporting browsers. You can write something or add an image between canvas tags to inform the users. Let's do it. This is our canvas tags. Between canvas tags, you can write something. This is fallback message for old browsers. This is not visible in the canvas supported browsers. This is only visible for old browsers which are not supporting canvas. This is a fallback mechanism to inform users about canvas support of their browsers. That's it for now. We will start drawing lines in next lesson. Be ready! Hello everybody! In this lesson, we are going to draw lines on canvas. In previous introduction lesson, we didn't write a complex code and we kept it very simple. But from now on, we will write our code for real life. Now, the most important thing we have to consider is the page load. Canvas is a DOM element and it should be loaded before our JavaScript code will try to handle it. In your local machine, in other words, in your computer, there is no problem with this code. There is no problem. We can start by writing this code. But there is a potential problem with this in real life. If some page loading problems or latency issues exist on the page, your code will probably crash because you will be trying to reach a DOM element before it's loads. To prevent these issues, our codes should wait the page load and then they should be executed. This means that we have to follow the page load with a function. There is a built-in function for this, window onload function. Inside of this function will be executed after page load. This means that inside of this code block is safe zone for us. Now we can write all of our codes inside of this code block. Let's do it. Now we are in safe zone. We can start to draw our line step by step. First, we will start to draw our line with beginPath function. Context beginPath. This function is not drawing anything. It discards the previous path and lets you starting a new path. Without it, you could append your current drawing to previous one. It's very dangerous for drawing something without it. There might be some side effects. You might see some code samples without it, but I'm strongly suggesting that you should use this function. Reset the context state. Now we should define our line's starting point. Let's define it. Context, move to function is taking two arguments, which are the coordinates of starting point. starting point of line. Let's give some values to starting point of the line. I would like to give 30 and 70. Now we can define the endpoint of the line. Context line 2. This function is also taking two values, x and y, the coordinates, endpoint of the line. And I would like to draw a straight line. Therefore, I will increase the x coordinate. I will keep the y coordinate same. Then I would like to give 130 for x and 70 for the y to end coordinate. Let's check the canvas. Look, there is nothing on the canvas. There is something missing. We defined the beginning point, end point. We haven't drawn the line yet. Now we should draw the line with this specification. Stroke. This function draws the line. Now we can check the canvas. Look, we draw a line on canvas. It looks awesome. We draw our basic line step by step. But what should we do if we want to change the color of the line? As you know, we draw our line with stroke method. It's the function which is like a pen or brush that draws the line between two defined points. So we need to change our brush's color. Let's do it. Context, stroke, style. Let's change our line's color to red. Now we have a red brush which will draw our lines red. Let's check it out. Great, it's red now. And lastly, what should we do if we want to change width or thickness of the line? Let's do it. Color of line we need to add line with parameter, for example 10. Thickness of the line. Now our line's width is 10. Let's check it out. Awesome, we have a border line now. In this lesson, we learned how to draw a line on canvas step by step. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw complex lines. Let's start. Last lesson, we learned how to draw simple line. You may remember these code pieces and output. However, our needs may change. We may need to draw some special shapes. There is no built-in functions for this. So, what should we do if we want to draw those complex shapes? The answer is simple. We should draw lines as many as possible to build our complex shape. Let's draw a simple zigzag on our canvas. Let's start. As you remember, in previous lesson we drew simple line. Let's get the code from previous lesson. Now we are in our current project. Drawing multi-lines. Let's start by drawing a simple line. I'm pasting code from previous lesson. Remove this and check the code. Let's check the output on canvas. Hey, look, we have a line now. Let's change the coordinates of this line to build our zigzag's first line. I would like to make it 30 and 30. And I would like to increase my zigzag 50-50. I mean, it will be 80 and 80. Let's check. Oh, look. This is the first line of our zigzag. Let's continue to draw our zigzag. Then we need to draw some line like this. Then this, then this. Let's continue. Let's copy this code. Paste. And update the coordinates. 80. 80. End point of this line should be starting point of this line. And increase the coordinates. It should be 130 and we have to decrease the y coordinates because this line go to up. Let's check. Oh, look, we are drawing our zigzag step by step. Let's continue to draw line. Let's draw to the third line. As I said before, this coordinates should be endpoint of the previous line, 130, 30. And I need to increase the x coordinates, and also in that time I need to increase the y coordinate. Let's check. We are doing perfectly, and I want to add one more line. This should be endpoint of previous line, 180 and 80, and I would like to increase the x coordinate and decrease the y coordinates. Hey, look, we have a zigzag now. It's awesome. But you may also notice that our code has become more complex just for drawing 4 lines. There are many repetitive code pieces in here, and we draw completely independent lines. Imagine the case if we have 30 lines and more. It's obvious that we should change our manner. Let's redraw the zigzag with a different way. Let's start. I'm removing all of the code pieces and just leave a one line. And we have a one line now. That's it. This is our first line. We have a one line now. As you know, we are defining one beginning point and one ending point for drawing a line. This is beginning point, this is the end point of line. So, what will happen if we add more endpoints to here? For example, if I add one more endpoint to here, what will happen with these coordinates? Let's refresh the page. Look, we drew a second consecutive line. Let's draw our zigzag with this way, adding by endpoints. This is our first point, this is our second point, and this will be our third point. Let's check. And I need to add 2 more points. It will be 180, and if you remember the previous implementation, these were the previous coordinates that I'm taking from early and early. Let's check it out. Look, we draw our zigzag with shorter and more clear code. You can increase the endpoints and you can draw whatever you want. It's very useful and easy way to draw complex shapes with multiple lines. They are consecutive lines. You can see our code has become more clear and readable. You got the idea. See you on next lesson. Hello everybody. In this lesson, we are going to learn a line attribute, the line caps. When we draw lines on canvas, we have a control how the endpoints look like. We are using line cap attribute how the endpoints of the line are drawn. So, the line cap attributes can have 3 different values, but the default value, round, and the square. Unless otherwise specified, the line cap attributes defaulted to but value. What does it mean? If you do not specify a line cap value, it's automatically defaulted to but. To understand the line cap attribute better, let's draw 3 parallel lines and set the values one by one and see the results. Let's draw the first line. Context, begin path. And also I would like to define a color to my line. Context, stroke style, red. And let's set the line width as 10. Context, line width 10. And let's set the beginning point of my line. Context, move to. Arbitrarily, I would like to set the beginning point as, for example, 100 and 100. And let's set the endpoint of the line, context, line 2. I would like to draw a straight line, therefore I will only increase the x coordinate, 300 and 100y. And let's draw my line, stroke. Let's check the canvas. Awesome, We have a red straight line now. Let's add the second line. I will draw a parallel line, therefore I will only increase the y coordinate. And also I would like to change the color, blue. I will increase the y coordinate as 125, 125. Let's check the second line. We have second line now. Let's add the third line. Let's copy the second line and add the third line. Again, change the color green and update the coordinates. And let's check the canvas. We have 3 parallel lines now. The gap between the lines are very small because I would like to make a comparison between the line cap values more clearly. Therefore, the gaps are very small. Let's set the line cap values one by one. First, let's set this one's line cap value, line cap, but. Let's check the canvas. You can see there is no difference. But value is the flat edge. Let's set the round value to second line. Context, line cap, round. Let's check the canvas. You can see that the endpoints of the second line have become rounded. A semicircle is added to endpoints. The diameter of the semicircle is half of the width of the line. Don't forget this. Half of the width of the line. If you increase the line width, the semicircle diameter will be increased. And lastly, set the square value to our third line. Let's do it. Context, line cap, square. Let's refresh the page. You can see that a rectangle is added to endpoints. Its length is half of the width of the line. And also you may notice that the square and round values are increasing the length of the line. You should be aware of this. If you set round or square, your line length will be increased. Therefore, you should use them carefully. That's it for now. See you on next lesson. Hello everybody. In this lesson, we are going to learn an advanced line attribute, the line joins. Let's start. The line join attribute on canvas specifies how lines are joined when their endpoints meet. This attribute can have 3 different values. Meter, the default value, bevel, and the round. As I said at the beginning, the default value of the line join is meter. Let's draw complex lines and set the line join attributes on them one by one and see the differences between the line joins. Let's start. Let's draw first line. I will use meter value for line join for this line. And let's start context, begin path, context. Let's define a line width, 20. Context, move to. Let's define the beginning point of our line. I would like to define 30 and 30 as always. Then let's define the second point of line, line 2. I would like to draw a straight line, therefore I will increase the x coordinate for this line. And context, stroke. Let's draw the line. Let's check the canvas. Okay, we have a straight line now. Then I would like to continue to drawing this line like this direction. I will add one more endpoint, context, line 2. The x coordinate will be same, but the y coordinate will be increased, 130 for example. Let's check the canvas. We have a second line now. Let's add more lines onto this shape. I would like to increase the endpoints, context, line 2. And I would like to decrease the x coordinate and keep the y value same, 100. And also I would like to add one more endpoint, context, line 2, 30 and 330. Let's check the canvas. Awesome. We have this question mark like shape now. Let's set the line join value as miter. Context, line join, miter. Let's check the canvas. Look, there's no difference. It was already miter because the miter is the default value of the line join attribute. So let's draw a second line and set its line join attribute as bevel. Let's copy this line. Second line, bevel. And also set this value bevel. Increase the x and y coordinates by 30 points. 60, 60, 60, 60, 60, 60. And also I would like to set a color to this line because I would like to make a clear comparison between the lines. Context, stroke, style, red. And let's check the canvas. Look, we have a second red line now. You can see that the edges have become diagonal at the join points. The bevel value has a diagonal effect on join points. These are the diagonal edges, the bevel. And lastly, let's draw a third line. Let's copy this second line. Third line, round. I would like to update the color as blue, and also I will change the line join as round. Let's update the coordinates by increasing 30 points again. 90, 90, 90, 90. Let's check the canvas now because we defined our third line. Let's update. Look, we have a third line with a blue color and rounded corners. You can see the edges have become rounded at the line join points. The round value of line join has a round effect on the join points. Now you can see the differences between line joins values more clearly and understand the basic idea behind the line join. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to add shadows to our paths. Let's start. To create shadows on our paths, we are using 4 specific shadow attributes. Shadow color, which is defining the color of our shadow. Shadow offset x, shadow offset y. They are the offset amount of the shadow. In other words, the distance of the shadow from the original objects. Don't forget, they can have positive or negative values, which determines the direction of the shadow, and shadow blur, which is defining the amount of applied blur on our shadows. And also, if you know the CSS box shadow property, you may also be familiar with these attributes and their functionalities. This is an extra note for you. So, to understand the attributes better, let's draw a small line and add shadow to it. Context, begin path. I would like to define the color of line as red. And also I would like to add line width as 20. Let's define the beginning point of our line as 160, and let's define the endpoint. Context, line 2, 260. I would like to draw a straight line, and let's draw the line. Context, stroke. Let's check the canvas. Nice, we have a small red line now. Let's add shadow to this line. As we mentioned before, a shadow can be created by using these 4 shadow attributes. Let's use them one by one on our line and create the shadow. Let's use them. Context, shadow color as black. Don't forget, you can use whichever color you want in here. Context, shadow, offset X as 10. Context, shadow, offset Y as 10. And lastly, I would like to define the shadow blur. Shadow blur as 5. Let's check the canvas. Look, we have a shadow on our line now. It looks very nice. And you can see that a shadow can be added very easily by using these 4 attributes. Let's copy this line and create more shadow variations. I want to have 3 more lines. Let's do it. Let's label this one as 1 and copy this line. 2, 3, and 4. Let's name them 2, 3, and 4. I'm creating more lines because I would like to create more shadow variations. You will see it soon. Wait. Let's update the coordinates. 3, 5, 3, 5, 4, 5. 200, 200, 3, 5, 4, 5, 200, and 200. Let's check the canvas. Look, we have clone objects now. They all are same. Their shadows, everything are same now. Let's update the shadow offset attributes and handle different shadows now. As I said before, shadow offset attributes can be positive and negative. I would like to make these lines shadow offset X as negative. For the third line, I would like to make shadow offset Y attribute as negative. And for the last line, I would like to make all of the offset values negative. Let's check the canvas. Look, we have different shadows now. If we set the shadow offset X attribute as positive, it will move the shadow to the right. You can see these are the offset X attribute positive ones. If we set the shadow offset X attribute as negative, it will move the shadow to the left. You can see the negative X ones. If we set the shadow offset Y attribute as positive, it will move the shadow to bottom. You can see these are the Y positive ones. And lastly, if we set the shadow offset Y attribute as negative, it will move to the shadow to the top. These are the Y negatives. So let's update the color of our shadows and their blur values. Let's make the color as blue. Second one as green, third one as yellow, and last one as brown. And also I would like to increase the blur values as 10, 10, and 10. Let's check the canvas. Look, we have amazing shadows now. You can do whatever you want with shadows. You got the idea behind the shadows now. See you on next lesson. Hello everybody, this is a practice lesson to reinforce what we have learned in previous lessons. We will draw complex objects by using lines, and then we will improve these objects with line cap, line join, and shadow attributes. Let's start. You can see that there is a small cheat sheet here. We will use these attributes on our examples. This is a quick refresher note. We will benefit from this note. Okay, let's start by drawing our first object. I will draw a Z object with lines. Let's draw. Context, begin path. I would like to define the color as red, stroke style, red. I would like to add a line width, 15. And then let's define the beginning point of our path. Context, move to. I would like to define as 60 and 80. And let's continue to draw our line. Context, line 2, 160 and 80. And let's draw the line, context, stroke. Let's check the canvas. You can see we have a straight line now. Then I would like to draw a new line from here to here. Let's draw. Context, line 2, 80 and 180. Okay, let's draw the third line from here to here and complete the Z object. Context, line 2, 180 and 180. I calculate the coordinates before, therefore I can easily set the coordinates. Let's check the final result. Refresh the page. Look, we have a red Z now. We did it. Let's draw another Z object now. But this time we will draw a reversed Z object. Let's do it. Label this one as first Z object and copy this line. Second Z object. Update the color as blue. And remove this line. Then update the coordinates 340, 80, 240, 80. Let's check the canvas. You can see we have a straight line now. The only difference between this straight line and this straight line is the beginning points are totally different. This line's beginning point is here. This line's beginning point is here because we will draw a reversed Z object. Let's continue. Let's set the third line, context, line 2, 340 and 180. Let's check. Awesome, we are almost done the reverse Z object. Let's set the last line, context, line 2, 240 and 180. Look, we have amazing objects now. I would like to draw one more last Z object. Let's draw. Let's copy the first one again. Add here as third Z object. And let's update the coordinates. 4, 2, 8, 5, 5, 2, 8, 4, 4, 180, and 5, 4, 180. Let's check the result. Oh, there's one more thing. I would like to update the color as green. Green. Now let's check the result again. Awesome. We have 3 different objects now. Let's start to enhance these objects. First, I would like to use line cap attribute. You can see that line cap attribute can have 3 different values. Let's use these values onto our objects one by one. Let's do this. Context, line cap as but. Context, line cap as round. And lastly, context, line cap as square. Let's check the results. Refresh the page. Look, you can see the differences. This is but, this is round, and this is the square. But has no effects on the object because it's the default value. Round line cap value adds a semicircle to the line cap points, you can see. And the square line cap value adds a rectangle to the line cap points, you can see. It's longer than the original one. Very nice. You may notice that these corners are so sharp. These are the line join points, you know. They are so sharp. Let's change them with the line join attribute. You can see that the line join attribute can have 3 different values. Let's use them onto our objects one by one. Context line join as miter, the default value. Context line join as round, and lastly context line join as bevel. Let's check the results. Look, our objects have become different compared to beginning drawings. These corners have become different. And these corners are still same because it's the default value, the miter. And there's one more thing we will do. Let's add shadows to our objects. Yes, shadows. You can see that we will add shadow by using these 4 shadow attributes. Shadow color, shadow blur, shadow offset X, and shadow offset Y. Let's use them. Context shadow color as black. Context shadow offset X as 10. And lastly, context shadow blur as 10. Let's copy these 4 attributes to other lines. And let's check the results. Look, our objects have become fascinating. We improved them so much. They look like very different now. Our shapes are almost 3D with the shadows now, you can see. And lastly, we can also play with the shadows a little bit more. Let's do it. Let's change the shadow color as blue, yellow, and red. Let's check the results. Look, they are totally different now. You can do whatever you want. You can play with the attributes and handle different results by yourself. It's up to you now. You got the idea. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw arcs and curved lines on our canvas. Let's start. We are going to use arc function to draw curves on our canvas. This function is taking 6 arguments. The first 2 arguments are the center coordinates of the circle. The third argument is the radius of the circle. And the next 2 arguments are the angle values of our circle. In other words, the amount of circle between these angle values. Don't forget, angle values are in radians, not degrees. And the last argument is an optional value, which determines the direction of our arc. Its default value is false. So, we are drawing our curves anti-clockwise direction. Let's examine the arc function more detailed and our drawing plane step by step. First, we should define the center coordinates, like this. X and Y is 75 and 45. Let's set them into our function, like this. Now we have a center point with these coordinates. It looks like this. This is the center point of our circle. Then, add the radius value as 50. Now we have some values which are 75 and 45 center coordinates, 50 radius value. This is our coordinate system. This point is starting point of our coordinate system. It's the same as like trigonometric coordinate system. Everything is again in radians. You can see trigonometric coordinate system is so similar to our coordinate system. Everything is again in radians. But trigonometry plane is following anti-clockwise direction to draw something. In our coordinate system, we are following clockwise direction, like this. This is our direction to draw something. So let's draw a half circle. First, we should define our start angle and end angle arguments in our function. I will define our start angle is 0 and end angle is 180. So after set these values, we will have this half circle. 0 is the starting angle, 180 is the end angle, and drawing in clockwise direction will result with this half circle. You can change the values and draw different arcs, like this. I only changed the start angle. It's up to you. You can change the values and handle different results. Lastly, I want to set counterclockwise argument as true in this example. Let's set argument as true and see the result. You can see it draws in anti-clockwise direction starting from 90 to 180. It's anti-clockwise direction if you set the argument as true. So this is the main idea behind the arc function. Let's start to write our codes. First thing, I will define a radian variable to decrease our code's complexity. Variable radian math pi divided 180. This is a mathematical equation. Let's start to draw our curve. Context, begin path, and define a color context stroke style as blue, and set the line width as 10. Now we can use the arc function context arc, and we can use the arc function now. Let's arbitrarily define the center coordinates 100, 100, and set the radius as 50, and I would like to define the start angle as 0 radian, 0 radian, and also I would like to define the end angle as 180 radian, and define the anti-clockwise direction variable as false. Then draw our path and see the results. Let's refresh the page. We made our theoretical examination into true. Awesome. Let's create a new one. First arc. This is our first arc, and copy this code and create our second arc. Set the color as red. Update the coordinates 300 and 200, and first check the result. Look, we have a second arc now. Let's update the angles. I would like to update the start angle as 45 and end angle is 135 radian. Let's check the results. Look, we have totally different arc now. It's the arc between our defined angle values. So it means you can draw any kind of circular arcs with arc function between your defined angle values. It's awesome function. And lastly, let's change the clockwise argument as true and see the result. Let's copy the second arc. Third, set the color is green and update the coordinates. For example, update the y value 100. First check the result. Awesome, we have a third arc now. Let's update the anti-clockwise direction of argument as true. Let's check the page. Look, our new arc is drawn in anti-clockwise direction with the same angle values between 45 and 135. The only difference between these arcs are the direction of drawings. Now we have a good understanding on drawing arcs. See you on next lesson. Hello everybody. In this lesson we are going to learn how to draw quadratic curves. Let's start. In previous lesson we have learned how to draw circular curves with an arc function. But what should we do if we need to draw more flexible curves like this? You can see this is not a circular curve. We cannot use the arc function to draw this. So what should we do? We will use the quadratic curve function to draw this kind of specific curves. This function provides more flexible and natural curves. Okay, let's examine this function more closely. This is our new curve function. The function is taking 4 arguments: Ctrl X, Ctrl Y, and X, and Y. The first 2 arguments are the coordinates of the control point, and the last 2 arguments are the coordinates of the endpoint of the path. So, what is this control point? It's totally new thing for us. It's also the point which pulls our curve towards itself. It's also the stretching point of our curve. To understand more clearly, let's examine the quadratic curve function in more detail. Let's start to learn by drawing a quadratic curve. As you know, this is also a path, so we should define the beginning point at first. This is our beginning point. Then we need the end point. This is also end point. We have 2 points now, beginning point and end point. These are our points. Let's draw a simple circular curve between these points, like this. It's very nice. But we need a custom shape, not a circular curve. So let's start. First, we should define the control point, like this. Now we have 3 points: beginning point, end point, and the control points. We will draw our specific curve between these points. To draw our custom quadratic curve, our canvas needs to define the peak point of the curve. This will be different curve and canvas needs a peak point to draw it. So the canvas starts by drawing lines between control point and the beginning and end point, like this. Then it finds the middle of these lines, like this. After determination of the middle points, the canvas will draw a line between these points, like this. Lastly, the middle of this line will be defined as our curve's peak point, this point. This is the process how the quadratic curve will be drawn. This point will be the peak point of our stretched curve. The curve will be drawn between these points, beginning point, peak point, and end point, like this. You can see it's now more elliptic curve. This is also the idea behind the quadratic curves and the control point. You can see the different variations with different control points. It's up to you and your design needs. So now we have a theoretical knowledge about quadratic curves and the control point. This is the idea behind the drawing a quadratic curve. We need a control point and stretch the curve via this control point. Okay, let's start to write our codes to convert our theoretical knowledge into in practice. Let's start. This is our small cheat sheet again. Let's start by context begin path, as always, because it's a path. Let's define the color as red, and I would like to add a line width as 10. And let's define the beginning point, context, move to. I would like to set the beginning point as 200 and 250. And now we can use the context quadratic curve function. Let's copy this line and paste here. Let's define the arguments. First, we need to define the control point. I will define as 300 and 100 y, and the endpoint as 400 and 250. And let's draw the curve, context, stroke. Let's check the results. Look, we draw our custom curve now. It looks very nice. It's very important to know that the control point plays a vital role to draw our custom curves. Let's play with the control point and handle different results. Let's decrease the x-coordinate of the control point as 100. You can see our curve is totally different now. We can try to increase the x-coordinate. It was 300 and I would like to make it 500. Oh, you can see it's also so interesting now. Let's continue to change the coordinates. Let's make this 10. You can see our curve is taller now. Let's change the coordinate again as 110. You can see our curve is shorter now. So the shape is drawn depending on our control point selection. This is the idea behind the quadratic curves and the control point. You got the point. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw Bezier curves. In other words, the cubic curves. Let's start. You may remember we have just learned how to draw quadratic curves in previous lesson. But what should we do if the quadratic curves don't meet our needs? For example, we need to draw a custom curve like this. What should we do? We cannot use the quadratic curve to function draw this. We will use the Bezier curve to function to draw this complex curve. The major difference between the Bezier and the quadratic curve is the Bezier curve has two control points. This means there are two stretching points on our curves. So we have more control on the curves. This is our new curve function. It takes 6 arguments. First 2 arguments are the coordinates of the control point 1. The second 2 arguments are the coordinates of the control point 2. And last 2 arguments are the coordinates of the endpoint of the path. Let's examine the Bezier curve in more detail by drawing a curve step by step. Let's start. First, we should define the beginning point and endpoint of our path, like this. These are our points, beginning point and endpoint. Now we can define our control points. Let's define the control point 1 and the control point 2. You can see we have 4 points at the moment. The starting point, the control point 1, the control point 2, and the endpoints. You may remember that we are defining a peak point for drawing a quadratic curve. Now we need to define 2 peak points for drawing our Bezier curve. This is the idea behind the Bezier curve. We have 2 control points and we have 2 peak points. The process to define these peak points are similar to quadratic one. First, the canvas starts by drawing lines between these points, like this. We have lines between these points now. Then the canvas defines the middle point of these lines, like this. We have the middle points of the lines now. After determination of middle points, the canvas will draw lines between the middle points, like this. And the middle of these lines will be pointed like this. These middle points will be defined as our peak points. So, let's draw our curves between the starting point, peak point 1, peak point 2, and the end point, like this. We draw our Bezier curve. More clearly, our Bezier curve will look like this between these 4 points. Beginning point, peak point 1, peak point 2, and the end point. This is the process how the canvas draw Bezier curves. It's more flexible and control curve style. You can see the different variations with different control points. It's totally up to your control point decision according to your drawing needs. So now we got the main idea behind the Bezier curves. Now we have more control points and now we have more control on the curves. Let's start to draw a real Bezier curve by coding step by step. Let's start context, begin path, and I would like to define the color as red as usual. I would like to add a line width as 10, and let's define the beginning point of our paths. Move to. I would like to define the beginning point as 200 and 250. And now we can benefit from this cheat sheet. Let's copy this code piece. And let's define the control point 1, control point 2, and the endpoint step by step. I would like to define the first control point as 100 and 100. Then I would like to define the second control point as 500 and 100. Endpoint will be the 400 and 250. And let's draw the curve. Okay, let's check the canvas. Look, we have so interesting curve now. It stretched from this direction and this direction. You can see we draw an interesting curve. Let's play with the coordinates again. Let's change the coordinate as 210. I'm changing randomly 50 and 100 and 150. Let's check the result. You can see we draw a curve like a signature of some people. So you got the idea. You can draw whatever you want with this function. This is the most comprehensive function to draw curves on the canvas. The most important thing is to define the control points accurately to draw your intended curve. This is very important. You should calculate the control points carefully and then you should use them. That's it for now. See you on next lesson. Hello everybody, this is a practice lesson for our newly learned curve functions. We will draw a heart by using quadratic and Bezier curves. Let's start. Okay, before starting to draw our heart, I would like to explain these two functions. Draw quadratic curve, draw Bezier curve. I created these two helper functions to ease for drawing our curves. These functions are drawing our curves with their control points. The control points are visualized with a circle and lines. These are the curves which are taken from our previous lessons. Let's check the canvas. Look, you are also familiar with these curves. This is our Bezier curve and this is our quadratic curve. Let's use our new functions to draw these curves again and to see the difference between them. Let's use draw quadratic curve. The draw quadratic curve function is taking 8 arguments. The coordinates of starting point, the coordinates of the control point, the coordinates of the end point, and the curve color and the curve width. These are the optional ones. Let's draw 500, 250, 600, 50, 700, and 250. Let's remove this part. Then let's use the draw Bezier curve function. The Bezier curve function is taking 10 arguments, the coordinates of the starting point, the coordinates of the control point 1, the coordinates of the control point 2, the coordinates of the end point, and the curve color and the curve width. These are again options. Let's draw Bezier curve 200, 250, 100, 100, 500, 100, 400, and 250. Remove this part again. You can also examine inside of this function step by step. It's up to you. You can do it by yourself. Anyway, let's check the canvas. Refresh. Look, our control points are visualized. These are the control points of the Bezier curve. This is the control point of the quadratic curve. Everything is more clear now. You can use these functions to calculate your control points. It's very nice to use. Okay, now we can start to draw our heart. First, I would like to remove this quadratic curve. Remove. That's it. I would like to use Bezier curves top of the heart. First, I would like to draw right top of my heart. Therefore, I need to move this Bezier curve to here. First, I would like to move to right, then I would like to move to top. Let's do it. First thing I would like to do is increase the x-coordinates by 200 or 230. Let's update the coordinates. Let's check the canvas. Awesome, we moved our shapes to right. Then we need to move the shape to top. Let's move. I would like to decrease the y-coordinates by 100 or 120. Update the coordinates. I don't want to decrease the control points y-coordinates more than 100 because I would like to see the control points on the canvas. Therefore, I will set the control points y-coordinates as 10. Then let's update this one as 130. Let's check the canvas. Awesome, we moved our shapes to top. Then I would like to update the coordinates of the control points. I would like to move this to a little bit right. Then I would like to move to this a little bit left. Let's update the coordinates. Let's check the canvas. Awesome. Lastly, I would like to do one more thing. I would like to update the coordinates of the endpoint because we need more stretched curve now. I would like to update coordinates of this endpoint. Let's do it. Let's do it as 7, 8, 8. Look, we completed our heart's right top. Now I would like to draw the left top. We are so lucky, we also draw the right top. The only thing we need to do is mirroring this one. We will draw a left top, the same thing on here. The only thing, we will update the coordinates of this curve. We need to mirror this curve. Let's do it. Let's copy this. Paste here. Then I would like to label them right, left. Okay. The first thing, I don't update the starting point. It can be same. This is our starting point. Then I would like to define the endpoint. The difference between these x coordinates will be the same. Therefore, I will use the same difference. Let's do. The difference between this coordinate and this coordinate is 240. Then I would like to use the same difference between this coordinate and this coordinate. This will be 190, and the y coordinate can be stay same. Let's check the canvas. Awesome, we defined the starting point and the end point. Then we need to update the coordinates of the control point. Let's update them. First, I would like to draw a control point to here. Then I would like to draw a control point here. Let's update the coordinates. I would like to define as 400 and 190. Let's check the canvas. Awesome! We draw the top of our heart. It looks very nice. Now we need some curves to complete our heart, because we need some curve like this and like this. I think we need to select a point to here as an endpoint, and then we can draw our quadratic curves between this point and this point. I think coordinates of this point will be as the same x coordinate of here and a little bit more than y coordinate of this beginning point. Let's do this. First, I would like to draw the right one. Draw quadratic curve. The starting point of this quadratic curve will be the end point of this Bezier curve. So this means this and this. Then I would like to define a control point randomly. I don't know, 600 and 400. Then let's define the endpoint as 500. Let's check the canvas. Look, we drew a quadratic curve and we are almost done. The only thing we need to do is we have to stretch our curve a little bit more, like this. Let's update the coordinates of the control point. Let's update the coordinates as 7 and look, we are almost completing our heart. The only thing we need to do is mirroring this quadratic curve. Let's do it. Let's draw quadratic curve. The starting point of this quadratic curve will be the end point of this Bezier curve. And we know the end coordinates now. This one. The only thing now, we need to define a control point. I would like to define a control point arbitrarily 200 and 400. Let's check the canvas. Nice, but I think I can update the coordinates of this control point a little bit up like this, because it's not the same, it's not mirrored. Let's do it as and Okay, we draw our heart and it looks like awesome. It's very nice. We also used quadratic and Bezier curves to draw this heart. And also we used our new functions to draw this heart. These are very helpful functions because we can easily update the coordinates of our control points. They are also visualized. Okay, this is the main idea behind these functions, to determine the coordinates. Now we can draw our heart without these functions. Let's do it. Heart, context, begin path, context, stroke, style, red, context, line width, 5. And then I would like to define the beginning points as 430 and 130. Then I would like to Bezier curved function. As you may remember, let's comment out these ones because I would like to draw the heart step by step. These are the reference ones. 7, 10, 10, 6, 7, 1, 8, 0, and context stroke. Okay, we have the right top of our heart. Then I would like to draw this part. Context, quadratic curved function. It will be the, let's copy this part. Awesome, we draw half of our heart, then continue to draw. Let's draw this part. Context, quadratic curved function. First we need the control point. This is our control point. Then we need two endpoints. Our starting point will be our endpoint. Let's check. Awesome. The only thing we will draw this part. Let's draw. Context, Bezier curved function. First, we need to swap the control points. Let's copy these control points and swap their positions. Because now we are drawing from the different direction, then we need to define the endpoints. Look, we draw our heart perfectly. It looks very nice. Now you got the idea. You can use the draw quadratic curve and the draw Bezier curve functions to determine the coordinates of the control points. You got the idea of these helper functions. Now it's up to you. You can improve this heart or you can draw different shapes. See you on next lesson. Hello everybody. In this lesson we are going to learn how to draw rectangles on canvas. And also we will learn some built-in rectangle functions. Let's start. These are our rectangle functions that we will learn one by one. Rect, fill rect, stroke rect, and clear rect. You can see each of these four functions takes the same parameters: x-coordinate, y-coordinate, width, and height. X-coordinate and y-coordinate are specifying the position of our rectangle. These are the left top coordinates of our rectangle. Width and height are specifying the size of our rectangle. That's it. Let's start with rect function. Let's move these ones to bottom. And let's start with rect. It's a very simple function. It determines 4 points and then it draws lines between these points. At last, it closes the path. So this means we can fill this object with a color because it's a closed object. We can only fill the closed objects because otherwise the color will leak and all of the canvas will be filled. We only want to fill the objects. Okay, let's draw our rectangle. Context, rect, 50, 200, 200, 200. And let's draw it, context, stroke. Let's check the canvas. Look, we have a rectangle on our canvas. Let's try to improve this rectangle with our line attributes. Let's define some line attributes. Context, stroke style as red. Context, line width as 11. Context, line join as round. Let's check the canvas. Look, we have an amazing rectangle now. Awesome. But there is one more thing. What should we do if we need to fill this rectangle with a color? For example, blue. I would like to fill this rectangle with a blue color. First, we need to define the color of fill. Context, fill style as blue. Then we will use the fill function to fill rectangle. Use context fill. It's very similar to stroke function. First we define the color and then we use the function. Let's check the canvas. Look, we have a full rectangle now. It uses every rectangle attributes. It's very nice. Okay, let's continue to learn rectangle functions. Now we will learn the fill rect function. Let's get the function and move other ones to bottom. Okay. This function draws a filled rectangle which can be specified a fill style. It's very simple and easy function. Let's use it. Context fill style as green and context fill rect. Let's specify the arguments 300, 200, 200, 200. Let's check the canvas. You can see this function is just drawing a filled rectangles without borders. It's equivalent to rect function followed by a fill without the stroke options. It's very easy and short form of to draw a filled rectangles. Okay, now we will learn the stroke rect function. Let's get the function. Let's move the last function to bottom. This function draws a rectangular outline which can be specified with a stroke style, line width and line join attributes. Let's use this function. Context stroke rect. I would like to specify the coordinates as 550, 200, 200 and 200. And also I would like to specify the rectangle. Let's define a line width, context line width as 3. Then I would like to define a color, context stroke style blue. Then I would like to define the line join square. Let's check the canvas. Look, the function strokes a rectangle with our specifications. It's equivalent to rect function followed by a stroke and line attributes without a fill option. It only draws a frame. This function only draws a rectangular outline without a fill. Don't forget this. Only rectangular outline. Okay, there is one more rectangle function that we will learn. This is clear rect function. This is a function to clear specific rectangular area on canvas. It's like an eraser. Let's use this function and understand better. We don't need a specification for this function. There is no color or anything. It's just an eraser. Let's use it context clear rect. Then I would like to specify endpoints as 100, 100, 200 and 200. Let's check the canvas. You can see the cleaned rectangular area on the canvas. We defined our eraser and it cleaned this rectangular area. That's it. There is one more thing. This function is also commonly used to clean entire canvas. Let's do it. Let's delete everything on the canvas. we need to specify the starting point as 0 at 0. We need to define the width of eraser as the canvas width and height is canvas height. Let's do it. 0, 0. These are our canvas size. Let's use this. 900 and 600. Let's check the canvas. You can see our eraser clean all of our canvas. This is also a very common way to clean canvas. That's it about the rectangles for now. See you on the next lesson. Hello everybody, this is a practice lesson for what we have learned recently. We are going to draw a chessboard on our canvas. Let's start by examining a chessboard. Look, this is a real chessboard. You can see there are many squares. There is a square outline. It's the biggest square. It's the frame. And there are small squares, the cells. This is the main structure, you can see. First, we will draw the frame, the outer square, and then we will draw the cells. Let's start by drawing the frame. Before starting to draw our chessboard, I would like to mention these variables. I defined two variables to chessboard. One of them is light cell color, other one is dark cell color. These variables will be used as a color for our cells. Let's start. Frame, context, stroke style, black. You may remember from previous lesson, we have a rect function to draw outlines. Stroke rect. Let's use it. Context, stroke, rect. First, let's define the coordinates. 250, 100, 400 and 400. Let's check the canvas. Look, we draw outer frame of our chessboard. Now we can draw our cells into this outline one by one. Let's start. Cell 1. Context, fill style. First cell will be light, therefore I will use the light cell color variable, light cell color, and context, fill rect. Let's define the coordinates. Let's check the canvas. Look, we draw our first cell. Let's draw the second one. Copy this one. Cell 2. The color will be dark. And the X will be increased by a width. Look, we draw our second cell. Let's draw the third one. Let's copy the first one. Third. Let's increase the coordinate. Okay, we are doing good. Let's add the fourth one. Copy this one. Then increase the coordinates. You can see we are doing very well, but it will be very difficult by doing this way. We should draw 64 cells with this way. It will be very difficult. We should change our approach because otherwise it will be very mass code. Let's change our approach. Let's use a for loop to draw our rows. Let's comment out this part. And let's write a for loop. First row for okay, then let's copy one of the cell. You should notice that when we drawing cells, we are increasing the x coordinate for the same row. Let's increase the x coordinate plus I times 50. The only difference, I is starting from 1. Therefore, we should decrease this one as 20. Let's check the canvas. Awesome. We draw a row, but with the same color. We should update the for loop. As you can see from the previous code, the odd cells are light and the even cells are the dark. Therefore, we should define a condition. If I is even, this means if I is even, we should define the color as this. If not, we should define this color. It's a very nice way to do. First row. Okay, we did it. Okay, let's check the canvas. Look, we draw first row of our board. Let's draw the second row. Let's copy this part. Second row. And we need to increase the y coordinate. And also for the second row, we need to swap this thing to this thing. And also, because it should start with dark cell and then light dark, then it should be reversed of this one. And we defined everything. Let's check the canvas. Awesome, we draw the second row. Let's draw the third row. We can copy the first one and only update the coordinates. Third row, we should make the coordinates as 200. Let's check the canvas. You can see we are drawing our board perfectly, but our code is again becoming a mess. For loops, for loops, for loops, and we should define 8 for loops for this. So let's improve our code again. Let's comment out these parts. Let's change our approach again. Let's use a for loop, but not just a for loop. Let's use a nested for loop. For var x equals 1. This is outer for loop, and we need the inner for loop. Now, this part of the code will be run 64 times. Let's copy a cell. For example, cell 1. What did we do for this cell? We define an if condition, and the if condition will update the coordinates and the other things. Let's do the same approach. Let's copy this if condition. Remove this thing. I think it's okay, but there is no I now. We have x and y. What should we do is, we should add here to x plus y. Because we have a nested for loop now. It's okay, there is one more thing. The coordinates. We should use x and y here, because they should be dynamic. Let's do this, 200 plus x times 50 and 100 plus y times 50. Let's check the canvas. There's one more thing. I forgot to decrease this. Look, we draw our chessboard with a short and smart way. It looks awesome. We did it. Now you can play with the size, colors, coordinates to create different variations. It's up to you now. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw circular objects on canvas. Let's start. In contrast to drawing rectangular objects, there are not any built-in functions to draw circular objects. We will use the arc function to draw circular objects, and then we will fill these objects with the fill function. This is our arc function that we will use. First, let's draw a circle, full circle. Context, begin, path. Context, stroke, style. Let's set the stroke style as red. And I would like to set a line width as 15. And let's use the arc function, context, arc. Let's define the coordinates 450, 300. And I would like to set the radius as 150. To draw a full circle, we need to define the start angle and end angle from 0 to 360 radians. 0 radian to 360 radian. And lastly, false. And let's draw the circle, context, stroke. Let's check the canvas. Look, we draw our full circle. We have also learned this function before. But what should we do if we need to fill this circle with a color? We will use the same attribute that we used in the rectangle functions, fill style and fill function. Let's use it. Context, fill style, orange. We defined our fill color and let's fill the object, fill. Let's check the canvas. Nice! We draw our filled object. We have a full object now. It's a circular full object. Let's change the start angle of our circle and see the result. Let's make it 135. Look, it looks strange. But how can it be possible like this? We only changed the start angle. The steps are these. First, the canvas draw the circle between start angle and end angle, this circle. You can see. Then it closed the object from the starting point of circle to end point of our circle. The object is closed now. Lastly, canvas filled the closed object with a color. These are the steps how this object is drawn. Yes, it looks strange, but these are the steps. Because if the canvas does not close this object, the color will leak the canvas and all of the canvas will be filled. This will be a catastrophe for us. We don't want to have this. We only want to fill this object. Therefore, canvas doing this. And also there is one more thing. What should we do if we need to draw a filled circular object without borders? You can see there is a border. If we remove this border, you can see there is also predefined color border. What should we do? Our solution will be simple and smart. We will set the color of border same as the fill color. Let's check. Look, it's a solid object now. You might understand, we need to generate solutions according to our needs. You can also do by yourself. It's up to you and your needs. That's it for now. See you on next lesson. Hello everybody, in this practice lesson, we are going to draw a famous game character, Pac-Man. Let's start by examining our hero. This is our hero, the Pac-Man. You can see it has a unique shape, and we will be busy with this shape entire lesson. We will draw our hero with two different ways. Let's start with the first one. First way. In this way, we will draw our hero path by path. First, we will draw this line, then we will draw this arc, and then we will draw this line. At the end, we will draw the eye. Lastly, we will fill the shape with the color. Let's start. Let's call it body, because eye and body are different objects. Context, begin, path. As I said before, we will draw our Pac-Man path by path. First, we will draw the line. Context, stroke, style, red, context, line width, 10. And let's define the beginning point of our path. Move to 250, 250. And let's draw our line, context, line 2, 330 and 310. And let's draw context, stroke. Let's check the canvas. Look, we draw our first path. Let's draw the arc. There will be arc from here to here. Context, arc. First center coordinates, radius, starting angle 37 and end angle 333 and anti-clockwise direction variable. Let's check. Nice, paths are becoming more meaningful. Let's draw the last line. Context, line 2, 250 and 250. Let's check. Nice, we drew the outline of our object. Let's fill it with a color. Context, fill style, orange, and fill it. Let's check. Awesome. Let's hide the border. Orange, and remove the line width. Amazing. Our body is okay now. Let's add the eye to our object. Eye, context, begin path, context, fill style, black, and context, arc, 250, 210 as a radius, 0 radian to 360 radian. It will be a full circle and false. And let's draw context, stroke, context, fill. Let's check. Look, we did it! We draw our hero path by path. It looks awesome. It looks Pac-Man. Okay, let's draw our hero with a second way. Second way. You may remember, if we draw an arc and fill it with a color, the canvas closes the arc from starting point to end point to prevent the possible side effects of the fill. Let's draw an arc and fill it with a color. Context, begin path, context, stroke style, red, context, line width, S10, context, fill style, orange, and let's use the arc function, arc, 600, 100, 100 radius, from 0 radian to 130 radian, and false. Let's draw it, context, stroke, and let's fill it, context, fill. Let's check the canvas. Look, we draw our circular object, and also we can benefit from this feature to draw our hero. Let's draw two filled half circles with this way. This will be the object 1. Let's update the coordinates as the radian is 143 and endpoint is 323, and also copy this code and make the object 2, and also update the coordinates as 320 and update the radians as 37 to 217 radians. Let's check the canvas. You can see we have two filled half circles. Let's put these two objects over the top each other. Let's update the only y coordinates as the same y coordinate of this object, 250 and 250. Let's check the canvas. Look, we almost did it. Let's hide the border and draw the eye. We hide the border and let's copy this eye, previous eye, and update the coordinates. Okay, everything is okay. Let's only increase the x coordinates and let's check the canvas. Look, awesome! We draw our hero with another way. It looks very nice. We can also draw it with your own way, like our second solution. Everything on canvas is up to your imagination. Let's do it with your own way. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw polygons. Sadly, there is no way to draw polygons on canvas easily. There is not a built-in function or anything. We should do it by ourselves. This is a pentagon. You can draw it by line, like this. But you should spend so much time to calculate the coordinates and the angles. It's very difficult, and also this is not a good way because you might need to draw shapes with more than 10 or more edges. This is not an efficient way. Let's change our approach to a smarter way. We will formulate drawing polygons with mathematical methods. First, we will enclose our polygon with a circle, like this. Now we have a circle which covers our pentagon. Let's define the center of our circle and draw the coordinate system according to our center point. This is our center point and these are the axes, x-axis and y-axis. Now let's define the corner points of our pentagon. These are the corner points. We need to find their coordinates and draw lines between these coordinates. This is the main idea to draw a polygon. Let's start by selecting one of these points as a beginning point of our drawing. I would like to select this one as a beginning point. Let's draw a radius to this point from center, like this. And identify the angle between the radius and x-axis as alpha. This is the radius alpha. Now we can calculate the coordinates of our starting point according to these values. Let's make the vertical projection on the x-axis like this. Now we can calculate the coordinates with the trigonometric functions sinus and cosine. This is x value, this is y value. These are the differences between the point and our center point. So the coordinate of the point will be this. Center x plus x, center y plus y. This is the coordinate of our beginning point. Let's draw radius to other points, like this. The angle between these radius lines will be 360 radians divided 5, because we have 5 sides of pentagon. With a more generic formula, the angle between these lines will be 2 mat pi divided h count. Let's define this amount into a variable as angle. So this means these are the angles. Now we have everything to find the coordinates of all points. Let's find all of the coordinates one by one. This is the first coordinate values. This is the second coordinate values. This is the third coordinate values. And this is the last coordinate values. So these are our coordinates. The only thing, we will draw lines between these points. So to draw polygons, we need center coordinates, start angle, and radius. With these values, we can draw awesome polygons. So you got the idea. Let's start to code this approach. First define our polygon variables. polygon variables, size, radius 100, and center coordinates 400, center y 300, and the starting angle arbitrarily I'm setting as 200. Okay, there is one more thing. I would like to define the angle variable, angle, which is the same in our slide. 2 times math pi divided size. Okay, let's start drawing. Start drawing. Context, begin path, context, stroke style as red, context, line width as 5, and also I would like to define a line join, context, line join as round, because I would like to have a smooth corners. Let's start with the beginning coordinates. Beginning point coordinates, variable begin x equals center x plus radius times math cosine start angle, where begin y equals center y minus radius times math dot sine start angle. You may also remember these calculations from the presentation. We also did these calculations step by step. And now we can set the beginning point, context, move to begin x, begin y. Awesome, we defined our beginning point. Now we need to draw our lines. Let's start. Draw lines. Let's write a for loop. This one. Sides. All of the things what we are doing now that we mentioned in the presentation. You may also remember all of the things. First we need to find the current point's coordinates. Current point coordinates. Current angle. First we need a current angle. You also remember the angle values calculations. Start angle plus I times angle. Current point x equals center x plus radius times math dot cosine current angle. And also we need the y coordinate, current point y equals center y minus radius times math dot sine current angle. Okay, now we have the current point's coordinates. Let's draw the current point. Draw the line, context, line 2, current point x, current point y. And also, after we define our line 2 functions, let's draw our line. Context. First, I would like to close the path. So, this means to close paths manually. And context stroke. Until now, what we did is we implemented what we have mentioned presentation step by step. First, we find the center coordinates, and then we found the coordinates of the other points one by one with our for loop. And lastly, we draw lines between these things. This is the thing what we try to implement our code. Now, let's check the canvas. Look, we did it. We created a generic polygon drawer. Let's play with our polygon. Let's make it hexagon. The only thing we need to do is increase the side number. Also, you may need a heptagon. Make it 7. Also, you need to change the coordinates. Let's make the center point as 200, 400. Look, its position is different. I think you got the idea. We also implement this thingy into our code. And this is our result. We made a generic polygon function and it creates awesome polygons. This is the idea. That's it for now. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to add shadows to our objects. Let's start by drawing a rectangle and circle objects. This is our shadows cheat sheet. First, we will draw the rectangle. Then we will draw the circle. Let's start with the rectangle, context, begin path, context, stroke style as green, because I would like to draw a green rectangle, context, fill style, green, and let's draw the rectangle, rect, 150, 100, 150, 400, and let's draw the rectangle, stroke, context, fill. Let's check the canvas. Okay, we draw our rectangle. Let's draw our circular object. Context, begin path, context, stroke style as red, because I would like to draw a red rectangle. Context, fill style as red, and let's draw the arc, context, arc. We also have the radian variable here. Don't forget, I defined before everything. 650, 300, 100 radius, 0 radian, to 360 radian. This means we will draw a full circle and false anti-clockwise direction variable. And let's draw context, stroke, and context, fill. Let's check the canvas. Awesome, we draw our two objects. We have our objects now. Let's try to add shadows to these objects. This is our shadow cheat sheet. Let's start with the rectangle. Context, shadow, color. I would like to define as blue. Context, shadow, offset X as 5. Context, shadow offset Y equals 5. And lastly, context, shadow blur as 5. And let's define the same attributes to circular objects. Copy, paste, and let's change the color as green. Now we defined our shadows on our objects. Let's check the canvas. Nice, we add shadows to our objects. They look like neon lights. They are so cool. Let's play with the shadows a little bit more. Let's make rectangle shadow x as 10, y as 10. And let's make circular objects x as -10 and y as -10. And also I would like to change the color as black and black. The real shadow color, black. Let's check. Look, the shadows are more real now. You can see the updates. You may notice that everything is the same that we learned in the line lessons. There is no difference with the shadow attributes and their effects on our objects. That's it. You can play the shadow attributes again and handle different results. It's up to you. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to draw texts on canvas. Let's start. For drawing basic texts on canvas, we will use two functions, fill text and stroke text. These functions are filling and stroking texts on canvas respectively. This is filling text, this is stroking text. Each of these functions are taking 4 arguments. The first argument is the text which will be drawn. Text, text. Second and third arguments are the coordinates which specify the location of the text. X coordinate, Y coordinate. These are the location arguments. And the last argument is an optional argument, which is the maximum allowed width of the text. This is an optional argument you can use or not. It's your decision. Let's start with the fill text. First, I would like to define a text var fill text equals fill on canvas, which will be shown on our canvas. Then let's use the function context fill text. The first argument is the text ftext. Second and third arguments are the coordinates. I would like to define as 80 and 100. And that's it. It's very easy to draw text on canvas. Let's check the canvas. Look. We draw our first text on canvas by using fill text function. Let's use the stroke text function. Let's use it as text, stroke text, stroke text on canvas. Then we can use the function context stroke text. First the text arguments, then use the coordinates as 80 and 200, and that's it again. It's very simple to use. Let's check the canvas. You can see we draw our second text, but we cannot understand the difference more clearly. To understand the difference between stroke and fill text functions more clearly, I would like to increase the font size of these texts. Let's do it. I would like to define a font size here. Context font equals 45 pixel Verdana. Don't worry about this issue. We will learn more details about font styling in the next lesson. Let's check the canvas. Look, this is fill text. This is stroke text message. Now you can see the difference more clearly. Fill text is drawing text by filling. Stroke text is drawing text by stroking. It's more clear now. There's one more thing, the optional max width arguments. Let's go back to our code. You may remember there is an argument here. Let's use argument here as 200, for example. And here 400. This is the argument which is the maximum allowed width of the text. Let's see the result of this argument. Look, it limits our text according to defined value and narrow it inside of this limit. The size and everything will narrowed. If we make it more small, for 100 for example, its width has become 100 and size automatically decreased. This optional value is also the limit that you can define as a width for your text. That's it. Let's remove this argument. Okay, these are our texts again. You also got the idea behind the drawing text on canvas with fill text and stroke text and its arguments. That's it for now. See you on next lesson. Hello everybody. In this lesson, we are going to learn how to style text on canvas. Let's start. This is a detailed cheat sheet for styling text on canvas. We are using font attribute to style our texts. We need to specify 4 font properties: font style, font weight, font size, and font family. You may also remember these properties from CSS, because the font attribute on canvas is the same as the CSS font attribute. Everything is the same. And the values of these attributes can be seen below cheat sheet. Font style can have these values, font weight can have these values, font size can have these values, and the font family can have these values. This is a huge cheat sheet that helps you to define your font values. Nice. Let's start by writing our text and style it. Text. This text will be styled, because this text will be styled. First, let's use the fill text function. Context, fill text, text, 100 and 100. Then we can use the stroke text function. Text, 100 and 200. Let's check the canvas. Nice, we draw our text. Now let's style these texts. We will use the context font property, and this property will have 4 different attributes. Let's define the context font. As I said, these will need 4 different values. I would like to define all of these values at the beginning as dashes, and we will replace these dashes with values above the cheat sheet. There's one more thing. We should define the font attribute before drawing our text. If you want to apply different style for fill text and stroke text, you should use the different font attributes like this. Copy this one to here. Otherwise, this context.font attribute will be applied on both fill text and stroke text. If you want different styles on your text, you should specify different font attributes. Now we will define 2 different font attributes. Let's start to style fill text, but before styling, I would like to state that I'm strongly suggesting you should use all of these 4 properties of font attributes. I mean these 4 properties. You can see some examples in the internet which doesn't cover all of these 4 properties, but this can cause some side effects. You should be in the driving seat and control everything. You should use all of these 4 properties. Let's style the fill text. Let's do one by one. The first attribute is the font style, and I would like to use the normal font style for fill text. And we need to define a font weight. I would like to define bolder. This is a very nice way to define a style for text. Just put 4 dashes and replace it with these values. It's a very safe way. And I would like to use font size. Font size, let's use XX large. And lastly, we need to define a font family. Let's define Courier, for example. Okay. And then I would like to define the font attribute of the stroke text. First, I would like to make it italic. Then the second thing, font weight. I would like to define the font weight as 700 for this time. And the third one is the font size. I would like to specify an exact number for font size, for example 48 pixel. And the last one is the font family. For this time I would like to define the fantasy. Okay, let's make it the fill text style and stroke text style. I would like to add comments because it's more readable now to understand for other people's. Okay, let's check the canvas. Look, we did it. These texts are styled. They look like awesome. Let's play a little bit and handle different results. Let's make this coordinate as 150. And I would like to change the font as monospace. And let's make the weight as 400. And I would like to change this font size as times. Maybe we can make it 800. That's kind of variations. Let's check. Now they are totally different. You got the main idea behind this font styles. We are using these 4 attributes and all of the values are here that you can use, and this is the implementation. That's it. Context, font. Don't forget, it's very easy to apply when you follow these 4 dash methods. That's it. See you on next lesson. Hello everybody. In this lesson, we are going to draw 3D texts on canvas. Let's start. There is not any built-in drawing 3D text function on canvas because we are in 2-dimensional context. In this lesson, we will experiment a new way to draw 3D texts. First, let's draw a text on our canvas. At context, font, normal, 600 font weight, 54 pixel font size, and monospace font family. And let's set a color, fill style, violet. I would like to define a violet color for my text. And let's draw it, fill text, text 100 and 300. Let's check. Nice, we draw our text on our canvas. Now we can create our illusion to create our 3D text. We will redraw the same text under the original one for many times, and these redraws will be black, acts like a shadow. There will be minor position changes on each of these black shadows. On the top, the original text will be shown, and there will be a 3D-like feeling in our text. So to sum up, there will be layers as a black shadow, and on the top, the original text will be shown like a 3D. Let's create our layers. Layer 1. Let's copy this one to here, and let's take this one to here, because it will be universal for all of our texts. And I would like to have 4 layers, 2, 3, 4, layer 2, 3, 4, remove these colors, and define as ones as black, and this will be the original text. Okay. These are layers, and this is the original text. Now we should play with the coordinates a little bit. I would like to decrease the coordinates, both the x and y, by 2 pixels, like this. and also the y coordinates. Let's check the canvas now. We have 5 texts and all of them are drawn onto each others. There is a huge stack and this stack is consisting of 5 texts. Let's check. Look, we almost did it, but the layers can be seen easily here. You can see there are gaps between the layers. Let's decrease the difference as 1. Let's check the canvas again. Nice! In this time we did it! Our illusion works amazingly. Our texts are in 3D now. It's very nice. You can see we draw a 3D text on canvas. Now I would like to make some changes on our codes because this form cannot be reused easily. You should update everything one by one. I would like to create a function which is called function draw 3D text. And this function will take as a parameter the text, what we need, the coordinates x, y, and also we need the style, and we need the color of the original text, and lastly we need how many layers will be drawn. I will be call it as size, 3D size. Okay, first let's copy this one to here and first we define the style, then we need to specify the color, fill style, black. In this time for drawing the layers, we will use the for loop, size, because it's more easy and more meaningful in this case. We don't need to rewrite these code pieces again and again. We will use context, fill text, x minus I, and y minus I. Awesome, now we will draw our original text. Context, fill style, color, context, fill text, x and y. That's it. Now we can call our functions in here. Draw 3D text. First we need to put the text as a parameter. Then we need to specify the coordinates 100 and 300, the original text. Then we need to specify the font style. It was the normal 654 pixel monospace. Now we need to specify the color violet. And lastly, how many layers will be drawn? I would like to draw 5 layers in this time. And let's remove all of these code pieces. You can see our code has become more clear and more reusable. Let's check the canvas. You can see we draw the same thing with our new function. Let's play with the arguments and handle different results. For example, the color as red. You can see it's a red color text now. With this way, we create our generic 3D text drawing function and we can reuse it wherever we want. That's it. We draw our text with a smart way and we have a function now that we can use everywhere we want. We can draw 3D text on canvas now. See you on next lesson. Hello everybody, in this lesson we are going to learn more details about positioning of the texts on canvas. Let's start. We are positioning the texts on canvas by defining an x and y coordinates. But exactly where the canvas draws the text depends two more properties, text align and text baseline. Each text on canvas is exactly positioned as a combination of x coordinate, y coordinate, text align and text baseline attributes. All of these attributes play a vital role to position text on canvas. The text aligned attribute specifies how the text is aligned horizontally. The text baseline attribute specifies how the text is aligned vertically. Let's examine these attributes one by one. First, let's draw a vertical reference line and then examine the text align. Vertical reference line, context, stroke style as red, context to the beginning point of our line, and context line to the end point of our line. And let's draw our line. Let's check. Okay, we draw our vertical reference line. Now we can start to draw our text. Then I would like to define a font style. Context font equals italic 400 font weight, 18 pixel font size, and mono space font style. And let's start to define our different text align values. Apply text line values. First, I would like to start with this default value, context, text align, starts, context, fill text, starts, 320. Let's check the canvas. Look, our text is here. So the start text align value denotes the text starts from the defined position. And let's continue. Let's copy this, paste. We will now use the center. Let's increase the coordinates as 30. You can see if we define center text align value, the text automatically aligned between the coordinates and widths of the position. And let's continue. Copy. Left. Let's increase the coordinates. So the left means the text starts from the left of the defined position. Continue. Copy. Then I would like to use the ends. We missed ends. Let's make the coordinate as 110. You can see if we specify the text align attribute as end, the text ends the specific position. Let's continue. There is one more thing, the right. Right and right. Make this beautiful. You can see it behaves very similar to and. If we specify the text align attribute as right, the text will be ended the most right position of the text. These are the text align values and their effects on the text. You can see they directly affect the position of the text. Yes, these are the text align values. Now let's draw a horizontal reference line. Let's copy this first to here. Horizontal reference line, red, yes. Let's update this coordinate as 20, 300, 300, and 580. Let's check. Okay, we draw our horizontal reference line. Now we can start to draw our text. To understand the text baseline attribute, let's start. Apply text baseline values. Let's start context, text baseline. I would like to start with the default value, the alphabetic. And context, field text, alphabetic, 120 and 300. Let's check. This text baseline is the normal alphabetic text baseline. Let's continue. Copy this. And the second one is top. Make it top, top. Make it 220. You can see this baseline attribute value affects as a top value. Continue. The next one is hanging. Let's check. You can see this hanging has also different baseline for the text. Let's continue. I would like to complete all of the text baseline and compare after all of them is completed. How many requests? 3 more. Let's copy all of them. Middle. Like this. Ideographic and bottom. Let's make this ideographic. Let's make this bottom and update the coordinates. Let's check. You can see all of the text baseline values have different effects on the text. The purpose of this text baseline attribute values are different languages have different baselines. For example, the alphabetic baseline is being used in the Latin languages, and ideographic baseline is being used for the Chinese or Japanese languages. And also the hanging baseline is being used in the Indian languages. These are the main purposes of the baselines, different languages and different baselines. These are the attributes and their results on text. We can have many different controls on text and their positions on canvas. You got the idea behind positioning on the canvas more detailed now. You can use X coordinate, Y coordinate, and text align and text baseline attributes with these values. You have the control, you can do whatever you want on canvas with text and their positions. That's it. See you on next lesson. Hello everybody, in this lesson we are going to learn how to add shadows to texts on canvas. Let's start. As you can see, everything is same again. Shadow color, shadow offset X, shadow offset Y, and shadow blur. These are the same shadow attributes again that we learned in the previous lessons. Okay, let's start by drawing the texts on canvas, and then we will add shadows to these texts. Let's start. First, I would like to define a text. This text will be shadowed. I would like to draw two texts. The first one will be drawn with fill text and the second one will be drawn with stroke text. Start with the fill text. Fill text function. I would like to style the first text, context, font, normal, 700 font weight, 24 pixel font size, and times is the font family. And let's draw text 100 and 100. Let's check. Nice, we draw our first text. Now let's draw the second text. Stroke text function. Context. Again, I would like to define a style for this text. Italic, 400 font weight, 48 pixel font size, mono space is the font family. And let's draw context, stroke text, text 100 and 400. Let's check the canvas. Nice, we draw our text on canvas. Now we can add shadows to these objects. As you can see, we again have 4 shadow attributes. Let's use them one by one. Context, shadow color as red, context, shadow offset X equals 5, context, shadow offset Y equals 5, and lastly context, shadow blur as 4. And then I would like to add shadows to this stroke text object. Context, shadow color as green, context, shadow offset X equals -5, context, shadow offset Y equals -5, and lastly context, shadow blur equals 4. Let's check the canvas. Look, we added shadows to our texts. It's the same process that we learned in the previous shadow lessons. The same attributes, shadow color, shadow offset X, shadow offset Y, and shadow blur. All of shadow attributes are same and their functionalities are same. Shadow is a universal attribute that we can apply any kind of drawings on canvas. We can add shadows to our lines, our objects, our text, our images, our videos, on everything. It's very universal attribute. When you learn it once, you can use it in everywhere like this. That's it. See you on next lesson. Hello everybody. In this lesson, we are going to create the structure of our project. As you can see, we have nothing now. We only have an HTML file which is almost empty. Let's start to create our files. Styles, CSS, Canvas, script.js, and bar.js. We created our files. Okay, let's include these files into our HTML. Styles. Let's include our style. CSS, relation, style sheet. Okay, we included our style. Then I would like to include the JavaScript files. scripts. First, I would like to include the bar.js script source bar.js script. Then I would like to include the Canvas script. Canvas script.js. Okay, now we have the files and all of them are included. Let's start the coding. First, I would like to create a div and then I would like to style it. Div id chart. This will be the target container, therefore I would like to define an ID. This will be our bar chart. Let's close the div. Awesome. It's very important that we have to have a container for our bar chart, because in this time we will create our canvas dynamically from JavaScript file. We will not create our canvas in HTML. We will create in the JavaScript. Therefore, it's very important to create this container. This will be a new approach for us, but this will make our library more usable and easier to use for end users. Let's style this div. Chart. Width 600 pixel, height 450 pixel. I would like to align my div as centered, margin 0 auto, and let's add a border to make it more visible. Border 1 pixel solid. Let's check. You can see our div is ready to use now. Let's start to code our JavaScript part. Open Canvas script.js. We also included Canvas script here. If we need to draw a chart, it's obvious that we have some data and we need to visualize this data. So first we need to create our data. Let's create. Var data. We need to format our input data for our chart library. I would like to make it object array, like this. And this object will consist of a label. For example, I would like to define the months, January, and this month has a value. For example, 32. Let's copy this. Let's remove this. Okay, let's update Jan, Feb, March, April, May, and change the values. Now we have the data. We can visualize this data onto our chart. But I would like to improve my data. I would like to have more distributed and random data. Let's do first I search math random JavaScript in Google, and I am opening this first result, developer Mozilla link. And you can see there is a function which generates random numbers between two values. I would like to use this function because we need integer values. Copy this one and paste here. Now we have a getRandomInt function that generates random numbers between the interval that we defined. First we need to define our interval, min 1, max 200. Then we can use our function in here, getRandomInt min max. Let's copy this. Okay, now we have total random data are in defined range. Let's check console log data. Let's open the developer console. Let's refresh the page. You can see these values. Then I would like to refresh the page again. You can see there are different values. Okay, it's awesome. We have now random values in our data. Now let's define our chart specifications. Let's remove this console log. This will be our chart data and chart specifications. First, I would like to define the target for target the chart. This is the ID of the target where the canvas will be drawn. In our case, this is our target and we need to define an ID on our target to handle this target, and we will draw our canvas onto this target. It's very important to have an ID on our target. Okay, canvas width 600, canvas height 450. Now we have the chart specifications. Everything is ready to begin our chart library. Let's create our chart library's constructor function. Open bar.js, function, bar chart. This will be the constructor function of our library, and this library will get target ID, chart width, we can easily specify as width, height, and data. Let's console these values to check. Console log arguments, all of them. This means all of them. Arguments means all of the inputs as an array. Let's go back to our canvas script.js. Let's create our chart object. Okay, chart equals new bar chart, and we need to pass the arguments target, canvas width, canvas height, and data. Everything is okay now. Let's check if it works. Let's refresh. You can see our arguments are passed to our library successfully. It's very nice that we create the basic structure successfully. There are some more things that we need to do. Let's go back to our code. You may notice that our code is not in a safe zone. There might be some side effects if we use our code like this. In our previous examples, we always use a very safe container, Windows onload function. This was our surrounding secure zone. Let's use it again. Window onload function. And everything is in a secure zone or safe place. Okay, there are a few more things. This will be an open source project and we should be explicit. We should write well documented code. First, we should describe the library a little bit. Then we need to define the date of the creation of the library and then the version. In short, some of the information about the library. Let's open bar.js. Let's add our documentation. Okay, first I would like to add bar.js, the name of the library. Then we can add our simple description of library, for example, simple, elegant bar charts library. It's nice. And we need to add the dates. This is the date that you should add when you create your library. I'm leaving this part as date. You can update by yourself. And the version. This is the first version. And continue. The URL. Exactly, this will be the repository URL that we will publish our code onto a repository, which will be probably a GitHub repository. We will update this part at the end of the course, the repository publishing part. And let's define our license. Because it's an open source project and it has to have a MIT license. Copyright. Your name. Released under the MIT license URL. The license file will be hosted in our repository. We will update this part again, but it's very important that you have a license file and you have a license in your project. Okay, we documented, we wrote very nice information about the project. If someone opens the code, he or she can easily understand what this project about, what is the versions. It's very important to have this brief information. Don't forget, you shouldn't write your codes for your computers. You should write your code for other people's. This means more readable, well-documented, and clean code is a must for writing a project. Let's continue. There's one more thing. Lastly, we will add one more thing, the use strict. Because we would like to write our codes in a strict mode. Use strict, in other words, the strict mode, is preventing the common JS errors and it's forcing us to write our code in a safer feature set of JavaScript. It's very important. Everything is now ready to start. See you on next lesson. Hello everybody. In this lesson we are going to draw the horizontal and vertical axes. Let's open our reference bar chart again. Yes, this is our reference. First we will draw the vertical axis, this line, and then we will draw the horizontal axis, this line. Let's draw. Open our constructor function. Again, we will write our code organized. Let's define our function. Draw charts. Draw charts. Okay, this will be the last function of our constructor. When we finish this function completely, our chart library will almost be completed. Let's create the function. Bar chart, prototype, function, and we need the base. Copy. Okay, first we will draw the vertical axis. Charts, draw vertical axis. But I noticed that I made a small typo because of the similarity of the pronunciation of the word. I defined the axis as ax in our configurations. First update our configurations. Let's open configure chart. And is there anything? No. Set parameters. Is there anything? No. Open. Yes, you can see X configuration. This is wrong because X is totally different thing. First we need to do is axis configuration, axis ratio, axis ratio, axis ratio, and we need to make this axis color and axis width. Is there anything like this? No. Let's open. Is there an axis related something here? No. Let's open data. No. Pre-process data. Yes. Axis specifications. Vertical axis width, horizontal axis width. Is there anything more? No. Let's console log chart. Let's check. There's something, yeah. Draw axis. We didn't define this function, sorry. Bar chart prototype. Okay, we define it. Refresh. Axis ratio, context. Axis. Okay, it seems everything alright. Let's continue to draw our axis. First we will draw the vertical axis. You can see this is a line which starts from the horizontal margin and vertical margin to height of the canvas minus vertical margin. Yes, it seems not equals this margin to this margin, but in our drawings it will be equals. We will draw more consistently. Let's draw our vertical line. First we need the base as usual. Okay. Vertical axis, it's very important. Chart, context, begin path, chart, context, stroke style. Everything is configurable. You may remember we defined everything in the configurations. Therefore, we need to assign our variables to these attributes. Chart, axis. We didn't define it. Sorry, axis color. Axis color. Chart, context, line width equals chart, axis width. Okay, now we can define our starting point, the horizontal margin and the vertical margin. Chart, context, move to chart, horizontal margin, chart, vertical margin. And let's define the endpoint of our line, which will be the height minus the vertical margin. Chart, context, line 2, chart. The x-coordinate will be same, horizontal margin, and the y-coordinate will be chart, height minus chart, vertical margin. And let's draw the line, chart, context, stroke. Okay, let's check the canvas. Let's close this console. Okay, you can see we draw our vertical line. It's very nice. It's totally configurable. The margins are configured by us. Let's update the margins and see the differences. For example, where is our configurations? Yes. Our axis ratio is 10%. When we make it 20%, you will see our axis will be here because the margins increased. When we make it 5%, it will be higher in the vertical axis because we decrease our margin. Let's make it again 10% and continue to draw our axis. Close this. Now we will draw the horizontal axis. chart, draw horizontal axis. Yeah, you can see our code is very organized, very understandable. Everything is separated into small logics, small functions. Let's close this. Bar charts, prototype, function. Okay, let's copy this directly and edit them. Close. Okay. Horizontal axis. Let's examine our reference charts. The horizontal axis is here. It starts from the horizontal margin and height minus vertical margin, and it ends width minus horizontal margin, and the y coordinate is same, height minus vertical margin. Let's draw. First chart horizontal margin, and let's copy this to here. We defined the beginning point, and let's update the end coordinate. Chart width minus chart horizontal margin. Okay, we did it. Let's check the canvas. You can see we draw our horizontal axis. Now we draw our vertical axis and horizontal axis. It's very nice because it can be configured with our specifications, for example, ax margin, line width, or any other things. They are very flexible and very nice axes. We completed our drawing axis process. See you on next lesson. Hello everybody. In this lesson, we are going to draw vertical and horizontal labels of our chart. Let's open our reference chart. These are the vertical labels. These are the horizontal labels. We will draw all of them one by one. Let's start by drawing our vertical labels. But at the beginning, I would like to show some typo correction. In the prepare data, in here, this was again horizontal x. I missed this variable to update in previous lesson. Therefore, I fixed now. This is okay. There is no x anymore. X, no results. Okay, now we can open our draw chart function. Then we can define our function. Vertical charts, draw vertical labels. Okay, let's create this function. Bar, prototype, function. Let's copy the base and open the function a little bit. Okay. So first I would like to define the text specifications. We should define our label fonts. Label fonts. We defined all of the font related things in the configuration. Let's open the chart parameters. You can see we defined all of the font attributes here, and we will use all of them in our function now. There are everything, vertical font size, horizontal font size. We will use vertical font size in this function. Let's close this one. And let's start to define chart, font style, chart, font weight, and we need to use vertical font size. And lastly, we need to use the font family. That's it. Now we can assign this value to our font attribute. Chart, context, font, label font. Then let's set a font color. Chart, context, fill style, chart, font color. Okay, we defined our text specifications. Let's start to draw our labels. Draw labels. Chart, items num I++. Okay, now we are looping. First we need to define the label text. This means the shown text on here, 200, 160, these are the label texts which are shown next to the vertical axis. Variable, label text. Let's open the chart again. You can see there's a frequency, there's a difference between the label text. We only know the upper bound and we know the frequency amount, and we will create the other label text dynamically. Let's do chart vertical upper bound minus I times chart vertical label frequency. Okay, let's define our coordinates. Vertical label x. I would like to define it as horizontal margin, and let's define the y coordinate. Vertical label y. We know the upper bound label's coordinate, chart vertical margin, and we need to increase this value by frequency amount, I times chart vertical label frequency. Okay, let's draw our labels. Context, fill text, label text, vertical label x, vertical label y. Let's check the canvas. Nice, we draw our vertical labels, but you can see there are many missing points that we have to handle. You can see their positions are totally wrong because they have to be on the left of the vertical axis. First, let's fix this issue. They have to be left of the vertical axis. First thing, we will add a text alignment to our labels, chart, context, text align, right. Let's check. You can see they are on the left, but we would like to move them a little bit left. Let's update their x coordinates. This is the x coordinates. We need to decrease the x coordinate by horizontal margin divided chart axis ratio. We are using always ratios because this manner makes our chart responsive. Otherwise, if we use something like this will be very dangerous. Our manner is better than this. You shouldn't use exact numbers anywhere. And okay, let's check the canvas. Nice. We fixed the horizontal positioning problem. Now let's handle the vertical positioning problem. Why do they position like this instead of like this? This looks like awesome. They positions very well, but our labels are not positions like that. The problem is our reference, in other words, our origin. We are based on to this max value and calculate our frequency according to this max value. Our range is 0 to 110, for example, or 0 to 140, but our vertical axis is higher than our range. This is the problem. We should scale our labels y coordinates according to width of the vertical axis, and then all labels will be positioned accurately. The first label, in other words, the upper bound, is positioned correctly. The problem is the frequency between the lines. So we should scale our frequency according to our vertical axis. Let's scale the label frequency value. Let's remove this gap. Scale values. We need to scale this value, chart vertical label frequency, scaled vertical label frequency. We will make a simple mathematical operation. First, we will find the ratio of the vertical axis width and the max label value division. Let's find chart vertical axis width divided chart vertical upper bound, and then we will multiply this ratio to our frequency times this value. This is our scaled vertically labeled frequency. Let's copy this, replace. Okay, let's check the canvas. Awesome, we fixed every issue and implemented the vertical labels correctly. Very nice. Now let's create the horizontal labels. These are more easy to create. We don't need to scale something or generate labels. They are also given us. Let's open handle data function. You can see we are handling the labels which are the horizontal labels. Let's use this array. First create the function horizontal labels charts draw horizontal labels. Let's create this function, close this. Bar chart, prototype, function. First, let's copy the base. And again, we need the text specifications. Let's copy them. Remove this one for now. Okay, now we can draw our labels. Draw labels for items name. Okay, now we are looping. Close this gap. Yes. In this time, we don't need to specify the label text. We also know the label text. Let's define our labels coordinates. Horizontal label x chart horizontal margin plus I times. We know the horizontal label frequency chart horizontal word label frequency. Okay, let's define the y coordinate. Horizontal y equals chart height minus chart vertical margin. Let's draw our labels. Chart context fill text chart labels horizontal x horizontal label y, and let's close these gaps. Okay, we did it. Let's check the canvas. Awesome, we draw our horizontal labels, but again we need to specify their coordinates, their positions. First, start with these font specifications. Let's set the text alignment, text align, center, and also I would like to specify a text baseline, chart, context, text baseline, top. These specifications will move our labels to below of horizontal axis. They are above the horizontal axis, but now they will be below the horizontal axis. Nice. But we need more specifications. Let's update their x and y coordinates. I would like to add half of frequency to their position, x position, and I would like to increase their y coordinate with our ratio, x ratio, chart, vertical margin, divided, chart, axis ratio. Okay, let's check the canvas. Awesome, we did it. We draw our labels. These are our vertical labels. These are our horizontal labels. Now our chart has becoming more nice. That's it for now. See you on next lesson. Hello everybody. In this lesson, we will draw vertical and horizontal guidelines. If you are wondering what is guideline, let's go back to our reference chart. You can see these parallel lines. These are horizontal guidelines. This chart only has horizontal guidelines, but our chart will have both horizontal and vertical guidelines. We will also have vertical guidelines like this. These vertical guidelines. Let's start by drawing our horizontal guidelines onto our charts. This is the current situation of our chart. We have the vertical and horizontal labels, vertical and horizontal axis, and now we will draw the guidelines. Let's start. Let's open JS. First, I would like to call our function into the draw chart function because it's our main drawing container function, horizontal guidelines, charts, draw horizontal guidelines. Okay, let's create the function. Bar charts, prototype. First, let's copy the base as usual. This is the most important thing. Okay, let's go back to our reference chart again. You can see the starting point of these guidelines will be almost same of the coordinates, the vertical labels. You can see they are almost same. So we also have these vertical labels. So let's benefit from these previous calculations because we already did these scale operations. Okay, let's copy the code pieces of the drawing vertical labels. Where is it? Drawing vertical labels. We need this part. Let's paste them. Okay, first I would like to comment out everything. Okay, now we can do whatever we want. As you can see, we will draw lines. Therefore, we need 4 parameters: starting point x, starting point y, end point x, and end point y. If we find the y coordinates of this point, it will be almost same in this point. Let's find these coordinates. Let's start var horizontal guideline start x. This will be the same with this. And then we need the horizontal guideline start y. This will be this. Paste. Okay, we find the coordinates of the starting point. Now we need to find the coordinates of the end point. The y will be same. The x coordinate will be increased. var horizontal guideline and x. Let's label them as starting point coordinates and point coordinates. Okay, if you look this thing, the x coordinate will be increased by the amount of the horizontal axis. So it will be chart plus chart horizontal axis width, and let's copy this guideline and y. This will be same. Okay, we defined the coordinates of our horizontal guideline. Let's draw this line. Chart, context, begin path, chart, context, move to. Let's copy this here. Y, charts, context, line 2. Let's copy this to here. Y, and at last, charts, context, stroke. Okay, there is one more thing. Let's close these gaps. Remove these unnecessary parts. And let's open this scale value because we are using this scale value in here. Because this is the scaled vertical label frequency amount, we need these calculations. Okay, let's check the canvas. Look, we draw our guidelines. Nice, we draw our horizontal guidelines, but we need to style them according to our configurations. Let's style them. We should define specifications here before everything. specifications, charts, context, stroke, style, charts, guideline, color, charts, context, line width, charts, guideline, width. Okay, let's check the canvas again. Awesome, in this time we completely did it. Now we can draw our vertical guidelines. We draw our horizontal guidelines. Yes, they look a little bit blurred, but this is the purpose. They are not significant like the axis. They are blur lines. Okay, let's close this one. Let's define our function. Vertical guidelines, charts, draw vertical guidelines. Okay, let's create the function. Bar chart, prototype, function. Again, first let's copy the base. Base is our everything. Again, we will benefit from previous calculations. Let's copy the inside of draw horizontal label function. Open this function. We need this calculations. Let's copy this part. Again, let's comment out everything. And we are here. Yeah. Again, we need 4 parameters. The start x, start y, end x, and y. We will draw lines again in this direction. Okay, but before drawing something, let's copy the style specifications from our previous guideline draw function. These will be same. Awesome. Okay, now we can edit inside of the loop. Again, we need to define 4 coordinates to draw our lines. Let's define the starting coordinates. Var vertical guideline start x. Let's copy this value, but remove the extra part, this extra part. Okay, then let's define the y coordinate. Let's copy this y. Again, we can benefit from this commands. Also, let's copy this. Okay, let's define the y coordinate. Let's copy this. Again, we will remove the extra parts. This will be enough. These calculations are for these labels. They are a little bit far away from the axis, as you can see. Therefore, we need to remove the extra parts. Okay, we defined the starting point coordinates. Let's define the endpoint coordinates. Var vertical guideline and x. It will be the same of the starting point x. And let's define the endpoint y. This will be the vertical margin. Okay, we defined the coordinates. Let's remove unnecessary parts. Again, let's copy the drawing code pieces. Copy this part from previous function and update the variables. And make this function a little bit tidy. Okay, we defined everything. Let's check the canvas. Awesome, we did it. we created our guidelines successfully. There's only one missing point. I would like to draw one more guidelines to here to close everything. Let's make it. Awesome. It's awesome now. You can see our chart is almost done. We only need bars now. Everything is okay. See you on next lesson. Hello everybody. In this lesson, we will draw the bars of our chart. Let's start. You can see we almost completed our chart. The only missing part is the bars. We will draw our bars inside of these blocks. There will be bars inside of these blocks. Let's come back to our code and start to drawing our bars. Let's open the draw chart function. Let's call the draw bar function. Bars, charts, bars. Okay, let's create the function. Bar chart prototype. Let's copy the base for the last time. Okay, before starting to write our code, we need one more thing. Color of our bars will be random, so this means every bar have randomly different colors. Therefore, we need to create a random color generator function. We can't use exact colors with their names or the hex codes. We will use RGB colors because we will play with our bars opacities. Okay, well, first let's define our random color generator function. Come here. Let's come to here. Bar charts, prototype, create random RGB color function. There are many different ways for generating random numbers. We will use the previous manner that we used before. Let's open CanvasScript.js. You may remember we had a function, getRandomInt function. Let's copy this and paste here. This function is generating random numbers between the min and max interval. The maximum is exclusive and the minimum is inclusive. So RGB range is 0 to 256. Therefore, we need to define from 0 to 257. Okay, let's complete our random RGB color generator function. First, we will generate red amounts. Var red get random int 0 to 257. Then green amounts, var green. Let's copy this function again. And lastly, the blue amounts. As you can understand, RGB is coming from red, green, and blue names. Paste here. Okay, let's return these values as an object. Return R red, G green, B blue. Nice, we created our create random RGB color function. Okay, let's test our RGB generator function. Let's call this function in here. Var color chart, and let's console log this color. Let's check. Open the console. Let's refresh the page. Refresh. Nice, it works. It generates random RGB colors. Every refresh gives different results randomly. Okay, let's define our loop now. Let's remove this console log for chart items num. Okay, let's close the gap. Okay, we are inside the loop now. We will draw the rectangles as our bars. Okay, let's start. Chart, context, begin path. Now we need 4 parameters to draw our bar rectangles. We need x and y coordinates, the coordinates of the left top of the rectangle, width, and the height of the rectangle. We need 4 parameters: x, y, width, and height. Let's go back to charts. Let's open this one. This is very complicated to calculate these values. You can see we should find these x and y, and we should scale the value according to our vertical axis. Yes, it seems very difficult and complicated. You can see we should take as a base this line, and we should find the difference, and we should find the x and y, and we should scale the value. Therefore, we will follow more easy manner to draw our rectangle. We will draw our rectangles from reverse direction. For example, here will be x and y, and we will find the scaled width and height. Lastly, we will multiply the height by -1, and it will be drawn accurately. This means we will draw our bar initially below the horizontal axis, and then we will reverse this bar to other side. Let's do it and understand by doing. First, I would like to define x and y. Come here. Var starts x. We need to find these points coordinates. So this x coordinate starts from the horizontal x margin, and they are increasing by horizontal label frequency. So it will be chart horizontal margin plus I times horizontal label frequency. Let's define the y coordinate. Start y. I would like to update their names. Bar x, bar y. Okay. Let's open the chart. Height minus vertical margin, as you can see, the y coordinate of this line. So this means chart height minus chart vertical margin will be the y value. Okay, let's define the width and height of the bars. Bar width equals, this will be the horizontal label frequency, chart horizontal label frequency, and variable bar height. Now we need to find the height, in other words, the scaled height. We should scale our value to our vertical axis. We did these scale operations for many times. So this will be something like this. Chart vertical width, axis width, times chart values. We need to handle the current value, I, divided chart max value. Okay, lastly, we should multiply this height by -1. This means -1 times chart. Otherwise, the rectangles will be drawn below of the horizontal axis. We need them above the horizontal axis. Okay, let's draw our charts. Chart, context, rect. Let's copy bar x, bar y, bar width, bar height, and lastly chart, context, stroke, chart, context, fill. Okay, it seems we did it. Let's check the canvas. Awesome, we draw our bars successfully. Now let's improve our bars. First, let's define color to bars. We have a color here. Let's take this variable into our loop. Now every bar will have randomly different color. Let's define our color specifications. First, I would like to define the opacity, fill opacity. I would like to define it as 0.3. Again, it's up to you. You can change these values. Then I would like to define the fill color. Var fill color equals RGBA, because we will play with the opacity. Therefore, we will use RGBA. Otherwise, we can use RGB. And then we will add the color variables. First, the color.r, then color.b, then this will be G, this will be B, and lastly we will add the opacity, fill opacity. Okay, we defined our random color. There's one more thing. Let's copy this. I would like to do some very aesthetic and stylish thing. Let's make this border color. And let's remove the opacity. The border color of the bar will be darker than the fill color of the bar. This will be very nice, you will see. And let's use these defined colors in our bars. Chart, context, fill style, fill color, chart, context, stroke style, border color. Okay, let's check the canvas. Look, it seems better now. The bars have different colors and they look very nice now. You can see. It's very nice. And also there is one more improvement that we have to do. We should narrow the bars a little bit and center into these columns. Then there will be some gap between the bars and it will be better. Let's play with their width and x-coordinate. First, let's narrow the bars. The first thing we have to do is update its width. Again, we need to use ratio. I will use again our axis ratio to narrow it. We have very famous ratio in here, wait. The axis ratio. Again, I will use this ratio. I will narrow the bar from the two sides by the ratio. So this means this will be smaller than chart. This will be smaller than this label frequency divided chart axis ratio. Let's check. Nice. It seems better now, but you may notice that they are left aligned to their columns. You can see they are left aligned. Let's play with their x-coordinates to make them centered. Let's come back to the code, the x-coordinate. We need to increase x-coordinate by again the ratio amounts. We have this chart label frequency. Again, we will use this value. Let's take it, paste here, and that's it. We will increase the x-coordinate by the ratio amount. Let's check. Awesome! We did it! You can see we built an awesome, totally dynamic and configurable bar chart. Congratulations to us, we did it! It's very nice. Now it's time to share this open source project to public. See you on next lesson. Hello everybody! In this lesson we will publish our project to our public repository. Let's start. Before everything, please make sure that you have installed Git on your computer. I don't mean GitHub, I'm saying Git. If you haven't installed yet, please visit this website and install it. git.scm.com. This is the official Git page and you should visit this website, download from this page and install it. Okay, now I'm assuming that you have Git on your computer. Okay, we built our bar chart library and we would like to share this masterpiece to other developers or anyone. We would like to share it to public because it will be open source project. We are very open to new ideas to our project and new contributions from the other developers. There are many repository management services that we can use. It doesn't matter whether you are using Bitbucket, GitLab or GitHub. There is GitHub, GitLab, and Bitbucket. It doesn't matter. You only need a public repository on these providers. They are the key components of the collaborative software development. If you don't have, you should have an account one of them. Because you really should to contribute open source community. That's it. For this project, I will use GitHub to create repository and share it. You can use whichever service provider you want, as I said before. This is my GitHub profile page. Let's create a new repository. Come to repositories and new. I will name it as bar.js. Let's write a simple description. Lightweight, configurable, and simple bar chart library in JavaScript. Okay, lastly, check initialize this repository with readme checkbox and create the repository. Nice, we created our repository. Okay, let's clone this project to our local machine. GitHub is providing some desktop clients which are directly aiming to help you for your GitHub operations. Otherwise, you should open this button, you should copy this, and you should open the terminal and you should write command line some things. But GitHub client is doing all of the things in the background. Let's open my GitHub desktop client. It's very easy to use. Let's click this one, clone a repository. And this is our project, bar.js. And then I would like to select a desktop and open. I would like to clone it to desktop and bar.js folder and clone it. That's it. Now we cloned our repository to our local. Yes, okay, this is the folder bar.js on the desktop. We clone it. Okay, let's prepare our repository. Let's create some folders on our repository. First, I would like to create an example folder. Then I would like to create a source folder. And lastly, I would like to create a dist folder, distribution folder. Okay, and we will copy our implementation to example folder. Let's open example folder. Let's copy our files to here. Okay, these are our current project. We copied them into the example. Nice. And you can see the new files on the GitHub client. Anyway, now we need to copy this bar.js to our source folder. Okay, there's one more thing. Let's copy this here and let's name it bar.min.js. In real life, all of the JavaScript code pieces are processed to be used in web applications. We will only minify our library to increase page load speed. It's very important. There are many different professional libraries and tools that we can use, but we will keep it as simple as possible. First, let's open our code, and then let's copy these code pieces. And then open the jscompress.com and paste our code to here. It's an online free tool that you can minify your JavaScript files. And then let's compress it. Now it's minified. Let's copy these code pieces to our bar.min.js file. Let's copy this. You can see we are saving almost 5 kilobytes. It's very nice. Remove and paste here. You can see it's minified. The spaces and unnecessary commands are removed. Let's save it. Nice, we almost did it. Now we will create our license file. Let's copy this, paste here, license md. Let's open it with Atom. Remove everything. This will be an open source project, therefore it should have an MIT license. Let's Google it. Open this, MIT license. You can open this link, opensource.org license MIT. We should have this license text as a file in our repository. Let's copy this text. Let's copy and paste here. Remove this one. Yes, Let's edit it. This is a MD, in other words, the markdown file. Therefore, we need to use markdown syntax. This is our headline. Therefore, we will use H1. And let's edit these parts. 2017. And copyright holder, it's me, Alperen. You can also write your email, alperen.oglu@gmail. Okay, awesome. We have a license file now. Last thing, I would like to add a screenshot of our bar chart. Let's open our bar chart and let's take a screenshot. I would like to take a screenshot like this. Okay, let's put this image to our folder and name it bar. Let's push all of them to our public repository. Let's open our GitHub client again. You can see everything is here. First, we should commit them. Project structure created and commit to master. Okay, we committed. Now we should push these changes, the local changes, to remit repository. Push them. Okay, the remove and the locals are equals now. There's no differences. Let's open our remote repository. Let's refresh the page. Awesome, look, everything is here now. We pushed everything successfully. Our project is public now. It's awesome. Lastly, I would like to update one more small thing. Let's open our project and let's open the source file bar.js with the atom. Okay, you can see we have a small documentation here, but some of the points are missing. For example, date, URL, license URL, your name. Now we will update these missing points. First, update the date. You should update this date to your current date that you create your project. I will randomly write a date, for example, 23.11.2018. And the URL, this will be our public repository URL. Let's open. This is the URL. Now our project has a URL. It's very nice. Our project is in the public now. Everyone can see, everyone can find it and contribute to it. Your name. In our, let's open license file. In our license file, there is here. Let's copy it. Let's paste. And also license URL. We have a license URL now. This is our license URL. If you open your repository and click license MD, you can see the details about your license, permissions and limitations of your license. It's very nice to see this. And let's copy the address of your license and paste here. Let's copy these pieces to other bar.js in the example. Open example bar.js. Paste. Nice. Let's commit these changes to our public repository. Let's write library documentation updated. Commit and push. Let's open our public repository. Open bar.js. We made our first contribution to our open source project. Let's open our source file, bar.js. You can see they are here. Now we have a public and open source project on our public repository, our GitHub account. See you on next lesson. Hello everybody. In this lesson, we will create the documentation of our repository. This is an open source project and the documentation is very important. Let's start. This is our readme.md file. Let's open it and let's click the edit button. First, we will add batches to our readme file. Let's open the Shields IO. You can see there are hundreds of batches with different purposes. Let's use some of them in our README file. I would like to use the license, for example. Let's click. Let's copy this. And also I would like to close this one. And I would like to add this one. There's no purposes of this batch now. I just want to show how to add batch to your README file. And also I would like to add one more. For example, the file store. Nice. Okay. Now we can start our documentation. First, let's create the description. Description. This is H2 because we have a H1 headline. Okay, let's write some description. Bar.js is a canvas-based, simple JavaScript bar chart library to provide a configurable, lightweight, and dependency-free experience. Okay, we wrote a simple description. Let's open our repository. You may also remember I added a screenshot. The screenshot of our bar chart. Let's copy its link because I would like to add this image to our README file. Okay, let's commit the README file until now and see the current status of our file. Let's commit. It looks very nice. Let's continue. Let's add the installation guide. Installation. Let's write a simple guide. Download the bar.min.js and include it in your project like this. Script source. Okay, let's add the usage guide. Usage. Let's write something about the usage. To create the bar chart, you will need a block level container like a div or paragraph, and first you need a div like this, chart. This will be bar chart. And then you can create the bar chart objects in your JavaScript file like this. JS var bar charts. It takes 4 parameters: chart ID, chart width, chart height, and the data. Okay, let's explain these parameters. This is very important. This will be the H3 because it's the sub explanation of usage parameters. Let's explain them one by one. First, the chart ID, in other words, container ID. This is a string. Let's define its type. Let's write something about this parameter. It defines the ID of container like charts. This is an example. And let's continue. Chart width, it's integer. It defines the width of the charts like 500, and charts height, again it's integer. It defines the height of the chart like 400. And lastly, we will define the data. Its object array. It defines the data objects, and the objects should have two key value pairs, label and value. These are musts for our objects. Example data JS. Let's open our chart. Example JS. This is our example data. Copy it, paste here, change these values to random numbers. Something like this. The data will be like this. And lastly, I would like to define my license again at the end of my README file. Let's write license MIT, and let's point our license file. I would like to add a copyright sign here, and Alperen, my name or your name, and I would like to copy the address of repository or my name. Copy this address and paste here. Okay, let's commit and open bar.js directly. Okay, when you open bar.js repository, now we have an awesome documentation. We completed our project, we completed our journey. See you on next journeys. Hello everybody, in this lesson we are going to learn how to draw images on canvas. Let's start. To draw images on canvas, we will use this function, draw image function. This function can be used in three different ways. The image draw function can take three different argument sets. These are the all variants. We will examine all of the variants one by one. Let's start with the first one. This one is taking three parameters. This is our canvas. We will draw this image by using this variant of draw image function. This is our image. This is the image, in other words, the first parameter of our function, the image. This is the dx. It's the x-coordinate of the image on the destination canvas. This is the dy. It's the y-coordinate of the image on the destination canvas. So this means this version of draw image function draws the images on canvas on a specific location. dx and dy are the top left coordinates of the image. Let's continue the second variant. In this version, there are two more parameters, dw and dh. dw is the width to draw the image in the destination canvas. dh is the height to draw the image in the destination canvas. So in this version, draw image function draws the image onto a specific location, scale to determine width and height. Now we are able to scale the image. Okay, let's continue to the last version. In this version, there are 9 parameters. In this version, we still have previous parameters, but now we have 4 more parameters: sx, sy, sw, and sh. These are the previous parameters that we learned in the previous implementations: dx, dy, dw, and dh. But we have 4 more parameters: sx, sy, sw, and sh. In this version, we can draw all or part of our image. So this means we can clip the image and we can position this clip part of image. So the sx and the sy are the top left corner coordinates of the clip rectangle, and the sw and the sh are the width and height of clip rectangle. So you can see these are the parameters and their purposes. So if you use this version of draw image function, first the image will be clipped by the sx, sy, sw, and sh parameters, and then the clipped image will be drawn on canvas with dx, dy, dw, and dh specifications. It's the most complicated and most comprehensive version of draw image function. You have all capabilities in your hands. These are the draw image function variants. We learned all of details of this function. Now let's start to coding. This is our canvas, and this is the image that we will draw on our canvas. Let's come back to our code. These are the different draw image function usages. We will experiment them one by one. First, let's create our image object. Var image, new image, and let's set the source, image source. I also added the image to our folder. It's in here. Regular show.png. Okay, we defined our image object. Let's start with our first version of draw image. This one. Copy and paste context and paste it here. First the image is here, and let's define the coordinates. For example, 100 and 100. Let's check the canvas. So where is the image? Let's open the console. Is there any errors? No. The problem is the draw image function fails silently. If the image hasn't been loaded, the draw image function is supposed to do nothing. When you use draw image function, make sure the image loaded and then call the draw image function. Let's go back to our code and fix this issue. Let's close this console. Let's come back. Let's create our fallback function. Let's put our draw image function into this onload fallback. Okay, let's check the canvas again. Nice, we draw our image. Let's play with its coordinates. It's on our canvas now. Let's make this coordinate as 250 and make this 50. I would like to center the image. Let's check. Yes, we centered the image. In this version of draw image, we can position the image wherever we want. Okay, let's continue the second usage of draw image. In the second version, there are 2 more parameters, dw and dh. These are the scale width and scale height of the image. So, if we need to define some values, for example, let's define 100 and 100, we will scale the image smaller than its original size. Let's check. Look, we scaled our image to smaller dimensions. Let's increase these scale values. For example, 400 and 400. And look, it's larger than original size. So in this version, we can scale and position the image. We have 2 controls on images in this version. Okay, let's continue to the last version. As you remember from the slides, in this version, we can clip the image, we can scale this clip image, and we can position the clipped image. As you may remember, these are the clip-related values. These are the position-related values on canvas. So, we have full control on image. In this time, I would like to clip this bluebird. His name is Mordecai. I would like to clip this Mordecai like this part. And I would like to start almost here. So we will start almost here. Here is about 40 and 100, I guess. Let's define 40 and 100. And width and height will be almost, I think, 150 and 250. And I would like to make it a little bit higher than wider. So let's update this as 250 and 400. Okay, let's check. Nice, we clipped the image. You can see the original one is this, and this is our result. We can also position or scale this clipped image in this usage. We have all of the controls in this usage. Yes, in this version takes 9 parameters, but in this version you have the full control of drawing image. It's very nice. We learned how to draw image on canvas in details. See you on next lesson. Hello everybody. In this lesson, we will draw Pokemon characters from a sprite tile. This session is very important because in next lessons we will create sprite animations. This session will be a foundation of these sprite techniques for us. Let's start. This is our canvas and this is our Pokemon tile. We will clip this tile and handle our Pokemons one by one. This is a tile and we will use this tile. Okay, let's start. Let's open canvas and go back to code. First, let's create our image object and draw it on our canvas. Var Pokemon tile. Then let's define its source. Pokemons.png. I already put the image onto our folder. You can see Pokemon PNG. It's in here. Okay, and then let's draw it on our canvas. Pokemon tile onload. Let's draw Pokemon tile 40 and 40. Let's check the canvas. Let's refresh. Look, we draw our entire tile on our canvas. It's larger than our canvas size, therefore it looks like this. It's a huge tile. Let's start to get our Pokemons from this tile one by one. Let's open. First we will get the Pikachu. Let's open our canvas and open our code. Okay. First we need Pikachu. This will be Pikachu. But in this time, we will use the third version of draw image function. Don't forget, we will clip the tile and get this small piece of image from the huge tile. So let's go back to our tile. I calculated the tile width and heights. All of the pieces are 200 and 200. These are the cells, 200 and 200 dimensions. And let's draw our Pikachu. First we need to clip. The clip will be start 0 to 0. 0, 0 to 0. These are the SX and SY. And the width and height will be 200 and 200. We completed these 4 parameters and also 5 parameters. Now we need to define these 4 parameters. First, we need to define the x and y. We can say 0 to 0. And we will define width and height of the Pokemons is 200 and 200. Let's define it as 200 and 200. Let's check the canvas. Nice, we draw Pikachu on our canvas. This is the huge tile. This is the Pikachu. We get the Pikachu from huge tile. Let's continue. Now I would like to have the Squirtle. Its coordinates almost 1 cell and 2 cells from the X origin and 1 cell from the Y origin. Let's draw the Squirtle on our canvas. Skirtle context draw image, or let's copy this one and update the coordinates. First, Skirtle is starting from 200 and 400x, and it's about the 200y, because there is 1 unit distance from the y origin. This is 200. Width and height, SW and SH will be same, 200 and 200. Then let's update the dx and dy. I would like to draw my Skirtle next to the Pikachu. Therefore, I will only increase the x coordinates. Make this 200. And the other ones will be same. Okay, let's check. Look, we draw our Skirtle next to the Pikachu. This is not a perfect tile. The calculations can be misleading. Therefore, we need to edit the coordinates of the Skirtle a little bit. Let's update. Let's make this 180. Check. Nice. Now it's okay. We have a perfect Skirtle. Lastly, we will draw the Bulbasaur. Bulbasaur is 200, 400, 600, 800, and 1000 pixel away from the X origin, and the Y origin is 0. Okay, let's draw Bulbasaur next to the Skirtle. Let's copy Skirtle. Bulbasaur, and the X will be 1000, Y will be 0, width and height will be 200, 200, yes, and the dx will be 400, because I would like to draw the Bulbasaur next to the Skirtle, and width and height will be the 200, yes. Okay, let's check the canvas. Let's refresh. Nice! We draw our Pokemons from our tile. This is our tile. This is our Pokemons that we got from the tile one by one. That's it. So we got the idea drawing items from the huge tiles. After we learned all details of draw image function, it's not so difficult to learn these kind of things. That's it. See you on next lesson. Hello everybody, in this lesson we will draw an image and then we will filter this image by manipulating the pixels. Let's start by drawing our image. This is our image. This is our canvas. We will draw our image to this canvas. First, let's draw the image. Let's create the image object where Amsterdam image, new image, Amsterdam image, source, Amsterdam JPEG. Yes, you can see the image is in here in our folder. I put the image in our folder. Okay, let's draw it. Amsterdam image on load. And let's draw context, draw image, Amsterdam image, 180 and 35. I calculated these values before. Okay, let's check. Let's refresh. Nice. We draw our image on our canvas. Let's go back to our code. As I said at the beginning, we will manipulating the pixels of our image. So what we need is to have all pixels of this image to manipulate it. So let's delete some spaces and handle this cheat sheet. HTML5 is providing some image data functions to us. The create image data, the get image data, and put image data. You can create an image with this create image data function by manipulating the pixels. But for filtering image on canvas, we will use get image data and put image data. First, we will get the image data in terms of pixels as an array, and then we will manipulate these values. After that, we will put this image data back onto the canvas. Yes, these are the functions. Let's get this cheat sheet to put here, because we will write our code inside of the onload function. It's very important to write our code in a safe zone. Before everything, make sure that you are running your code on a local host or a real host. Otherwise, you will face cross-origin issues. I'm using MAMP. If you are using Windows, you can use WAMP. But before everything, make sure that you have a local host. Okay, let's handle the image data by using getImageData. Let's define our variable, image data, context. We will use this function and this. GetImageData function is taking 4 parameters. First two arguments are the top left coordinates of the image, x and y coordinates of the image. So this means these coordinates, top left, and the last two arguments are the width and height of the image, height and width of the image. So our function will take 180, 35. The width of our image is 550 and height is 366. Okay, let's console log this image data. Console log image data. Okay, let's check. Let's open our console and then refresh the page. Look, it's an object which is consisting of 3 key value pairs, data, height and width. We need this data. This is the pixel array. So each pixel in the image contains 4 components: red, green, blue and alpha components. Let's go back to our code. Let's get another cheat sheet that I prepared for you. These are the components of the pixels. So these 4 parameters are represented in the image data 4 by 4. So a pixel is consisting of these 4 parameters. Let's go back. When we open this data, when we open this and this, it's very huge array. So the pixels of image are represented here 4 by 4 according to RGBA representation. RGBA, RGBA, RGBA. Yes, these are the pixel representation. Let's define a loop and handle these values. Let's close this one. Let's write a loop for image data, data length, I++, not I++, it should be I plus 4, because we will handle 4 by 4. Okay, now we can handle the values like this. Image data, data, I, 0, this is the red component. Image data, data, I plus 1, 0. This is the green component. Image data, data, I plus 2, 0. This is the blue component, and lastly image data, I plus 3 equals 0. This is the alpha component, in other words, the opacity component. Okay, this is the process how to handle image data in terms of pixels and manipulate it. So let's update this as 240, 0, 0, 0. Okay. What should we do after this change? We manipulate the pixels by playing with the color codes. We get the image data and manipulate it. Then we need to put this new data to canvas. So this means we should make this context, this thingy. This put image data function is taking 3 parameters: image data, x and y. X and y, as you know, the top left coordinates of the image. First we will put the image data and we will put again the same coordinates, 35, and that's it. Let's check the canvas. Let's refresh. Look, we did it. We set the color of image as black by playing with its pixels. Let's only update the opacity and make the image a little bit blurred. So let's comment out these ones and make this one 50. Let's check again. Nice, we updated the opacity successfully. Let's make more advanced filtering operations. First, we will reverse the colors of the image. In other words, we will apply negative filter. Let's comment out opacity and open other ones. First, I would like to make all of them 255 like this. This is the maximum value of the range that a color can take in the RGB color system. We will subtract the current value of pixel from this maximum value and it will reverse the color. To make it clear, let's implement it and you can see the results more clearly. Let's copy this one and subtract from the upper bound. Let's copy this one and subtract from the upper bound. Let's copy this one, subtract from upper bound. Okay, let's check the canvas. Refresh. Look, our image is filtered negatively. All of the colors are inverted. This is the negative filtering. Let's continue to filtering. Lastly, we will filter the image as black and white base. Let's go back to our code. This is a little bit different filter. The black and white filter takes the average of red, green and blue values of each pixel and assigns this average to each of the pixels. So let's define an average variable here. And let's find the average. Let's get 1 plus 2 divided by 3. Okay, this is the average. Let's copy this, paste here, and here. Okay, let's check the canvas. Let's refresh. Look, we filtered image as black and white. It's an interesting filter. After handling the image data as an array, you can do whatever you want. You can update the opacity, you can update the colors, everything. You have the full control in terms of pixels. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to manage the state of the canvas. Let's start. Yes, we are here. When the drawings has become more complex, you may need a way to revert back to previous state. You may want to manage the current or previous states. Luckily, the HTML5 canvas provides us access to manage the context state. We can save and restore the context state onto a stack. So, the canvas is storing states onto the state stack. Yeah, it's complicated, but state stack. State stack. When a state is saved, it's placed onto this stack. This is our stack. So, we are saving the current state with the save function. This is our save function. You may save many states onto this stack, but don't forget, this is a stack data structure. And the state that was saved first will appear at the bottom and the most recent one will be at the top. A stack's data structure is last in, first out structure, don't forget. Then, if you want to handle the last state from the stack, you should use the restore function. This is our pop function of the stack. Yes, this is restoring the state from the stack. This is saving our state to stack. Yes. Let's draw 3 different colored rectangles which are next to each others and then implement these save and restore options onto these rectangles. Let's start. Rect1, context, fill style, red, context, fill rect, 240, 100, 120, 120. Okay, let's draw the second one. Rect 2. Let's copy the codes and update the values. Green 390, and other ones will be same, and copy this one. This is rect 3. This is blue 1. And the coordinate will be 540. Okay, let's check. Nice. You can see we draw our rectangles. All of the rectangles have different fill colors. So this means all of them are changing the current state of the canvas according to their fill color definitions. So let's save all of these state changes to our state stack. State stack. Let's do context save. And copy this one to here and to here. Nice, we saved 3 states on our stack now. Now let's draw 3 more rectangles below of the previous ones. Let's copy this one. Rect 4. Rect 5 and rect 6. Remove the fill colors. And let's update the coordinates. This will be 300, 200, 300, 300, 300, and this will be the same as 390, 540. Okay, let's check. Look, we draw our new rectangles below of previous ones. You may notice that their colors is blue, which is the same of the third rectangle. Lastly, we updated the state while drawing the third rectangle, and then we haven't done anything related to state. So this means the most up-to-date state is the blue ones. Now we can use the previous states that we saved before. So we call the restore function before our new drawing operations, and we will use the previous states onto these new rectangles. Let's come here, context, restore, and copy this one to this one and this one. Okay, we saved these rectangle states, and now we are using these states onto these rectangles. Let's check the canvas. Look, we got the previous states and applied them onto our new drawings. Order of previous state is coming from first to end. So this is the first in and last out. And this is the last in, first out. This is how stack works. So you can see we can save the state of canvas whenever we want. You got the idea behind how to manage the state of canvas and use it. That's it. See you on next lesson. Hello everybody. In this lesson we will learn how to save canvas as an image on our computer. Let's start. This is our filter image canvas that we did before. We will save this filtered image canvas onto our computer as an image. Let's go back to our code. These are the filter image code pieces. So we will get the image data URL of the canvas, and then we will set this image data URL to the source of an image object. After setting the source of the image, we can right click and download the image as a PNG. First, let's get the image URL. Data URL equals canvas to data URL. Yes, this is a built-in function in the canvas which gives image data URL to us. Let's write explanation. Save canvas image as data URL, default PNG. Okay, we defined our data URL. Now let's define an image object in our HTML file. Okay, let's come here. Let's define ID canvas image, and let's write a simple message. Right click to save image, and that's it. Now let's set the source of this image object as our data URL. So let's go back to our code. Documents, get element by ID. Our ID is canvas image. Now we have the image object, then let's set its source as data URL. Okay, let's check the canvas. Let's refresh. Look, the image is here. Let's right click and save it. You can see we can save the image. Name it Amsterdam. And this is the image. That's it. It's very simple and easy. You will convert canvas to data URL and then assign it this data URL to an image object and you can save the image. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to create patterns on canvas. Let's start. First, let's open this Google search, Google pattern search. These are the patterns. A pattern is a repetitive template. It has a predictable manner, as you can see. It has a pattern. So open canvas and let's go back to our code. In canvas, we have create pattern function. This function repeats the specific image in a specific direction. It takes two parameters, image and repetition. Image is our image object again. Repetition is a string which defines our direction. It can take four different parameters: repeat, repeat x, repeat y, and no repeat parameters. So let's start by creating our pattern image. I put an apple PNG image to here. This is an apple image. I will use this apple as a pattern. So let's create our pattern image. And let's define the source. Okay, let's create the fallback function. As you know, this is an image and we need to use onload function. Okay, we can use create pattern in this safe zone. Let's create our pattern. Context, create pattern. This will take two parameters. First one is pattern image, and second one can be one of these four parameters. I would like to start with repeat. Okay, let's assign this pattern value to our field style. Pattern. Okay, let's draw a rectangle. 0, 0, 900 and 450. This rectangle will cover all of our canvas. Okay, let's check the canvas. Look, we created our repetitive pattern. It repeats in both directions. So, repeat means repeat horizontally and vertically in both directions. And let's update this value as repeat x. Look, it repeats only in x direction. Let's make it y. And let's refresh. Look, it repeats in only the y direction. Lastly, I would like to make it no repeat. No repeats. Let's check. Look, it's not repeating. It only draws one image because it's our template pattern. That's it. In Canvas, we have a create pattern function which takes two parameters. These are image and repetition definition. And repetition can take four different parameters. Repeat in both directions. Repeat x horizontal on the repetition. Repeat y is vertical on a repetition. And no repeat is neither repeat x or repeat y. That's it. See you on next lesson. Hello everybody. In this lesson we will learn how to create gradients on our drawings. Let's start. Until now we draw many objects and we directly fill them with exact colors. But in addition to these exact colors, we can specify gradients for the stroke style and fill style attributes. We have these two functions on Canvas to create gradients. Before examining these two functions, first I would like to create a rectangle. And then we will apply these functions to this rectangle one by one. Let's start with the rectangle. Context, stroke style, blue, context, line width, 4, context, fill style, red, and context red. 240, 40, 420, 420. It will be a huge rectangle, and let's draw and fill. Okay, let's check the canvas. Nice, we draw our rectangle. It's filled by a red color solidly. There is no transition between the colors. But as you know, gradients are creating transition between colors. In Canvas, we have these two functions to create gradients. Create linear gradient, create radial gradient. Create linear gradient. This function is taking 4 parameters. First two parameters are the coordinates of the start point of the gradient transition, and the last two arguments are the coordinates of the endpoint of the gradient transition. And this function is taking 6 parameters. First two arguments are the coordinates of the start circle of the gradient transition, and the third parameter is the radius of the starting circle. Next two parameters are the coordinates of the ending circle of the gradient transition, and lastly this parameter is the radius of the ending circle. Okay, these are the functions to create gradients in Canvas. Let's start with the create linear gradient function. Let's start gradient. Let's copy this one. Okay, I would like to make the gradient from the top left corner to right bottom corner. So this means the gradient will be started in here to here. There will be transition between this point to this point. So the coordinates should be 240, 40, 660 and 680. This is the top left corner's coordinates. This is the right bottom corner coordinates. Then let's assign this gradient to our fill style instead of using red. Okay, let's check the canvas. Look, nothing happened because we haven't defined a color for our gradient. Yes, we defined there must be a transition between this point to this point, but we haven't specified the colors. We should specify our colors. We are specifying the color by using add color stop function of gradient. This must be like this, gradient add color stop. Let's explain this function. Add color stop. This function is taking two parameters, stop and color. Stop is a value between 0 and 1 that represent the position between start and end in a gradient. And color is the color display at the stop position. So let's define some colors. Let's define 0 to red, and let's add one more color stop. 1 white. Okay, let's check. Let's refresh. Look, our gradient is drawn successfully. There's a color transition between this point to this point. You can see red to white. To understand add color stop function better, let's add more color stops. Let's come here, let's copy this one. Okay, we have 5 color stops and I would like to increase them like this. And let's define some colors. Blue, green, orange, and white. Okay, let's check the canvas. Look, we almost drew a rainbow. It looks very nice. You can see the transition between the colors. We added some color stops on specific locations and the gradient created fantastically. Yeah, it looks very nice. Okay, let's comment out this gradient. And let's create a radial gradient. This one is linear. And now we will create radial gradient. Okay, let's start. Also update the name radial gradient and also update this name linear gradients. Okay, let's define our radial gradient. Let's copy this function and then context. In this time, we will draw two circles and the transition will be between these circles. Let's define our circles. I will arbitrarily select the points 570, 380, 300, 570, 300, and 10. And let's copy previous color stubs to this gradient. And let's rename them. Okay, now we can assign this radial gradient to our fill style. Okay, and let's check the canvas. Look, it's a circular. Let's make this 500. Yeah, something like this. You can play whatever you want. For example, like this. Okay, let's make this 20 and refresh. Yeah, this is the radial gradient and this was the linear gradient. Yeah, the most important part is to calculate these values and these values very carefully. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to create animations on canvas. Let's start. To make anything move on the canvas, we need an animation loop. Animation loop is a function called over an interval. It's used to create the canvas and redraw the canvas with the updates. It's the loop function that we will call. These are the steps of the animation loop. First, we will clear the canvas. And then second, we will save the state. Third, we will draw the updates. And lastly, we will restore the state and make these steps a loop like this. Loop and loop. If we look more clearly, first we are updating everything like position, and then we are clearing the canvas to draw something on it, and lastly we are drawing everything back on the canvas. These are the three main steps of the animations, and lastly we are looping these steps again and again. This is the main idea behind how to animate something on the canvas. Let's start the coding to understand these steps better. We will draw a rectangle and then we will update its fill color randomly. To create random colors, we will use this function that we used before for many times. This create random RGB color function, which is consuming from this getRandomInt function. We will use this function to generate random colors. Okay. First, let's define a function to draw random color rectangle. Function draw random colored rectangle, and it will take x, y, width and height. Let's copy these code pieces and remove the comments. Okay, now we have the random colors for the fill and borders. Let's draw the rectangle. Okay, context, begin path, context, fill style, fill color, context, stroke style, border color. Then let's draw the rectangle, x, y, width, height. And let's draw. Okay, we defined our function. Let's call the function. Let's copy this one. Let's call the function in here. And let's set the arguments as randomly 230, 107, 400, and 250. Okay, let's check the canvas. Look, we implemented our function successfully. Look. It's drawing rectangles by generating random colors. Nice. Let's animate this thingy, this color changes. But I would like to randomize everything the x, y, width and height. Therefore, I would like to update the function. Let's remove these thingies. And I would like to generate this value. And I would like to generate these values randomly. X. I will use this function. Zero to canvas width. And let's copy y, 0 to canvas height, and this will be width, this will be height, this will be between 0 to canvas width minus x, and this will be 0 to canvas height minus y. Okay, let's check. Look. Awesome, now we have totally random rectangles. The function works successfully. Let's animate these rectangles. First, I would like to use a while loop, like this. While, true, and call this function. But if you do this, the browser will be locked, like this. It's locked, because JavaScript is running on one thread, and this endless loop will lock it. So you shouldn't try to animate something with a loop, especially with an endless loop. Let's remove this and this. Instead of using an endless loop, we can use window set interval or window set timeout functions, like this. For example, window set interval, and we can call the function in here, and we can define time as 1 second. This is in terms of milliseconds, so this means 1 second. Okay, let's check. Look, it calls the function between the 1 second time intervals. Nice, it's animating. And let's use the other function, set timeout. In this time, as you know, we should call this function again. It's a little bit recursive way. We will call this function at the end of the function. Animate here. Because the purpose of the setTimeout function is to call the first argument function after defined amount of the time. So we are recursively benefiting from this functionality. This will be a recursive manner to make an animation. Let's check. Nice. Again, we animated the rectangles. But these functions are not directly intended for animations. These are the timing functions of JavaScript. Set timeout, set time interval, these are the timing functions. You can animate something with these functions, but it's not an accurate way. Until now, we learned how not to animate some things on canvas. Yeah, we animated some things, but these are the wrong ways. You shouldn't use these manners. Let's remove and remove. There is a specific function to animate something on canvas. Request animation frame function. I defined it before. It's in here. Request animation frame function. It's directly aiming to animate something as smooth and efficient as possible on canvas. It's the most optimized way to create animations on canvas. This is a fallback for different browser compatibility issues for supporting every kind of browsers. If the browser doesn't support the animation frame, it will use set timeout. It's very nice callback. To start animation with request animation frame function, first you call the animation frame function passing by the function as a first frame, something like this, window, and draw random rectangle, and you will conditionally call the request animation frame function inside of the loop. So this means we will call this function in here, like this. But unlike setTimeout and setInterval functions, you can't specify a frame rate. In setTimeout, you can see we were defining a time amount. In this time, browser selects the optimal rate for our frames. So if we check this version, you can see it animates in the most optimal frame rate in our browser. Let's make the rate 1 second again with a conditions. Now it's running about 10 milliseconds. Let's define a condition. We will define our condition in the beginning of our loop function. I would like to make the animation time interval as 1 second. Therefore, I would like to define my condition as null minus start greater and equals than 1 second, 1000 milliseconds. If and start will be null, and let's cover all of these code pieces inside of our if. Yes. Now we can check again. Look, it's animating in the 1 second frame rate. Nice. This is the way how we will animate some things within our defined frame rates. But you may notice that one step is missing in the animation loop lifecycle, the clear canvas state. Let's add our clear canvas to here. Context, clear rect. Okay, let's check the canvas again. Fresh. Look, it's animating perfectly. Now it's a real animation. Something is drawn and canvas is cleared and redrawn, redrawn and redrawn. This is how an animation works on canvas. Update, clear, draw. Update, clear, draw. This is the life cycle of the loop. That's it. See you on next lesson. Hello everybody. In this lab session, we will draw a ball and then we will animate this ball. When this ball collides one of the edges of the canvas, it will bounce. This ball will be a bouncing ball. Let's start. First, let's draw our ball. We will create a function for drawing our ball. Function draw ball x, y, radius and color. First, I would like to define the radian. You may remember from our previous arc operations. It's a shortcut. It's a syntactic sugar for us. And let's begin. Color, context, fill style, color. You may remember we are defining stroke and fill style same, and the black borders will be removed. And let's draw our circle. X, Y, radius 0 from 0 to 360 radians and false. Let's complete our function. Okay, we defined our drawable function. Let's use it. Let's define our variables. Ball x 400, ball y 300, ball radius 30, and ball color orange. Let's use them. Draw ball, ball X, ball Y, ball radius, and ball color. Okay, let's check the canvas. Look, we draw our ball on our canvas. It looks very nice. Let's create the animation loop now. We will move this ball with our animation loop. Let's do... First, let's close this. We will use the request animation frame function. Let's come here. But before everything, let's define our loop. Animation loop. Yes. And let's call it animation loop. And let's put this thingy inside of the animation loop. Animate. You may remember from the previous lesson, this is the idea how we are animating something on canvas. We are defining an animation loop function, and we are calling this animation loop function with request animation frame function. That's it. Okay, let's get this draw ball inside of loop. First, let's clear the canvas. Context, clear rect, 0, 0, canvas width, canvas height. Okay, let's use this. Let's define our draw. Okay, now we need the update state. You may remember in our animation loops lifecycle we have clear, update, and draw steps. The only missing part is the update part. Let's define update. Before updating the coordinates, let's define the update amounts here. Change X for 4 units. I'm defining 4 units. Okay. Okay, we defined the change of X and change of Y amounts. Let's use them. Let's increase the coordinates with them. Ball X, change X, ball Y, change Y. Okay, we defined everything. Let's check the canvas. Look, it's moving. Nice, but it's not bouncing, it's just moving. Because we haven't defined the bouncing conditions yet. Let's define the conditions. Let's come here. First, we will define the bottom edge bouncing condition. So if the ball comes to the bottom edge, it should change its Y movement direction. So it will be ball Y equals canvas height, change the direction of Y. Like this. Let's check. Look, it's bouncing, but the condition should be improved. We are comparing the center of the ball to edge. This is the wrong thing. We should compare the edge of the ball to edge of the canvas. So it will be plus ball radius. Something like this. Let's check. It doesn't work because we created an exact comparison. It's very difficult to catch this condition. Let's make our condition more flexible. So let's make this greater. Let's check. Look, it's bouncing on the bottom edge of the canvas perfectly. Let's define the condition for the right edge of the canvas. Let's make this bottom edge. Let's copy this code. Right edge. This will be ball X. This will be change X. This will be width. Let's check. Awesome, the ball is now bouncing on the bottom and right edges. Let's create other edge conditions. Let's copy this one. Top. Let's copy this one. Left. Let's update them. In that time we will check this condition. 0 and 0. Yeah, that's it. We defined all conditions. Let's check the canvas. Look, it's bouncing perfectly. We did it. We implemented our animations perfectly. Yes, we implemented the steps correctly. Clear canvas, update, and draw. That's it. See you on next lesson. Hello everybody. In this lesson we will learn how to create sprite animations on canvas. Let's start. This is our tile. Sprite is a single image which contains many scenes like this. Several frames of an animation can be included in a single image. You can see our sprite tile has 8 different frames, 8 different movements. These are the different move scenes. I would like the transition between the first 4 frames. This will be our animation. This Game Boy will jump. Close the tile. Before the lesson, I drew the first frames on our canvas. Look. We will smoothly transition between these frames. Let's start by creating our draw tile cell function because we need single cells from the tile. First, let's define the width and height of the cell. Wait. Now we can create the function draw tile cell index, which cell will be drawn. So let's copy this function and let's call the function in here with 2, for example. First, let's draw a cell manually. So I would like to draw, for example, the first cell. Yes, 0 to 0, and cell width, cell height. This will be 360, this will be 300, this will be cell width, this will be cell height. Okay, let's check. Look, our single cell is drawn. Nice. Let's update our function with index because we define an index. We will define this. The coordinate is index times cell width. Y will be 0, yeah, and rest will be same. Okay, so this means if we set the argument as 2, the third cell will be drawn. Let's check. Look, the third cell is drawn. Nice, we created our function. Now let's create our animation loop. Let's come here, function, animation loop, and let's use the request animation frame function with our animation loop. Animation loop, and let's get this thingy to. Now we can define our animation steps. First, let's clear the canvas. Clear. Context. Clear rect. 0, 200. Because I don't want to clear this sheet. Canvas width. Canvas height. Minus 200. Okay, let's check. Okay, it animates and this sheet still exists. Let's continue. Then we need to update the cell numbers. We need to call the cells one by one. 0, 1, 2, 3, 0, 1, 2, 3 with this manner. So I would like to define a variable, counter variable, and I will update this counter, and I would like to ensure that this counter always be within the 0 to 3, inclusively 0 to 3 numbers. So our cell numbers 0, 1, 2, 3, and if the counter has become 4, it should be automatically 0. It should automatically go back to beginning of animation. Therefore, I would like to make a resetting counter 4. And lastly, let's copy this function. We created the animation loop structure. There is one more thing. I would like to set a time for our frame transitionings. So start. And if now minus start greater than equals 100 milliseconds, then transition. And start will be now in that condition. And we made some typo mistakes. Let's update this counter as cell, and let's add cell to here. Okay, it seems nice now. Let's check the canvas. Let's refresh. Look, it animates perfectly. Our cells are transitioning successfully. You can see we are transitioning between these cells. It's very nice animation. This is the main idea, how to create sprite animations on canvas. That's it. See you on next lesson. Hello everybody. In this lab session, we will create a running game hero on a real game background. Let's start. First, let's overview our PNGs. This is our hero. This hero will be running on our canvas, and this is our background. So let's start by drawing this background on our canvas. Let's close this one. Let's start with backgrounds. Source, back PNG. And as usual, let's define the onload function. Let's draw the background. Background 0, 0, canvas width and canvas height. Okay, we draw the background. Let's check the canvas. Look, we draw our background. It looks very nice. Now let's draw our hero, our character, onto here. Let's come here, hero, new image, hero source, sprite PNG, hero onload function. Let's copy this. Hero, remove this part. First, I would like to draw the first cell, this cell. This cell will be 0, 0, 256, 256, 100, 280, 100 and 100. 256 is the width and height of the cells. These are 256 and 256. But I would like to scale these values as to 100. Now let's check the canvas and see our hero on the canvas. Look, our hero is in here. It looks great. Let's animate our hero. First, let's create our animation loop. As usual, function, animation loop, and let's use this function again. animation loop. Let's copy this. Animate. Okay, we created our animation loop successfully. But now I would like to update our code a little bit to make it a little bit tidy. First, let's write comments background character, and let's define some booleans here. Is background loaded false? Is hero loaded false? So put them inside here, true and true. So if the image loaded, the variables will be true, otherwise they will be false. Let's get these functions into the loop. Drove, animate, and let's define the clear state. Context clear rect 0 0 canvas width, canvas height. Okay, the only missing step is update. We will define soon. Before defining update, let's use these variables. If the background is loaded, then draw it. If the hero loaded, then draw it. Nice, we made our code very tidy and more secure now. Let's continue to animate our characters. Let's define some cell specifications. Cell specifications. First, let's define cell width 256 and var cell height 256. Then I would like to define the current cell. Current cell variable will define the animation state on the sprite to define the state of the cell. For example, 0, 1, 2, 3, 4, 5. And let's use variables here. Okay. And let's update here to current cell times cell width. This is the key point of making animations in our case. And then let's define the update conditions. Current cell, and let's reset the cells for every 6 steps because we have 6 scenes on our tile and we have to reset to beginning in every 6 steps. Now, and lastly, let's update this one and let's check the canvas. Look, our hero is animating, but we need to define a time for our animation. Let's define time specifications, animation start, and animation now. If animation now minus animation start greater than equals than 100, which means 100 milliseconds, and then animate it. Otherwise, do nothing. And let's assign the animation start, animation now. Okay, let's check the canvas now. Look, our hero is animating very smoothly, very nicely. Now let's move our hero to the right. Let's define our move specifications. Move amount 5, move x 100. Let's make this move x, and let's update the move x with here by move amount. Okay, let's check the canvas. Look, our hero is walking now. She is walking very smoothly, very nicely. Lastly, we have one more thing to do. We will define a condition. We will define a condition for move x, because our hero is going to the right and then she is disappearing. I would like to make her to come back here and then continue, come back here, continue, like this, a loop animation. So first make this move x greater than equals than canvas width move x equals, reverse the amount, cell width, else increase the move x. Okay, let's check the canvas again. And also I would like to increase the speed. Okay, refresh. Yes, she is back. She is back. She is walking very smoothly, very fastly, and she is coming back from the left. She is disappearing from right and coming from the left. It's very nice. I think this hero and this background can be a good game. You can see. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to scale the canvas context. Let's start. The transformation operations on canvas are changing the current context. So the scale function is scaling to the current context drawings to bigger or smaller size according to our definition. If you scale the context once, all future drawings will also be scaled. The position, size, and everything will also be scaled. This is a small cheat sheet for our function, scale function. The function is taking two parameters, horizontal scale factor, vertical scale factor. Don't forget, this function is scaling the canvas context, not the objects or drawings. It scales the canvas context. The parameters of the functions are double numbers which defines the scale amount of the context in terms of percentage. For example, if you define it 1, it means 100. The default value of the scale of the canvas is 1. For example, if you use scale like 2 and 2, the context will be scaled twice as far from the left and top of the canvas. 2 means 2 times 200. So this means 200 and 200 percentage. So to sum up, the scale function scales the canvas context with our defined ratio amounts. Let's start by drawing a red rectangle. Context, fill style, red, context, fill rect, 50, 100, 40, and draw it. Okay, let's check the canvas. Nice, we draw our rectangle. Now let's use the scale function to scale our context. Scale, context, scale. Let's scale the context for twice in terms of horizontal and vertical. And now let's draw a blue rectangle with the same parameters. Let's copy this one. blue rectangle, blue. As you can see, only the color is different, everything is same. Let's check the canvas now. Look, blue rectangle is on the different location, but they identically have the same parameters. They have same parameters, totally same, but their location is totally different. Okay, let's scale the context again and draw one more rectangle. Let's copy scale. And let's copy blue rectangle. I would like to draw a green rectangle. Again, the parameters are same. You can see all of their parameters are same. The only difference is the scale of the context. So let's check the canvas again. Look, this rectangle is also on a different location. You can see we define all the parameters of the rectangles as same, but they are on totally different location. The thing is that we scaled the context and initial values don't have the same meanings. So the initial 50 is not the same 50 anymore. Initial 100 is not the same 100 anymore. All of the values are enhanced. You can see all of the values enhanced. They are all same, but they are on different locations. But enhance is not the only option. We can scale our context to the smaller values than initial state. As I said before, originally the scale value was 1 and 1. If you do 1, 1, 1, the rectangles will be overlapped. The only green rectangle is visible because other rectangles are hidden behind it. They have the same parameters and all of them are drawn one by one onto each other. So 1 is the default value, as you can see. Let's decrease the scale values less than 1 and observe the diminish of the context. First, update our coordinates. 200, 250, 400. Yes, again they will have same parameters. Okay, let's check. Nice, all of them are here. Again, the green one is visible because other ones are behind of it. And now let's scale the context less than 1. Let's check the canvas again. Look, you can see the second rectangle has become smaller than the first rectangle. This is our first rectangle, the red rectangle. This is our second rectangle, smaller than the first one. And the third rectangle has become smaller than the blue one. We scaled to our context to smaller sizes. Our context is diminished. You can see they are diminished. You can see the values are smaller now. You can see initial 250 is not 250 anymore. It's smaller than initial value. In previous examples, it was bigger than the initial value. Now we diminish the context. We are scaling the context according to our definition and the value has different meanings according to new context. We are scaling everything. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to rotate the canvas context. Let's start. Again, we are transforming the context of canvas in a reverse the transformation matrix. And at the beginning, I defined the radian variable here as always. It's a 1 unit radian because we will rotate the context in radians and this syntactic sugar will help us to reduce the code complexity. This is our cheat sheet about the rotate function. The rotate function is basically rotates the context in terms of the radians. But don't forget, this function is rotating the context in clockwise direction, not anti-clockwise direction. The function is taking only one parameter, which is rotation amount in terms of radian, rotation amount. The rotation will only affect drawings made after the rotation is done, like scale function. The drawings before the rotation canvas will not be affected by this rotate function. The new drawings will be affected after the rotate used. Okay, let's start by drawing a rectangle. Context, style, red, context, fill rect, 250, 250, 400 and 160, and let's draw. Let's check the canvas. Nice, we draw our rectangle. So if we want to rotate this rectangle, we should define our rotation function before the drawings. This means we should call the rotate in here. Let's rotate. I would like to rotate about 10 radians. Okay, let's check. Look, it's rotated about 10 radians. Let's update the rotation value. I would like to make it minus 10 radian. You can see it's rotated to the upper bound in anti-clockwise direction. And let's change the value again. Make 50. Look, it disappeared. Because the rotation center point is the canvas origin. In other words, this point, the left top of the canvas. While you are using this rotation function, you should be aware about this. But also you can change the center point of the rotation. We need to move the origin of canvas to another point by using translate function. We will learn it the next lesson. For now, rotation is this. You can use the rotate function by passing the rotation amount in terms of radian, and the context will be rotated. That's it. See you on next lesson. Hello everybody. In this lesson, we will learn how to translate the canvas context. Let's start. The main purpose of the translate function is to move the canvas to the new location, and the origin of the canvas will be a new defined point. This is our small cheat sheet. The translate function is taking two parameters, which are x and y values. The main purpose of the translate function is move to the canvas and its origin to the new location. So x and y are the coordinates of the new origin. Now let's start by drawing a rectangle as usual. Rectangle, context, fill style, context, fill rect, 50, 50, 160, 160, and draw. Let's check. Nice, our rectangle is on the top left corner of the canvas. So what will happen if we translate the canvas and redraw the same rectangle with the same parameters? Let's check. Translate canvas. Context, translate. We are going to move to our canvas origin from 0 to 0 to 300 to 200. And let's redraw the rectangle again. So this is original. This is translated rectangle. Okay, let's check. Look, second rectangle is drawn to a different location on canvas because we translated our canvas. Even they have totally same values in terms of the coordinates with height and color, you can see their location is totally different. We updated the origin of the canvas. Our new origin 300 and 200. At the beginning the origin was here, but now it's almost here. So don't forget, once the context has been translated, the new drawings will be based on this new translated canvas, and the result will be on our new context. So we translated our context to do here. Now it's on here. This is our drawing region, and the new drawings will be based on this region. That's it. We translated, we moved the canvas. This is the main idea behind the translate function. See you on next lesson. Hello everybody. In this lesson, we will learn the transform and the set transform function on canvas. Let's start. Until now, we learned scale, rotate, translate. All of these functions are manipulating the transformation matrix of the canvas context. Transformation matrix is 3 by 3 matrix. Whenever you draw anything onto canvas, whether a shape, text, or image, The browser applies the transformation matrix to the object that you are drawing. By default, the transformation matrix is the identity matrix. When you use scale, rotate, or translate function, you are modifying the transformation matrix. Therefore, it's affecting all future drawings. We are using 6 values of this matrix. The first one, M11, represents the horizontal scaling. The second one, M12, represents the horizontal skewing. The third one, M21, represents the vertical skewing. And the fourth one, M22, represents the vertical scaling. And the fifth one, dx, represents the horizontal moving. And the sixth one, dy, represents the vertical moving. So the initial state is this. If we use the scale function, the matrix will be updated like this. If we use the translate function, the matrix will be updated like this. And lastly, if we use the rotate function, the matrix will be updated like this. So this is how the transformation matrix is being used while scaling, rotating, and translating. So this means we can do the same functionalities only by playing with the transformation matrix. The reason why we have scale, rotate, and translate function is to reduce the complexity of editing transformation matrix. However, we can directly touch the transformation matrix. To modify the transformation matrix, we have transform function. This function is directly taking these 6 parameters. We can direct access to matrix with this transform function. So this means we can scale the context by using transform function like this. They are doing the same thing, scale function and this transform function, by taking these parameters of the transform function. And we can rotate like this. And we can translate like this. And in addition to these built-in transformation functions, we can skew like this. We have one more option now, skew. So these are the functionalities that we can do with the transform function. The initial value of the transformation matrix is the identity matrix, as we said before. If we use transform function once, the transformation matrix will be updated, and if we use the transform again, the updated version of the matrix will be used. So we will continue on the updated context. If we want to start to transform from the initial context for every operations, we have set transform function. This function has a different manner for transforming something. First, it's resetting the current transformation matrix to the identity matrix and then makes a transformation. It takes the same parameters as transform function. So the difference between transform and the set transform is the approach of transformation. The transform continues from the current context and the set transform continues from the initial context. These are the main difference between transform and set transform functions. And lastly, we have one more function, reset transform function. This function resets the current matrix to identity matrix. But you can also use the set transform function like this with the same purpose. These are the same functionalities, reset transform and this set transform function usage. That's it. Let's start the coding now. These are our custom transformation functions, transform, set transform, and reset transform. Let's start by drawing a rectangle as usual. Red rectangle, context, style, context, fill rect, 150, 150, 200 and 100, context, fill. Fill is not so necessary for this fill rect function, but I like to use fill. It makes me feel more secure. And then I would like to scale the context with the transform function. Scale transform, context, transform. I would like to enhance the context. Okay, we enhanced the context. Let's draw one more rectangle. Let's copy this one. Blue, blue. They all have same values. The only difference is the fill style. And then let's scale the context again. And let's draw one more rectangle. This one. This time I would like to draw a green rectangle. And green. Okay, as you can see, all of the rectangles have the same values, same coordinates, same widths, and same heights. The only difference is the color. And the only difference is the different context drawings, because we are scaling the context in here and in here. Okay, let's check the canvas. Look, we implemented the scale functionality with transform function. We use the transform function, we scale the context. All of the rectangles have the same width, same height, and same coordinates. But the context is enhanced. Therefore, they are on the different locations. You can see, we use the transform function with the scale purpose. And now I would like to use the set transform function. You may remember, set transform function have a different approach to transformations. The transform function is going to transform the context from the previous transform context, but the set transform function is started from the initial state. So let's do set transform function and let's check. Look, the last two rectangles are overlapped because the context scale operation is reset before the transformation. It starts from the initial state and then it's scaled. This means the context is enhanced in here, yes, and then it does the same thing. It goes the initial state and then enhance. It goes the initial state and then enhanced. This is the purpose of set transform function. It resets the context and then transform. So you can use many of them like this, purple, and then the result will be same. Because the context is resetted and then transformed. So this is the approach of set transform. If I update the functions again transform, you will see it will continue from the enhanced context. Look, they continue from the enhanced context. Therefore, they are on the different locations. And lastly, let's use the reset transform. I would like to reset the transformation in here. Okay, and I would like to reset in here. So this means we have only one transformations here. Okay, let's check. Look, they are overlapped because we reset the transformation. In other words, we set the transformation matrix as identity matrix. It's resetted now. Yes, these are the transformation functions and these are their usages. See you on next lesson. Hello everybody. Before starting to our physics applications lessons, I would like to demonstrate our ball class, its usage, and our basic template for next lessons. I created this ball class for our physics lessons. We will apply physics onto this ball. It's very similar to a real ball. It has a radius, color, x and y the center coordinates of the ball, mass, it has a mass. It has a velocity in terms of two directions, x and y, and lastly, it has a context variable. This is very important variable because this will be the context that the ball will be drawn. Don't forget to assign drawing context to your ball, otherwise you can see the ball on your canvas. And also, ball has a one function, draw function. It draws the ball on the defined context with center x and the center y coordinates. So this is the main structure of our ball. We will work object-oriented. We will create our ball objects from this class. This will reduce our code complexity and this will be more organized for our physics applications. This is our current canvas that we will work throughout the physics lessons. Let's start by creating a ball object. I want to draw a green ball on our canvas. But don't forget, make sure that you included your ball.js before canvas script.js. Otherwise, you can't use the ball class to create your objects. Okay. This is our main structure of canvas script. We will use this pattern, this template for every lessons. We will start from this pattern every single lesson. Let's create our ball, new ball. As I said before, I would like to draw a green ball. I would like to define the radius as 30 and color as green. Okay, we create. Now we can assign our variables. First, the center coordinates. I would like to draw on 100 and 250. And as you may remember, this is the most important part of creating a ball object. We should set the context to ball. Otherwise, ball can't know the context and it will be on the air, not on your canvas. Nice, we set all necessary variables. Now we can draw it. You can see, that's it. We defined the center coordinates, we assigned the context to our ball, and we are drawing it. It's very easy. Let's check. We can't see because our animation is running. First, we should close the animation. In the animation, there is a clear rect, and it clears the canvas, so close the animation. Let's check the canvas again. Okay, nice. We draw our ball. We can update the coordinates and the color. Let's make the coordinate of x as 400 and y as 320. And I would like to make the color as purple. Everything seems okay. Let's check. Nice. It's a purple ball on a different location now. It works. Our ball implementation successfully works. This is important because our code has become more object-oriented now. We are reducing the code complexity and we are more organized now. The only thing that we need to draw a new ball is just creating a ball object. That's it. This is our physical object that we will use throughout the physics lessons. See you on next lesson. Hello everybody. In this lesson, we will learn how to add velocity to our ball objects. Let's start by some basics. What is velocity? Velocity is the rate of the change in an object's position. Velocity is a magnitude and direction. It's a vectorial quantity. To sum up, it's the most basic property of something that moves. Let's start by drawing a red ball on our canvas. Ball, new ball, and the radius as 30, color as red. Let's define the properties of the ball. Ball x equals 100, ball y equals 150, and the most important part, yes, the context. I'm always saying this is the most important part because if you don't assign the context to your ball, you can't draw it onto your canvas. And let's draw. And close the animation for now. And let's check. Nice, it's drawn. Now I would like to move our ball to the right in this direction. Okay, let's define our velocity. I would like to define our velocity in here. Velocity. And first we will move in the x direction, the horizontal direction. Therefore, we need to assign a vx, for example 1. And we can update our placement according to our velocity. So open the animation and come here. we need to update the center coordinate of the ball according to our velocity. So this will be ball x should be plus v, and let's draw it. That's it. You will see our ball will be moved to the right now because we define a positive velocity, which means it will move to the right. Let's check. Look, it moves to the right and it has a constant velocity. Okay, let's increase the velocity. Let's make it 5. Look, it moves faster now. Let's move our ball in the vertical direction by defining a velocity y. Ball Vy equals 1. But for now I just want to move in the vertical directions, therefore I will comment out the horizontal x and horizontal updates. And let's update y. That's it. Let's check the canvas. Look, it's moving in the vertical direction. Let's increase the vertical velocity a little bit more. Let's make it 5. Yes, it's moving faster in the vertical direction. We succeed. The ball can have vertical and horizontal velocity now. So, what will happen if the ball has both vertical and horizontal velocity? So, let's open this command. And now it has both vertical and horizontal velocity. Let's check. Look, it moves in both directions now. Both vertical and horizontal movements. You can update the velocities according to your choice. For example, you can make them minus. And let's check. Look, it moves to a different location. Because we update the vertical velocity as minus, this means the reverse direction. You can do the same thing to here. Look, it moves to the top left corner and you can make this positive. And it moves to the bottom left corner and lastly make it positive. It moves to the right bottom corner. Yes, that's it. Now our ball has both vertical and horizontal velocity skills. See you on next lesson. Hello everybody. In this lesson we will learn how to add acceleration to our ball objects. Let's start with some basics. What is acceleration? Acceleration is the rate of change of velocity of an object with respect to time. It's again a vectorial quantity. It's represented by this formula, the change of velocity over a time interval. So the most basic meaning of acceleration is the change on the velocity over the time period. That's it. Let's start by drawing a green ball on our canvas. Ball, new ball, 20 and green. And let's define the properties. And the most important one, context. And let's draw. And don't forget to close the animation. It's clearing the canvas. Okay, let's check. Nice. It's drawn. It's in here. First, let's move this ball to the right in this direction. So, open the animation and define our velocity. Vx 1, and we need to update our placement according to this velocity. So this means will be plus Vx, and we need to draw the ball after the clear of canvas. Okay, let's check the canvas now. Nice, it moves horizontally to the right. but the velocity is constant. We need an acceleration for increasing the velocity of the ball. So let's define our horizontal acceleration. Let's define acceleration. Horizontal acceleration is 0.05. And we can update our velocity according to this acceleration. Ball Vx should be plus. Okay, our velocity is increasing by the acceleration amount. Let's check the canvas. Look, the velocity of the ball increasing according to our acceleration. We can also increase this acceleration as 1, for example. Look, it's gaining the velocity faster now. Nice. Let's move our ball in vertical direction. Now it's moving in the horizontal direction. First, let's close this horizontal movements because now I just want to move in the vertical direction. And we need to define the velocity for vertical sides. Okay, let's check. Nice, it moves in the vertical direction. Again, it's moving constantly. Let's define our vertical acceleration. For AY equals 0.05. Also make this one again 0.05. And Y X ball VY ball VY plus AY. Okay, let's check. Look, it's moving in an increasing velocity. Nice. We can also increase the acceleration again as 1. Oh, it's very faster now. Nice. Now we know how to use acceleration in both directions. What will happen if we use acceleration as a negative value? Let's make the AY as negative. And let's check. Our ball is slowing down and changing its move direction. You can see. Let's refresh again. It was trying to go down, but it slows down and then go to the upper side. Because the negative acceleration first stops the ball and then increases its velocity in the negative direction. We can do the reverse scenario. Let's make this positive and this one negative. But also I want to decrease the acceleration value. Okay, let's check. Look, the ball moves in the negative direction. And then the acceleration is slowing down the ball. After the velocity has become 0, the acceleration is going on to increase the velocity. And then the velocity has become a positive value. You can see. Let's increase the velocity a little bit. Let's check. You can see more clearly now. The ball is trying to go into the negative direction, but the acceleration prevents it. And then the velocity has become positive and increasing and increasing. You can see. That's it for now. We learned velocity and acceleration in depth. That's it for now. See you on next lesson. Hello everybody. In this lesson, we will learn how to vertically projectile our ball. We will cover 3 different scenarios. First, the free fall. This is the jump of Felix, which is one of the most famous free fall. He broke the sound barrier. You can see. He jumps from the space to the earth ground. And then second, fall with initial velocity. Like this. Jumping from an initial velocity. And third, the vertical projectile from bottom to top with initial velocity. Okay, let's start the coding with free fall. In this time, our acceleration is the gravity. So let's define our gravity. But it's also so high for our canvas, our reality. This is the accurate value of the gravity on Earth. We should make it about 0 points, something like this. And let's draw a ball. This is the ball 1. It will be 20 radius and blue color. And the x coordinate will be 400. Y coordinate will be 80. And the most important part that you can understand is the context. And let's draw. And let's close the animation for now. Let's check. Nice, we will make a free fall. There will be no change on the horizontal velocity. Therefore, we will only play with the vertical velocity. So let's define the vertical velocity. Open the animation. Velocity. Ball1 dot vy equals 0. In the free fall, there is no initial velocity, and the vertical velocity is increasing with the gravity. So it's the initial value. And let's update our animation loop. Ball1 vy equals ball1 vy plus gravity. And then we need to update the y coordinate of the ball with the vy. Okay, and let's draw it. Okay, let's check. Nice. Let's decrease the gravity a little bit because it's again so much for our velocity. Yeah, now we can easily simulate the free fall. You can see the initial velocity was 0 and then it's gaining a velocity because of the gravity. It's falling. Okay, let's draw one more ball and add an initial velocity to this new ball. First, I would like to update this coordinates to 100 and let's copy this. This will be ball 2 and its x coordinate will be 300, y can be same, the color will be green. And let's update these variables. Okay, we defined our second ball and let's define its velocity vy as 2 and let's implement the same things to the second ball, but it's a little bit complicated. Let's add some commands. And indent, yes, and update this to ball 2, and let's draw it. Okay, let's check the canvas and we will see the difference between the free fall with an initial velocity and without initial velocity. Look, green is moving faster because it's starting with a velocity. It has an initial velocity. Yeah, it starts the race with an initial velocity. Let's increase the initial velocity more, for example 5. Whoa, it's faster now. Green is faster. And lastly, let's draw one more ball for vertical projectile from bottom to top with an initial velocity. So come here. Let's copy this. Ball 3. We can remove these draws because we are drawing balls inside of the animation loop. These are just the declarations, the creations of the objects. And this ball will be red. And update these variables. And the coordinate will be 500 x and 500 y. And it should have a negative velocity initially because we will throw it from bottom to top and it's the negative direction. So ball 3 Vy should at least negative minus 10. Let's copy this once. Ball 3. Okay, and let's draw it. Everything looks fine. Let's check. Nice. You can see we simulated 3 different vertical projections. Free fall without the initial velocity, free fall with initial velocity, and vertical projectile from bottom to top. The most interesting one is the red one, because it's losing its velocity due to the gravity, and after total velocity has become 0, it starts to make a free fall. These are the basic physics for vertical motion with gravity. Our acceleration is gravity, and these are the basic vertical projections. In next lesson, we will also add horizontal motion to these projections. See you on next lesson. Hello everybody. In this lesson, we will learn momentum in one direction. Let's start. So, what is momentum? It's the product of the mass and the velocity of an object, and it's very important that it has to be conserved. What I mean is, the total momentum is always conserved. This is the formula of the momentum. The momentum before the collision and the momentum after the collision are equals. So we have this formula, and also we have the energy formula. After resolving this momentum equation and the energy equation, we can find that the velocity after the collision with these formulas. The new velocities can be found with these formulas after the collision. But don't forget, these formulas are valid for the elastic collisions. So now we need to find two things. First, the collision moments, and second, the conservation of the total momentum. In other words, the new velocities. Let's start the coding. Let's start by drawing two different weighted balls on our canvas. First, I will draw the large one. Large ball. Okay, let's check. Nice, we draw our large ball. But I also want to define a mass for this ball, because we will handle the momentum, and momentum is the product of mass and velocity. So I would like to define a mass as 10. And let's draw the small ball. make this ball 2. This one will be 30 radius and the color will be green, and the coordinates will be 550 and y will be same. The mass will be 6. Okay, everything seems okay. Let's check. Nice, we draw our smaller ball. Now we will move these balls. This large blue ball will move to the right, and this small green ball move to the left, and they will collide. Let's move them. Open the animation. Again, first we need the velocities. In this example, we will only use the horizontal velocity, so will be 6, and ball 2 Vx will be -3. Okay, we defined our velocities. Let's update our animation loop. We will complete our simulation step by step. First, I would like to move the balls. Ball 1 dot x will be plus Vx, and ball 2 plus Vx, and let's draw them. Okay, let's check. Nice, they are moving. Awesome. First, I would like to handle these edge cases. You can see we have edges on our canvas, and I want my balls bounce when they collide to edges. So we should handle these edge cases. We will check the edge cases in here. Detect edge collisions. First, I would like to check for the ball 1. If ball 1 x plus ball 1 radius greater than the canvas width, this means the ball has come to the right, or again the ball 1 x minus r less than 0, this means the ball has come to the left edge. Bounce it. This means reverse its velocity. We should do same thing for the ball 2. This is ball 1, ball 1, ball 2, ball 2, and this is also ball 1.r, ball 2.r. Okay, let's check. Nice, they are bouncing. Awesome. Now we need to detect the collision of the balls. Now they are passing onto each other by overlapping, but they should bounce after they collide. First, we need to detect their collision moment. Let's detect ball collisions. If in that time I will use a simple mathematical equation. The difference of their x coordinates should be less than the total of their radius. So this means x minus x should be less than ball 1 r plus ball 2 r. This is the collision mode. We can check collision. Let's open the console and refresh. You can see they collide, they collide, they collide, they collide, they collide, they collide. Okay, our detection works perfectly. So we need to find their new velocities after the collision. Now we need the equation of the momentum that we learned in the presentation. In that time, we should do one by one. But let's open a small reminder. This is our formula to find our new velocities. First, I would like to find the first Mole's velocity with this formula, where velocity 1, the difference of their mass, ball 1 m, ball 2 m, times ball 1 Vx divided the total of the masses, ball 1 m plus ball 2 m plus 2m2 weight by 2 plus 2 times ball 2 m times ball 2 velocity divides. We can separate this equation like this to make it more readable. The total of the masses. Let's copy this part. Yes, we find the new velocity. Let's assign it. Ball 1 Vx equals V1. And let's find the second velocity. Let's copy this one to here. New velocity after collision. New velocity of ball 1 ball 2. Okay, let's do this y2 ball 2. We should reverse everything. Every ball 1 should ball 2. So ball 2 ball 1 ball 2 ball 2 ball 1 ball 1 ball 1, and then it's okay. Okay, we are finding the new velocity of ball x1 in here, but we are using new velocity in the formula. We should use old velocity to find the new velocity. So we should assign all of the new velocities after the calculations. These calculations must be done in the previous velocity value amounts. Yes, that's it. Okay, let's check. Let's refresh. Look, they are making elastic collisions. It's very nice. They look like a billiard ball. Their mass are different, their initial velocities are different, and the total momentum is conserved. You can see. You can see it's more realistic movement now. We can update the velocities. 5, 10, for example. Yeah, is directly related to their mass and initial velocities. We can change their mass, for example, 100. You will see. Ooh, because the blue one is very weight. Next lesson we will use both vertical and horizontal velocity together and we will create more balls on our canvas. See you on next lesson. Hello everybody. In this lesson we will add more balls on our canvas and then we will add vertical velocity to these balls. So this means we will handle vertical and horizontal momentum on our canvas. We will continue from the code of previous lesson. First, let's comment out everything. Okay, they are comment out. First, we will create our ball array and we will add our balls into this array. Let's create our balls. Ball. We need a radius. So let's define our radius. I would like to generate the radius of the balls randomly, so we need a random generator function. You may remember this function from previous examples, previous lessons. We use this function for many times. Again, we will use. Let's copy it. Let's put the function bottom of our page. Now we have a getRandomInt function. Now we have a random generator between this interval. Let's call it getRandomInt. The radiuses will be between 10 to 25. Now we can set the properties of the ball. I would like to set the numbers randomly, so x can be between radius to canvas width minus radius, and y will be radius to and let's set a mass. We can assign to radius and the context. Lastly, let's draw it and push to balls array. Okay, let's check the canvas. Nice. We created a random ball generator. You can see. Every refresh generates random balls on our canvas. Now let's define their initial velocities randomly. Let's do getRandomInt. It can be between 0 to 20 minus 10 because I would like to define the velocity between negative and positive values randomly. Y. Okay, we defined the velocities randomly. We are ready to animate our balls. So let's copy our animation loop and clear inside of it. Clear. Okay, now we are ready to animate. We created our balls. We can draw them and we will animate them. So I would like to update the coordinates of the balls according to their velocities and draw the balls with their new coordinates. In this time we have many balls, 10 balls, so we need more complex functions. I will create two functions. First, move functions, which takes a ball argument, and updates its coordinate according to its velocity. And we need a general function for looping over all of the balls to move all of them one by one. Function move balls. Move balls. Move balls I. Okay, let's call this function in here. And there's one more thing. We need to draw balls with their new coordinates. So copy this. Make it draw balls. And call it to here. Okay, everything is ready for animation. Let's check. Look, they are animating, they are moving. Oh, there's so much thing that we need to do. First, we will handle the edge cases. You may remember from the previous lesson. When they touch the edge, they should bounce. Okay, so we need a generic function to check edge situation which takes ball as a parameter. Let's copy this one. Check edge. We can benefit from previous definitions. We have edge conditions. We can do and this is the horizontal edge. We need vertical edge condition. So copy this one. This should be height and this should be y, vy, ball, 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 y, 0. Okay, and we need a general function for looping all of the cases. Or we can use this function inside of the move function in here. For example, check edge, ball. I think it's okay for here. We don't need to re-loop again. There's also a loop and we are benefiting from this loop. Okay, let's check. Nice. Now the most difficult part has come. We will bounce from the collision of the balls. Again, we need to loop all of the balls. In this time, we will check the collisions 2 ball by 2 ball. So we need a function to check the collision of the 2 balls, and then we will loop 2 by 2 over the balls to check the collisions. We will check for every step. Okay, let's create our function. Function is collided ball 2. We also experience the collision check. Let's benefit from this. This is the is collided part. Return. Or, because this was for the x coordinate, y. Yes, it's better now. You can see we are checking in terms of x and y. Nice. Now we need a general function to loop all of the balls. Function check ball collisions and first we need a ball and the second loop and we need a second ball and we need to check is collided. Ball 1, ball 2. Let's check. And let's call this function in here. Okay. Okay, let's check the canvas. Open the console. Fresh. You can see we can detect the collisions. There are many collisions. Okay. Now the only thing, when the collision happens, we should update the velocities according to the momentum conservation. So we have the equations, copy them. Let's paste here. But all of these are for the horizontal velocity. Let's write so. And we need the vertical version. Vertical. Vertical. So this will be Vy, Vy. This will be Vx1, Vx1, Vx2, Vx2, Vy1, Vy2, Okay, let's update this one to Vy, 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 Vy. Okay, it seems everything is alright. We are handling both horizontal and vertical velocity of the ball after the collision, so we are preserving the momentum total. Let's check. They are moving very weirdly because we made a mistake. This equation should be and, not or. Let's check it again. Nice. Now they are colliding elastically. You can see. Nice. We did it. We preserved the momentum on two axes. Yes, we can improve the equations, but this is a good beginning for you to understand momentum, physics, and everything. That's it for now. See you on next lesson. Hello everybody. In this lesson, we will learn how to handle key events, in other words, the events which are coming from the keyboard interaction. Let's start. When we press a key on keyboard, the browser generates a key event. This event is directly aiming the focused HTML element. But Canvas is not a focusable HTML element. Therefore, we will handle the event by listening the window object. There are three types of key events that we can handle: key down, key press, and key up. Let's start with the key down event. Let's create our event listener. key down, fallback function. Okay, and let's log our event. This is the object which thrown after the interaction. Open the console, browser console, and refresh the page. Nice. Now you can click some keys on your keyboard like this. You can see we are handling the key down event, and the logged event shows our key, which key we pressed. You can see there are many parameters inside of the event. Alt key, bubbles, cancel bubble, code, and also key code, key. There are many parameters, but we are only interested in the key and key code parameters. Let's update our console. And also I can add okay, let's check it again. Refresh and click some things. Nice. We are handling the key and its code. Okay, let's handle these key down events. For example, when I click A, I would like to do something. And the most basic approach is writing an if condition. Event key code 65. This is the code of A. Console log A pressed. Remove this. And also we can add more conditions, for example, for B. Else if B pressed. Nice, we handled the A and B keys. We can continue like this, else if, for example, C. Continue and continue. There are many complexity in this way. As if, but you can see, yes, you can do this, but it's not clear, it's not understandable. We need to reduce our code complexity. Therefore, we will define a key map. This key map is a dictionary that we can directly map the keys to their key codes. Let's define it here. Let's write commands. Keyboard definitions and key code. It's an object, therefore we can directly map with this object by using the keys. I would like to define the arrow keys, but I don't know their codes, therefore we need to console the event again and handle the codes. Left arrow, up arrow, right arrow, and down arrow. Let's open 37, 38, 39, and I guess 40. Yes, 40. Okay, I got the key codes. Let's define them. First, left, 37. Up, 38. right 39 and down 40. Okay, we defined our keys. Let's handle these keys in the fallback of the event. In here, we have the event object and we can handle them. The most common way to handle these keys in a fallback function is using a switch. You can do the same thing by using if-else conditions, but switch is more clear to understand. Let's define our switch. You can see the switch structure. Okay, we will put the event key code into the switch, and there is no default condition, we will handle the cases. Our first case will be key code left, for example console log left arrow pressed, and let's copy this. Okay, let's handle other arrows. Up, right, and down. Okay. You can see we handle the keys more clearly. The key code is coming into the switch and it's trying to match these conditions. So this means we are only handling the defined key codes. It's very clear. Okay, let's check. Let's refresh. Now I'm pressing many keys on the keyboard, but you can see nothing happens. But if I click the left arrow, it catches the event. When I click up arrow, it's handled. When I click other arrows, they are handled. Because we are only handling these keys. We defined our key code map and we are handling these keys. It's very explicit and understandable manner to handle the key codes like this. So if you are writing a game, you can use these controls because in game development, arrows are very important to handle. This is the idea how to use the key events. You can try key press and key up. Next lesson, we will handle the mouse events on canvas. See you on next lesson. Hello everybody. In this lesson, we will learn how to handle the mouse events on our canvas. Let's start. You can see there are many mouse events that we can handle. Mouse down, mouse up, mouse over, mouse out, mouse move, click and double click. Mouse down and mouse up are the events that mouse button is clicked or released over an element. Mouse over and mouse out events are the events that mouse pointer comes over or out from an element. Mouse move event is an event that every mouse move over an element triggers this event. And click is the event which triggers after mouse down and then mouse up over the same element. And the double click is the event that triggers after a double click over an element. To click means double click. And let's define our event listener and start with mouse down and mouse up events. Let's define two event listeners and use these events. So in this time, instead of attaching our listeners to the window object, we will use canvas at event listener, copy, and first mouse down function event. mouse up. Okay, and let's write something inside of the fallback function. Console log mouse down, and also console log event object. Let's copy this to here. Mouse up. Okay, let's check. Let's open the console and refresh the page. Okay, we refreshed. Now we can click our canvas and we can click out of canvas. You can see only click events triggered when we click on canvas, not out of the canvas. You can see I'm clicking in here, but when I click canvas, they are triggered. So first one is mouse down. You can see the attributes. There are many different attributes that we can use, and you may notice when we click mouse down event is triggered, and when I release the mouse up event is triggered. Mouse down, mouse up. Let's try it again. Mouse down, I clicked, and then when I release, mouse up was triggered. Nice. You can see it's very easy to use. And let's continue to our events. Now I would like to use the mouse move. Let's comment out these code pieces. And canvas at event listener, mouse move, function. Okay, we added our listener. Let's copy this part. Okay, let's check our mouse move event listener. Let's refresh. Now you can see when our mouse is moving, the event was triggered. But when I go out of the canvas, nothing happens. When I go inside of the canvas, it's triggered. You can see my mouse is moving and this event is triggered. Yes. And let's continue to events. Let's close this one, and I want to copy this one. Now I would like to check the click event. Click, click, and also the double click event. But I noticed that we skipped the mouse over and mouse out. After these events, we will check them. Let's check this click and double click events. Refresh. When I click outside of the canvas, nothing happens, but when I click canvas, the click event is triggered. When I click in here, it's triggered. But when I double click, you can see the click events are also triggered, but a new event is triggered. Double click. You can see double click is the same with the click plus click. When I double click, that's it. You can see two click events are triggered and then double click is triggered because we are clicking 2 times and then double click is triggered. And let's handle the last 2 events. Let's comment out these points. Mouse over and mouse out. Also copy these ones. Mouse over, mouse out, mouse over, mouse out, mouse over, mouse out. Okay, let's check these events. These events are like a Hoover state checkers. Let's go to our canvas, refresh. Now you can see when our mouse is on the canvas, in other words, hovering the canvas, the hover event is triggered, and when our mouse is leaving from the canvas, the out event is triggered. You can see. It's very easy to understand. Their names are very declarative. Mouse over, mouse out. There is one more thing that I want to mention. Let's open all of the commands. Also, I would like to explain this thing. You may remember when I double clicked, we were triggering 2 times click event, but let's comment out other ones. When we're trying to click on canvas, these events are also triggered. Mouse down, mouse up. Because when we are trying to click, first we need to mouse down and then we need to mouse up. Let's observe this logic. Refresh. I'm clicking, mouse down, I'm releasing the mouse, mouse up and click. So, in other words, click event means the combination of mouse down and the mouse up. You can handle the same thing with mouse down and mouse up combination instead of using click. Or you can check double click by tracking the click event for 2 times. It's up to you, but you got the main idea. It's very easy to handle the mouse events, key events on canvas. You understand the logic, you understand the main idea behind handling the events, key events or mouse events. You need to add an event listener and then track this event listener. That's it. See you on next lesson. Hello everybody. In this lesson, we will juggle a ball with our mouse. The ball will be falling and we will try to bounce this ball from our mouse cursor. Let's start. This is our free fall ball template from our previous lessons. Everything is defined. Ball is defined, animation is defined. Let's check. You can see ball is falling. We need to bounce our ball with this mouse cursor like this. Bounce instead of falling. So first we need to define our mouse events. We will define mouse move event because we are moving our mouse and we need to find its coordinates, exact coordinates. So let's define our event in here. Canvas at event listener, mouse move, callback function, console log, event as always, and let's check. Nice, it works. Now we need the coordinates of our mouse cursor. Mouse X 0, mouse Y 0, and let's assign them. Mouse X equals client X, mouse Y, client Y. Okay, now we get the coordinates into our variables. The fact we need to find now is the coordinates of the mouse cursor are touching with ball or not. We need to find the intersection, the collision moment. So let's check our intersection case. We need to check in here because we are updating the coordinates in here. So we can say that math square root. We will find the distance between 2 points, the center of the ball and the exact coordinates of the mouse cursor. So it will be something like this. Math power ball x minus mouse x This is the Pythagorean theorem. Plus, we can copy this and make this y, and close the if condition. Yes, we defined our if condition. Mouse collision check. We can say console log collision. Let's check. Let's open the console. Clear. Refresh. You can see something is wrong. We cannot accurately collide because the mouse event is not giving the accurate coordinates. It gives the coordinates according to the browser window, not canvas. So we can fix this issue. Let's come back to our event handler and we should get the boundings of the canvas. So let's do this. Boundings, canvas, get bounding client rect, and we need to subtract these offsets from these coordinates. So this means boundings left, boundings top. Now our mouse is based on this box, not huge box. Let's refresh. Yes, we made one more mistake. We didn't define the condition. Let's make this ball.r. It should be less than ball radius, and let's refresh it again. You can see we only collide when it touched. Nice. We created the condition accurately. Nice. Okay. We catch the collision moments. Nice. Now we need to update the velocity of the ball according to this intersection. The only thing we need to do is reversing the velocity times -1. You can handle momentum or more complex calculations, but for now I just want to make a small demo. You can see. We can juggling the ball now. Nice. It's bouncing when the ball touches the mouse cursor. Oh, I lost it. You can improve these calculations or everything. It's just simple demo, just a simple lab session. You can use momentum that we learned in previous lessons. You can do the same things, for example, like this. In this direction, you can update the momentum, you can handle different physical operations, and you can improve this juggling. Yes, that's it. You can improve the condition and at horizontal velocity your ball. It's up to you. See you on next lesson. Hello everybody. In this lab session, we will drag and drop the ball objects on our canvas. We will draw balls and then we will add a drag and drop capabilities to these balls. Let's start. We will draw random balls on our canvas, totally random color and the coordinates. We have these two wonderful functions from the previous lessons, get random int and create random RGB color. This is generating random color, this is generating random numbers between this interval. So let's draw our balls. First I would like to define some variables. Specs, balls. I would like to draw 5 balls, for example, and balls array. I would like to put my balls into this array and draw balls, for and we can create our balls by defining everything randomly now. We are looping with for loop. First, let's randomly create the radius and get random int between 25 to 50, and let's generate random color, create random RGB color, but this will be rand color, var ball color is RGB, so it's string, sorry. And the colors will be inside of these pluses. So first the red one, rand color R, rand color blue, and lastly rand color, sorry, this one is green, this one is blue. Okay, we generated our random color RGB and RGB, nice. Then we can create our ball object, ball. I'm assuming that you are remembering the ball object from previous lessons. It's taking radius and color initially, and you should include before the canvas script. And now I will put the radius and ball color inside of it. And again, the most important thing, ball context. We should assign the context. We can randomly define x and y coordinates of the ball. Radius canvas weight minus radius. Radius canvas height minus radius. And let's draw it. Lastly, balls array, push, ball. We will handle these balls later, therefore we need to add them into this array. This will be more easy for us. Okay, let's check. Let's refresh. Awesome! We successfully draw our totally random balls. Now we will add the drag and drop functionality. For example, we will click this ball and we can drag this ball and then drop. To tackle drag and drop, we need to track 3 mouse events: mouse down, mouse move, and mouse up. Mouse down to drag the objects, mouse move to move the objects, and mouse up to drop the objects. Let's create their event handlers. So close this for loop. Let's define the event handlers. Mouse event handlers. First, canvas at event listener. We need 3 events. First one is the mouse down, the drag moment, function, event, console log, mouse down, and second we need mouse move, And lastly, we need mouse down. And lastly, we need mouse up. Okay, we defined our mouse handlers. Let's check them. Let's open the console. Refresh the page. Okay. You can see mouse move is also working. Let's click. Mouse down is working. And let's release the mouse. What? Sorry, mouse up. Refresh. Let's move. Mouse move working. Click, mouse down is working, and release, mouse up is working. Nice. Our event handlers are working very well. As you may remember from the previous lessons, mouse events are not giving the coordinates of the mouse accurately. They are giving the coordinates according to the browser window, not the canvas. So we need to fix the issue again. Let's come back to our event handlers. And in this time, let's define our boundings in here, because it's a little bit global variable. Get bounding client rect. Now we can fix the issues in here. We can define the x and y variables. Mouse down x, event client x minus boundings left. Let's copy this one. Y top. Let's copy this to here and here. This is mouse move x, mouse move y, mouse up x, mouse up y. Okay, everything seems alright. We are ready to handle the ball detection on the click moments. So we can start with the mouse down event. First, we need to detect when we click somewhere on canvas, is there a ball or not? So we need to create a ball detection function. For example, when I click here, I have to find that there is a ball. When I click here, there is no ball. And also you may remember when I direct something to here, there must be a redraw on the canvas. So there is a new operations on canvas and we should clear the canvas and then redraw, clear and redraw. It's like the animation logic. I would like to separate the drawings of the boss from this initial for loop. I would like to create a new function for drawings. Remove this function, draw balls. Create balls and copy this inside of my function. Remove everything. I need to get the ball and draw it. But before draw the balls, I need to clear canvas. Context, clear rect. Okay, we created our draw balls function. Now we will draw our balls with this function. We can call it in here for initial case, because we are creating the balls and we can draw them. Yes, it works. Nice. And now we can detect the ball types. Let's create the function. So we need a function. Close these ones for now. We need a function to detect ball clicks. So function is hit on ball, and this function will take mx and my, mouse x and mouse y coordinates. And we need to call this function inside of the mouse down x, mouse down y. Nice. Now we are sending our mouse coordinates, the mouse down moment coordinates to our function. We can check the bulk detection. So let's create a for loop. But in this time we will create a different approach. We will loop the array from end to beginning, not beginning to end. So this means balls minus 1, I 0, and I minus minus. Yes, as I said before, we need to iterate from end to beginning of the balls because the balls are drawn from first one to last one. There might be some overlappings, therefore the top one is needed to be handled first. Let's create the condition. The difference between the point that mouse click and the center of the ball must be less than the radius. We also know this condition from previous lessons. We can easily write this last must be smaller than ball.r. I don't want to forget this time. Math power plus math power. So we need to find the mx minus balls array I x and let's copy this thing inside of this one, and this should be y, this should be y. Okay, and alert something on ball. Okay, let's check. Let's close this one, refresh. This is the issue. Okay, let's check it again, refresh. Okay, when I click here, you can see nothing happens. Why? Why? Yes, again, problem. Okay, let's check the canvas. Let's refresh, click. Oh, something is wrong. Let's check our events. We are calling in here. And yes, this must be client Y. And also, let's fix all of them. This is a huge mistake. And let's check the canvas again. Let's click ball, 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 ball. Nice. Now we can detect when we click on ball. We are in here. So we need to get the ball when we clicked. We can define a variable current ball, and we can assign this current ball in here. We can directly assign the ball. Nice, and stop the loop. Okay, now we handle the ball. And the second step, we need to move the ball. Now we know when we click on ball, we are handling this ball. But we need to move this ball after clicking. So we need to handle mouse move events. Let's define a condition. If the current ball is not null, current ball x should be mouse move x, and current ball y should be mouse move y. And after that, draw balls. We should clear the canvas and redraw after every single operations. Okay, let's check. Let's refresh. I clicked and I can move. But when I release, again it follows me because we didn't determine the drop condition, mouse up condition. Okay, let's define the mouse up. In other words, the drop operation. So let's come here. In this time, we don't need the coordinates or anything. The only thing we need is the removing the pointer of the current ball. So now this is enough. Let's check. Let's refresh. Let's click and release. You can see it works. Yeah, it works perfectly. We implemented our drag and drop. You can see. We use mouse down event to select the objects, our ball objects, and we use the mouse move event to move the ball objects, and at last we use mouse up event to release the objects. Release. Release. So we dragged and dropped the balls. We did it. Nice. See you on next lesson. Hello everybody. In this lesson we will create the main structure of our project. Now we have an empty project folder. Let's start. You can see now we are in our empty project folder. We will have some image style sheets, JavaScript files, and our index.html. So let's create our folders. First, I would like to create assets for the image, or we can make it images. And I would like to create the CSS folder. This is a real project, therefore I would like to make it more organized. So the JS, and that's okay then. Let's create index.html. Doc type. This is an HTML5 document, therefore we are starting with doc type HTML structure. Head and body. Okay, let's fill the head. First we need to define our character set, so let's define UTF-8. This is the most important thing. You need to define your character set at the beginning of your head, and it will affect entire page after this definition. If you define this in here, it will not affect anywhere. Okay, and title. Flappy Monster Game Project. Now we can define our canvas. Canvas ID Flappy Monster Game, and width 900, height 600. I will not write a fallback message for now. Okay, we defined our canvas. Let's check. We can't see, we need to style our canvas to make it visible. So let's create our style CSS. So this is our ID. First thing, I would like to define a border. 1 pixel, solid, and black. And some definitions. Block, because I would like to make it centered. Width 900, height 600, and make it align center 0 auto. And we need to include this style into our HTML. So link hrefs CSS style CSS relation style sheet. Okay, let's check. Nice, our canvas is in here now. Okay, we did it. Now we can create our JavaScript files. So first we need to create our canvas script. And also in this time we will create a util.js. Util.js. So let's write some commands. Global functions. Okay. And first thing I would like to add to here is the animation function of canvas, this function. We used this function for many times in our previous lessons. Now I would like to make it a global function and paste here. And also I would like to add this URL to these code pieces that you can check. Okay, and I would like to add random integer generator function. So again, we use this function for many times in our previous lessons. Again, I will use this one. Let's paste here. And also I would like to make it window get random int function. Okay. And this time I would like to assign this function to window object because we will use this function in everywhere. Again, I would like to add this URL. You can check. Okay, now we have request animation frame function as a global and random integer generator function as a global function. And lastly, I would like to create a random color generator function. We also create this function in our previous project, the bar chart project. It will be something like this: window get random color function. We need to generate random red, green, and blue colors, and then we will create our RGB color. So var red equals get random int from 0 to 257. Let's copy this. Green, blue. Now we generated total random RGB colors, and we can return this RGB. And now we need to add these random numbers into this RGB parentheses. So red, green, and blue. Okay, we created our global functions. Let's include this JavaScript file into our HTML. So in our index.html, before our close tag of body, we should include this JavaScript file, source, JS, util.js. Okay, and also I would like to include our Canvas script. Let's copy this Canvas script and open it. Again, I would like to create the save container Windows onload function. Window onload function, and we can handle the Canvas document get element by ID. Our ID is Flappy Master Game, and we can paste here. Okay, we create the main structure. The image will be inside of this folder, styles inside of the CSS folder, JavaScript files will be inside of this GS folder, and everything looks fine for now. Next lesson, we will start to create our game class. See you on next lesson. Hello everybody. In this lesson, we will create our game class. This will be a little bit complicated lesson. Therefore, we will make it in two parts. Let's start first part 1. First, I would like to create our game class. So this will be Flappy Monster.js. So this is our game class. Let's create the function Flappy Monster. Yes, this is the constructor of our class, and constructor will take the canvas as a parameter. Let's define our base. So game, this, and global attributes. First, I would like to assign the canvas to my game object. Canvas. And now we can handle the context from this canvas. Game context, game canvas, get context, two-dimensional. Context is important because we will draw everything onto this context, canvas context. So we created the most basic structure of our game class. Let's include the game file into our HTML and create our game object. So open index.html and include Flappy Monster.js and open CanvasScript.js. This is the canvas definition, and now we need to define game object. So our Flappy Monster, name Flappy Monster, and canvas is a parameter. Okay, we created our game object. Let's check that it was created accurately. So let's console log game. Okay, now we can check. Open the console, refresh the page. You can see our object is created and it has the canvas and context parameters. You can see we successfully created our object. Okay, let's close console and go back to our code. Close this one. Okay, remove the console. Now we will start a very long journey. First, we should understand that the game has 3 different scenarios. The game can have initial screen scenario, game playing screen scenario, and game over screen scenario. Basically, a game is consisting of these 3 scenarios. These are the three different scenes of a game. So let's define them as a variable. Initial. I would like to define them as a number 1. Game playing. The state is 2. And lastly, game over. 3. Yes, we defined our game states. So we can remove this command. So we need to define the current state of our game. So this means we need to define a game state. Game current state initial, because at the beginning the state should be initial state 1. If we start the game, state should be changed to 2, and if the game is over, the state will be replaced as game over state. But initially the state should be this one, initial. Nice, we set the state of game. Now we need a function to start our game loop. Let's create our start function. Flappy master prototype start. Again, we need the base to make everything understandable. You can see game current state, game context, game canvas. Everything is very clear. And also we need a game loop function. It's like animation loop function from our previous lessons. So let's create it. Prototype, run game loop. Okay. So we will handle the state, the current state of the game in the game loop. The run game loop function. Let's do. So let's get the base and we will handle the game state with a switch game state. Sorry, when I save it automatically scroll down. And I would like to use switch instead of using if-else conditions. Switch game current state. If the current state is initial, draw initial screen, and also copy this case. And game playing, draw game playing screen, game over, draw game over screen. Yes. Basically, the game loop will be like this. It will check the state and then it will behave according to current state. Okay. And let's call this run game loop function inside of the start function, because we need the start function like an animation manner. So start game. As you may remember, we are calling the animation function with request animation frame function. So request animation frame. Normally we can directly use this like this, but in this time we can't directly call the run game loop inside of this request animation frame function, because the run game loop is not directly accessible from outside of the function. It's inside of the prototype, so we need to call it from the game, the base. So write an anonymous function and call in here run game loop, and okay, we created the game start function and the run game loop function. Nice. Now we can create the draw functions of every single states. So first game draw initial screen, game draw game playing screen, and lastly game draw game over screen. And let's create these functions. First, the draw initial screen function, Flappy Monster prototype, function, the base, and the game playing screen, Flappy Monster prototype function, the base, and lastly draw game over screen, Flappy Monster prototype function, and copy the base. Okay, we created our functions. So let's go back to Canvas script. Now we need to start the game to triggering the game loop. So what we need to do is Flappy Monster start. Okay, now our game is started. The only thing we need to do is filling inside of these functions. Draw initial screen, draw game playing screen, and draw game over screen. These are our game screens. So let's open the draw init screen. And let's draw the initial screen. Draw. First I would like to draw a black background. Game, context, fill style, black, game, context, fill rect, 0, 0, game, canvas width, game, canvas height. Okay, we draw the black background. Let's check. Yeah, you can see we draw the black background of the initial screen. And now I would like to write something. Also, we can write something. Background. Text. Game. Context. Fill style. White. Game. Context. Font. And 36 pixel and Arial. Game, context, fill text, initial, game, canvas width divided 2, game, canvas height divided by 2. Okay, let's check. Yes, we did it. Let's move the text a little bit to the left. So let's make it like this. Nice, it's almost centered. This is our initial screen. Now let's draw the other cases, the other scenes. Let's copy all of this code. Draw playing game. Paste here and write game playing and also paste it to game over case and game over. Let's update the current state of the game and let's check the screen. So first I would like to make it game playing. Yes, it's updated and let's make it game over. Yes, it works. Nice. And let's make it again. And let's make it again initial. Yes, the initial. We created the basic structure of our game class. Now we have the main class structure and we have the game loop and we have the drawing functions. Next lesson we will continue to complete our game class. See you on next lesson. Hello everybody. In this lesson we will continue to create our game class. Let's continue. First I would like to complete the drawing functions. So let's update this one. This will be click to start. Refresh. Nice. It looks better now. And also I would like to update the game over screen. This will be game over. And let's update the state and check. Okay, it looks nice. And also let's do game playing. There's nothing to do for this state because this is the game state. We will handle this step by step in the next lessons. Now we can handle the events, mouse and key events. So let's define our function in here. Bind events, game, bind events. Let's create the function. Flappy Monster prototype. And as always, the base. Okay. First, I would like to handle the mouse events. Let's define our event handler. Mouse listener. Game canvas add event listener. Click function event. And also we will handle the key events, key listener. Window add event listener. Key down function event. Okay, we defined our listeners. Let's handle the states. So I would like to write a switch. Remove the default. Again, we will handle the game current state because we need to behave differently according to the state's current state. For example, if we are playing a game, we need to behave different. If we are in the initial screen, when we click on the canvas, the game should start. If we are at the end of the game over screen, if we click, it should behave differently. So let's define the cases so we can benefit from our run game loop switch case. Copy this one, paste here, clear. Initial screen and the game over screen have to be transitioned to the game playing state when clicked. So we should make, when we are in the initial screen and clicked, game current state should be game playing. Same for the game over case. But if we are in the game, when we click on the canvas, it should jump to our monster. Okay, let's check. We are in game playing state, but make it initial. Let's check. Let's refresh. Click. Nothing changed. Let's console log game current state. Refresh, inspect. When I clicked, the state is 1, click 2, 2, 2. It's 2 now, but it's not redrawn. We probably made an animational mistake. So we define our animation, run game loop. Yes, but we forgot to recall inside of this function this. We should think like an animation, yes, when we call this, and we should call inside of this function again. So refresh, clicked, game playing, okay. And let's change the state as game over. And let's check, refresh, game over. When I click on the canvas, it should change to game playing state. Yes, it works. But we are playing our game by clicking on canvas. Starting after clicking the game over screen can lead some issues. Therefore, I would like to transition after a key event after game over state. So let's remove this one. I don't want to handle this one. And I would like to handle game over restart state in here. And also let's update the draw game over case. So the text is now just game over, and also I would like to add press R to restart. Let's copy this. And this time I would like to write a little bit smaller. And I would like to write press R to restart. Oh, sorry, autosaves issues. And I would like to position it about lover of game over text, and our state is game over. Let's check, refresh. Okay, it looks better now. Press R to restart. Nice. And we will use keys, so we need to define a key map. So let's define our key map. Var key code R82. I checked it before, so I will handle the R in here. So again, we can do the same thing with a switch, paste, and let's remove this console and remove this game over state. Yes, key event, key down event, and the state is game over if event key code equals key code R. We need to change the state. And also I would like to console log to key code, and let's check. Our current state is game over, and if we clicked on R on our keyboard, the game state will be changed to game playing from the game over state. Okay, let's open the console, refresh. I'm clicking many keys, but when I click R, you can see the event is triggered and passed, and the state is changed. Refresh. I'm clicking to T, Y, U, other keys, but when I click to R, the state is changed. The screen is changed. Nice, we handled the key codes. Okay, now let's make the state as initial, and we are handling the initial and the game over states, and the basic structure is almost okay. Let's refresh, click, game playing. Okay, nice, it works very well. Okay, we created our game class basically. Let's close all of these functions. Yes, this is our wrapper object. And also our game will be consisting of objects. We will design our game object-oriented. So we need the object creation function inside of our Flappy Monster class. Let's create it. Create game objects. Create objects. And create the function. Get the base. Okay, our objects will be created inside of this wrapper function. We will have monster, background, score, wall, wall factory, many different objects. So we can create the JavaScript files of these objects. First, I would like to create the background.js. Game will have a background, moving background. Game will have a score on the right tab, score.js. But I would like to name it game score. Rename it game background. We can create wall.js. We will have wall factory.js. The walls will be created in a time interval from this factory. We will create a factory object, and factory will create walls for us. And also we will have a monster.js. Monster.js. Yes, we have wall factory, monster, game score, game background. And we should include all of these functions, classes. So we should include them between util.js and the Flappy Monster.js. We will use all of them inside of Flappy Monster, and the Flappy Monster is used in the Canvas script. Therefore, we should define them above the other ones. So let's copy util.js. 1, 2, 3, 4, 5. First, game background.js, game score.js, wall.js, wall factory.js, factory, and lastly the monster.js. Yes, these are our JavaScript files, and we included all of them. Nice, we created game class and project structure successfully. Now we can create our game components. We will continue with creating our game background. See you on next lesson. Hello everybody, in this lesson we will create our game background. Let's start. In our image folder, I put our background image. This background is used in our previous lesson. In our animation lesson, there was a hero in here and she was running. And again, I just want to use the same background because it's very suitable for a game background. Okay. So open game background.js. Let's create the constructor function game background, and the constructor will take two parameters, the image source and the canvas. Again, we should define the base, background, this, and first global attributes, background canvas equals canvas, background context equals background canvas get context two-dimensional. Okay, and now we can define our specifications. The background will be an image, so it needs two left top coordinates and width and height. So let's define them. Background x equals 0, background y equals 0, background width equals 0, background height equals 0 initially. But you may notice that the background should cover entire canvas, therefore the width should be canvas width and canvas height. Okay. And lastly, we need to handle the image source, and we need to create the image according to this image source. So let's define background source equals source and background image equals null for now, because we will create the image from scratch. Okay, we created the basic structure of the constructor function. So let's create our image creation function. Create background image, background create, game background prototype create. Every necessary specifications are inside of the object, so the only thing we need to do is handling the base, and we can access everything now. So let's create image, background image, new image, or we can directly do this, background image equals, and background image source equals background source. Okay, that's it. We don't need anything more. And lastly, we need a draw function to draw our background. Let's do game background prototype draw. This is very independent function from this creator constructor. This function will be called outside of the class. So get the base, and first thing we need to take into account is the image is loaded or not. So let's check. Background image is not now, and then we can draw it. So background context draw image, background image, background x, background y, and background width, background height. Okay, we did it. Now we need to use this class inside of our game class. This means we need to create an object, an instance of this class. Let's open our Flappy Monster. Come to here. Background. Game. Background equals new. Game background. We need to pass canvas and the image source. Images back.png. Okay, now we can draw this background, but I would like to make it lowercase. game background, and in our draw game playing screen, remove draw background, draw. That's it. Let's check the canvas. Refresh, click. You can see background is drawn. Awesome. We will draw game-related drawings inside of this function. Therefore, first thing we need to do is clear the canvas. Clear canvas. Game, context, clear rect. Game canvas width. Game canvas height. Okay, we draw the background, but in this game I would like to move this background from right to left. It will not be static background, so we need to update the coordinates. But before increasing the coordinates of the background or anything, we need to define a velocity for game. We need a game velocity, so we can define the velocity inside of the constructor function in here. Game velocity, game speed, game velocity equals 5. This is the pace, this is the speed of the game. And then we can update the coordinates of the background. So come back to playing scene. It's in here. First thing we need to do is game background x should game backgrounds x plus game velocity. Let's check. Click. Okay, it moves, but I would like to move background from right to left, so we need to make it minus. Refresh. Okay, it's nice. Refresh. You can see it moves from right to left, but it leaves from the screen. It leaves from the canvas. So let's define a condition that the image should come back from right again. Let's come. So we should define a condition that the image should come back from the right after leaving from the left. So let's define our condition. If math apps game background x greater than game canvas width, this means it's left from the canvas, so make the position of game background x is game canvas width minus game velocity, and continue to moving. Let's check. Refresh, click. Nice, it's coming back. Now our background is moving from left and coming back. But you may notice that there is a gap between the states. Yes, you can see there is a gap in here. We can solve this issue more complex mathematical operations, but we will make a simple trick. We will draw one more image next to the first image, and we will move both of them at the same time. There will be no gap between the background transition anymore. So let's come back here. Let's create one more background. So let's make this background 1, copy this and make this background 2. In this time we need to position background 2 next to the background 1, so game background 2x should be game canvas width. And we will move both of them at the same time. Let's come back our code. So this is background 1. We should move background 2, and let's copy this. This is background 1. This is background 2. Background 2. Okay, let's check. Refresh, click. You can see there is no gap between the transitions and background is moving from right to left. It looks very nice. It's very smooth animation. Okay, there is one more thing I would like to do. I would like to keep everything simple. You can see draw game playing screen function has become more complex, and we will draw many things more inside of this function. Therefore, I would like to create a separate function to animate the backgrounds. So Flappy Monster prototype animates background function. Let's get all of these pieces inside of this one and get the base. Yes, this is just for drawing background and animate it. And also we can separate them like this. Background 1, background 2. Okay, and let's call this function in here. Game animate background. Yes, you can see the function is very clean and understandable. Draw background, animate background. And everything related to background is drawn inside of this function. Totally separate from this function. Nice. Let's check it again. Refresh, click. Yes, it looks awesome. We did. See you on next lesson. Hello everybody. In this lesson, we will create our game score object and we will draw our game score onto the right top of our game. So the game is transitioning, moving now, and then we are adding a score onto the right top of our game. Let's start. Let's open game score and let's create our game score function. And the constructor will take one parameter, the canvas, and let's define the base. Game score, this, global attributes, game score, canvas, game score context, game score canvas dot get context 2-dimensional. Okay. As a score of game, I would like to track the travel time of our monster. So to track the score, first we need the start moment. So specifications. First we need the start moment. New date. This is the start moment when the object is created. That exact moment will be taken. And also the game score is the current score. And also we need to specify the position of the score. So we need x and y coordinates. Game score x equals 0, game score y equals 0. These are the parameters that we need to specify. Okay, let's create our draw function. Game score, prototype, draw function, get the base. Okay, we get the base and draw. Okay. So we need the moment of drawing and we will use the difference between this moment and the start moment, and this will be our score. So let's define our draw moment. This will be start moment or start draw, and this will be new date. And the score will be the difference between draw minus game score start divided 1000. Okay, now we can draw our score. First we need to define our font, game score, context, font. It will be a little bit large text, 45 pixels, and Verdana. And game score, context, field text. First parameter is the score, game score, and second and third parameters are x and y coordinates, game score x, game score y. That's it for this object. Now we need to create this object inside of our Flappy Monster in our game class. First thing we need to do is create the object. It's in here, score, game score, new, game score, game canvas, and we need to specify the coordinates of the scoreboard. So game score x would be game canvas width minus 200, and game score y will be almost 70 or 80. Okay, we created scoreboard object. Now we need to draw this object. Let's call it draw game playing screen, draw score, game score, draw. That's it. Let's check. Let's refresh. Let's check the canvas, refresh and click. You can see the score is, and in other words, the time is looping. Nice, but I would like to decrease the float amount. You can see it's so much. So let's go back to our game score. So we should update here, parse float to fixed 1. Okay, let's check. Refresh, click. Yeah, it looks better now. And let's update the position of scoreboard a little bit more right. So let's make this 150. Let's check. Yes, it looks awesome. Our game score looks very nice. Our background is moving, our score is changing, and next lesson we will add the walls onto our game. See you on next lesson. Hello everybody. In this lesson we will create our dynamic walls. Let's start. Let's open wall.js. Let's create our function. Again, this function will take on the canvas, and let's define our base. Global attributes, wall canvas, wall context, wall canvas get context to dimension. And then we need to define some specifications. Vol is the entire block which has a only small hole gap between this wall. So the wall consists of two parts, the upper part and lower part. So we need to define x coordinate of this wall and the y coordinates of this wall. So let's define wall x. Initially the position of wall will be canvas width, because initially wall will be staying here and it will come from right to the left and go to the left and will disappear in this point, and wall y will be 0, and we need to define the width of the thickness of the wall w width is 100 and the wall height is 0 for now. And then we need to define the gap amount. Wall gap 0 and wall color get random color. Let's check get random color. Okay, it's correct. Okay, we defined the constructor of wall object. Let's create the draw function. Get the base, draw. The wall is consisting of two parts, so we need to draw two parts. First, the upper part. Draw upper part, wall, context, fill rect, wall x, wall y, wall width, wall height. And we need to draw the lower parts. Draw lower parts, wall, context, fill rect, x, wall h, plus wall gap, wall width, and wall canvas height. Okay, we did it. We defined drawing upper bound and the lower bound. Now we can create our wall object and draw it. But in this time, we will follow a different manner. We will not create the wall objects inside of the Flappy Monster class. We will create a factory, and the factory will create the wall objects. So open the wall factory. Let's define wall factory, and this function will take canvas. So the base factory, this, and copy these parts. Okay, we define the global attributes, and this class will be our random wall generator, so we should define the gap in here. Specifications. First, factory gap 200. This is the minimum amount of gap, and we need to define the maximum amount of gap. Factory max gap 300, and we need to define the frequency of the walls. The walls will come from the right to the left. And what will be the frequency to drawing new walls? I would like to define frequency as 1.5 seconds, 1500 milliseconds. And also we need walls array. The created walls will be stored in this array. Okay, we created our specifications. Now we can create the generator function. Let's create wall factory prototype generate walls function. Get the base, generate. So we will create walls at a certain interval. So we need to use the set interval function in here. Set interval function, and the interval will be factory frequency. Okay, now we can create our wall inside of this function in here. So first I would like to create the gap randomly. Gap get random int factory gap and factory max gap, and we need to define the random height of the upper wall. So var h height get random int 0 to factory to max gap. Okay, and now we can create our wall. New wall factory canvas wall gap equals gap wall height equals height, and lastly factory walls push. We need to add this new wall to our array wall. Okay, when we create wall factory object and when we call this function, the factory will automatically generate walls in this time interval. So in this time interval. Now we can create the factory object inside of Flappy Monster.js file in our game class. So wall factory game wall factory new wall factory game canvas, and let's create the walls game wall. Let's make this lowercase and generate walls. Is it correct? Yes. Walls will be generated after this function code in our defined time interval. So the only thing we need to do is drawing the walls. Again, we need to draw inside of this function, draw walls, but we need to loop this array and update the coordinates of the walls according to the game velocity and redraw and redraw. Therefore, it will be a little bit complicated, and I would like to maintain everything as clean as possible for this function. So let's create a new function. Flappy Monster prototype draw walls function. Get the base and call it in here. And now we can write our function draw walls. First we need to handle the walls. Game wall factory walls, and now we can loop onto this array. Okay, we are looping onto this array now. We need to draw this wall in here. Walls I draw. But don't forget, we need to increase the x-coordinate of the wall according to our game velocity. So what we need to do is walls I x walls I x minus game velocity. This is minus because we would like to move the walls from right to left. Okay, let's check. Refresh, click. Yes, you can see our walls are coming from right to left. And they look very nice. But something is missing because they don't have color. Let's go back to our wall class. Yes, we forgot to add color onto our walls. Wall color, wall context, fill style, wall color. Let's check, refresh, click. Nice. Our walls are randomly colored now, and our game score is colored according to this new color. This is also a very new feature for us. We are trying to add color, but we created a new feature for our scoreboards. Yes, our walls are coming from right to the left, and there are a gap between these walls that our Flappy monster can try to jump, and they are disappearing from the left. It's very nice. Refresh, but there is a one missing point. We are drawing walls and they are coming from right and going to left. Yes, we are not seeing the walls anymore, but they are still in there. They are going to the left and left. So this means they are still existing. So we should remove the walls which are leaving from the game. Otherwise, our array will be overflow or can cause some problems in the factory. There might be thousands of, maybe millions of walls inside of this array. This is not an efficient way. So we need to remove the extra walls. Let's come to here, draw walls. And we need to write a function to remove extra walls. Flappy master prototype remove extra walls function. I would like to get all of these. Okay, now we need to define a condition to detect the wall is out of canvas or not. So this means walls I x plus walls I width smaller than 0 and remove. So to remove the wall, we need to make very simple JavaScript operation. Walls shift. This is the opposite of the pop function. Pop function removes at the end of the array, and shift function is removing the top of the array. Okay, let's call this function, and I would like to call this function inside of this drawWall function at the end of this function, because we are drawing walls in here and updating the coordinates, and this is the best place to check remove extra walls. Okay, and let's come here, console log game wall factory walls. Okay, let's check the canvas. Let's open the console and refresh. Click. You can see the wall objects are almost 2 and 3. Only visibles are inside of the array. Other ones are removed. This is a good optimization for us because we need to loop this array to check collisions in next lessons. And we have only 2 or 3 objects. This is very easy way, low complexity for us. It's very nice. If we don't remove the walls, you will see. Let's close this one. Let's refresh and click. You will see the amount of the array will increase exponentially. Not exponentially, but it will be very much after 1 minute or 2 minutes. You can see our complexity is increasing. Yes, instead of searching 3 or 2-membered array, we need to search 17th, 18th member array, now 19, 20. Yeah, this is very inefficient way. Yeah, you can miss this point, but this is not a good way to search. Let's open. Let's check it again. Refresh. Click. 2, 3, 2. You can see how many rows are visible in canvas and they are on the array. That's it. This is very nice. Yes, you can see it works very well and efficient. That's it for now. See you on next lesson. Hello everybody. In this lesson, we will create our Flappy monster. So let's start. Let's open our master.js. Close these ones. First, we need to create our class. Function monster. And as always, the monster will only take canvas, but not only canvas. We need to define our image source. Because our monster will be animated tile image, I put this image in here. This is our monster. We will rotate between these 4 cells. Because our monster will use wings when he is trying to fly. And we will rotate between these 4 cells. So we need the source of this tile. Okay, and define the base. And as always, the global attributes, the canvas, and the context. Okay, now we can define the specifications. And we need to define width, height, x and y coordinates of the image. Not image, the current cell, because we will show the cells one by one. Therefore, we need to handle this one, this one, this one. And I calculate the width and height of these cells. It's about 120. So monster x 115, monster y 115, monster width 115, monster height 115. Our monster will make a free fall, therefore we need to define a velocity and gravity for our monster. So monster vy should be 0 initially, and monster gravity, I would like to define the gravity as 0.20. And also we need to handle the source, image source. Monster source equals source, and monster image initially null. Okay, there's one more thing. Monster frame 0. Frame is the number of the current cell. So the frame 0, frame 1, frame 2, frame 3. We will rotate between these frames. Therefore, we need to track which frame we are running on. So this is the frame. And first thing we need to do is to create our monster image. We can copy from the background, the create function, and this part, paste here, make this monster, create monster tile image, and monster, it seems okay. This will be source, master image source, master source. Okay, everything seems all right. Then we need to create the draw function. So again, we can copy from this function, this one. Master, context, draw image. Everything seems all right. So we need to draw the image, but in this time not like this. First image. And SX, SY, you may remember SWSH, the source with height X coordinates. So we need to handle first the X master frame times 115, and Y will be 0, width will be 115, height will be 115. And master X, master Y, master width, master height. Okay, everything seems alright, but there is one more thing. After drawing the master, we need to increase the frame, and also we need to reset the frame when it becomes 4 frame 4. Okay, it seems alright. Let's create our master object inside of the game class. Come here and master game master new master. We need to define as images monster png and game canvas, and we need to draw it. Remove this one, draw monster, draw. Okay, let's check, refresh, click. What's wrong? Okay, we made a mistake. We use frame here, but forget to assign to master. Let's check it again. Click. Okay, but you may see there is a problem in here. We can make the height a little bit shorter. Make this one 100, and let's check again. Refresh and click. Okay, now the master seems alright. He is flying. He is using his wings and flying, but we need to add the velocity. In other words, the free fall, the gravity, the other attributes. So let's come here. In this time, we need to add the velocity inside of the master.js because it's directly independent to game class. We need to add gravity and y velocity. So master vy should be master vy plus master vy, and master y should be increased with this velocity. Okay, let's check it again. Refresh, click. Nice. and we can't do anything. Nice. First, I would like to define a condition that the monster has become the bottom of the canvas. It should stay in here unless he crash or collide the wall. So let's define a condition. If monster y plus monster height greater than monster canvas height, monster y should be monster canvas height minus monster height, and make the monster vy 0. Okay, let's check. Refresh, click. Nice. Our monster is bottom of our canvas. We are not checking the collision yet, therefore he can fly very, very happily. But when the collision check works, the game is over, and game is over. And there's one more thing I would like to do. I would like to make one more condition to the top of the canvas, because you can click and your monster can run away. So the condition will be else if monster y smaller than 0, monster y 0, monster vy 0. Okay. And let's update our mouse controller to force our monster to fly when click on our canvas. So come here, and where's our event listener? In here, game playing. The only thing we need to do in here is we need to make game monster vy should be -1. When we click on canvas, it should jump. This is the action. So refresh, click. You can see our monster is flying. Okay, we can change the gravity a little bit. Make this 1. Okay, it looks better. Okay, it looks nice. Okay, I noticed the issue because when we click double, it automatically affects reverse to velocity. Therefore, we need to prevent this. We need to prevent this. So what should we do is monster vy, not this one. We should do -1 times game velocity and refresh, click. Okay, it looks all right now. Our monster is flying and it looks very nice. It jumps when we click on canvas and it's very nice. Next lesson we will check the collisions and some final touches, and we will finish the game. See you on next lesson. Hello everybody. In this lesson we will complete our game. Let's start with the collision check. Before the collision check, I would like to increase the gravity. Yeah, it's better. It's a little bit sensitive. Okay. And okay, let's go back to our game class and come here. So we need to check the collisions. We need to check the collisions in the draw game playing screen function. So we need to call collision check in here. and I would like to separate the logic as always. You can see everything is very clean. So game, check collisions, and let's create the function Flappy master prototype function and the base. Okay, so we need to check that is our monster collided to any wall or not. So we need to check this collision condition. You can see there are 2 or 3 walls on the canvas. So we need to loop over these walls to check one by one the monster is collided to them or not. So get the walls, game, wall factory, walls, and let's loop. Okay, now we are looping over the walls array. So we need to define an if condition to check the current wall and monster collisions. In here we need to define an if it's collided, and update the game state, current state as game over. This is the thing that we need to do. So again, I would like to separate the logic from this function because there's a huge logic behind the collision check. So let's create a function. Flappy master prototype is collided. This function will take 2 parameters, the master and the wall, current wall. We will call this function in here is collided. Game is collided. Game master walls I. Okay, we are sending the parameters and get the base. Okay, everything is very separated, very clean. The only thing that we need to do is create the condition, create the logic in here, and that's it. So I would like to define a boolean is collided true and return is collided. We need to define the logic between these 2 parameters. We need to compare the wall and the monster. So make it more clearly, I would like to define some variables. So first I would like to define the monster variables. Monster top, the top coordinate, monster x, but game monster x, and let's copy this one for 1. Bottom game master y plus game master height, and right game master x plus game master width, and lastly left game master x. I made a mistake, this will be y, this will be x. So master coordinates, and now I need the wall coordinates. But for now I would like to send false because I would like to observe. So we need the coordinates of the wall, we need to x coordinate, we need to this coordinates and these coordinates. So we would like to check x, y, top, bottom, that's kind of things. So let's define wall top wall y plus wall gap. This means top means the top of lower wall, wall bottom, wall y plus wall height, bottom of upper wall, and lastly we need the left and right of the walls, they are same, wall left, wall x plus wall width, this is wall right, sorry, and we need wall left, wall x. Okay, we defined the coordinates and now we need to define the condition, our if condition, and inside of this if condition the collision check will be false, is collided, false, this is true. First condition is the condition that between the walls, sorry this one makes error. First I would like to check this gap, this hole. This is the zone between the upper wall and the lower wall. So let's define the condition. Monster should be lower than the wall top. Monster bottom should be less than wall top, and monster top should be greater than wall bottom. If it's okay, there is no problem. This condition means the monster is inside of the hole, the gap. That's okay. And also we need to check other conditions. If the monster is on the left of the wall or right of the wall, this means no collision. So this means there are two more conditions. First one is monster left greater than wall right, or monster right lower than wall left. So if the conditions are met, this means there is no collision. If this condition is not met, this means there is a collision. So let's check, let's refresh, check. Yes, I can fly to show the collision. No, why? We are false, because this is true. Because this must be true, otherwise it's always false. Okay, let's check, refresh. First let's collide. What's wrong? There's a problem. The wall bottom, the wall top should be wall y plus wall gap, but wall height should be added. So let's refresh, click. Yes, we can fly, and game is over. Let's do it again. I refresh the page. Yes, our monster is flying, and if I touch, game is over. Let's restart the game. I'm clicking R, but game is not starting. You can see I can click, something is happening. When we try to start game after the game is over, you can see we can't, because previous states are not cleared. So we need to create a reset function to clear all of the previous states. So come here, Where is our event handler? So we forget a console log in here. We need to reset game in here. Reset. And Flappy Monster, prototype, reset. Okay. Reset states. First thing I need to do is game score, start, new date. I would like to refresh the starting time, and also we need to reset the score 0, and let's remove the walls, wall factory, walls, and game master x 115, game master y 115. Okay, we resetted everything. Every previous states are removed and cleared. Okay, let's check the game again. Refresh, start. Game is over. I'm clicking to R. Yes, the game is started successfully. Nice. And our monster is flying between the walls. Oh, and there is one more thing that I would like to add. I would like to add the score to this game over screen. I would like to see the score in here. So let's come back to game over screen throw function, and let's copy these code pieces to here. I would like to draw it a little bit larger, and your score game score and move it to a little bit top. Okay, it looks nice. Let's check. This is the final touch of our game. Click and let's try to play. Let's try to create a record. Game record. Oh, yes, our score is in here now. Let's restart. I click R. Game is very fluent, very smooth. Our monster is trying to fly and overtake the walls. Yes, we did it. We completed our Flappy Monster game. We did it from scratch with you, step by step. And now you can put this project to your repository or your website. You made an awesome game and you can improve it whatever you want. For example, you can save the scores and you can show the highest score in here, or you can improve the collision checks. That's kind of improvements. That's it for now. See you on next project. Hello everybody. In this lesson, we will make a simple bug fix. So when we open our game, and if we do not immediately start to playing our game, the wall generator is still working in behind and walls are generated continuously. So when we click to start, you can see the walls are released. All of the walls are released. So refresh, wait a little bit, start, and you can see walls are overlapped because many walls are generated while we are waiting to start game, and when we start game all of them are released. So we need to start our wall generator when we start our game. Let's fix this issue. Let's come. So we are creating objects when we create our game, and when we create our objects, we are calling this function generate walls function. This is our generator. Let's get this from here to here. This is initial state, and when we click on our canvas and the game is in the initial state, then the generator will work. Okay, let's refresh. Wait, wait, click. You can see walls are not overlapped because the wall generator started to work when we click on our canvas, the initial state, refresh, wait, click. You can see now we don't have any problem with our walls. They are not overlapped because they are not created before our game started. Yes, that's it. We fixed our small bug. Our game is ready. Hello everybody. In this project, we are going to build a paint application. This is the paint, the classic paint application, which was default on the Windows machines in the past. It's consisting of a color palette, some brushes, some shapes, and more extra features. You may probably use this application in your life. And in this project, we are going to build a simple version of this paint application. This is our paint application. I made a simple design for our project. It's just a template without any functionalities now. We will make this design work step by step in next lessons. The left block is consisting of the color palette, the brush widths, clear and the save buttons. So this means, in other words, the left block is the toolbox of our application, and the right block is the canvas that we will draw on it. This is the canvas. This is our toolbox. You can see the mouse cursor is changing. For example, when I come onto the color or width, clear or save buttons, or on canvas. Exactly, you can see it's totally different on the canvas. It's like original paint experience feeling. So mainly this is our design. These are the components. I want to show the code a little bit to you. I want to introduce the code, the project structure. So this is our project, which consisting of 3 files: index.html, style.css, and canvas-script.js. Index.html is very organized code. You can see there is a main tag. Inside of the main tag there are 2 blocks, left block and right block. Inside of the right block you can see there's a canvas in the right block, and inside of the left block there are 3 divs. The colors are the buttons that we will handle the events, and the brush. These are the brush widths of our canvas, our drawings. And lastly, the buttons, which are clear and the save buttons. We will use them to clear the canvas and save the canvas as an image. So that's it. And I also handled the canvas context and the boundings. This is also ready for starting. Yes, the base template of the project is ready to start, and this is our design. We are ready to start. We introduced the design and the code base. See you on next lesson. Hello everybody. In this lesson, we will create the basic structure of our project. We will handle the colors and the brush widths. We will handle these features, the colors and the brush widths. So let's start. These are the variables that we defined in previous lesson. Also I defined. So we will handle the brush and the colors. The colors and the brush. You can see there are there are many buttons in here that we need to handle one by one. We need to handle all of them separately because when we click on blue, we need to get this value and we need to get this value. so we need to handle them separately. This means we need to add event listeners to these buttons one by one. And we can do it like this on click. Set color. And also we can add the color like this. And let's define the set color function in here. Function set color, and show it in the console. And okay, let's check the page, open the console, refresh the page and click it. You can see we handled the color. But we need to add this on-click definition to every single buttons. So let's copy this and paste it to every button like this. Yes, even I'm making a copy and paste, but it's difficult because this is very inefficient way to handle the events on a button in this condition. And more. I'm so tired. That's enough. So you can see this is not an efficient way. We are passing everything manually. I need to pass everything in here. I need to update everything. This is very difficult and very old school way. Exactly, old school way. So we can handle the click events of buttons by listening to parent div. This means if we listen to colors div, just this div, we can handle the mouse events instead of defining thousands of these on-click events, because this way is also very difficult to manage. You need to define everything in here, and if you make a mistake, it's very difficult to debug. Exactly. So we can handle the click event of button by listening to parent div. This is also called bubbling in JavaScript. Event bubbling. When an event happens on a button, for example, it first runs the handlers of button, and then parent, and then all the way up on other ancestors. So we can handle by listening body or main or every parent and ancestors. So if we listen colors div, we can easily handle which button is clicked. Okay, let's define our colors listener. So first I would like to remove all of these unnecessary things. Again, our HTML is awesome. So remove this set color. Let's handle the colors div. Handle colors. First we need to handle the colors div as an element, DOM element. So colors, document, get elements by class name, colors, and this function returns an array. We need the first element of this array. Okay, let's attach the click event, colors, add event listener, click, function, event, and console log events target value. This means it will targeting the elements and I'm getting the value of this element. Okay, let's check, refresh, click. You can see we are handling the colors very easily. We only define one event listener and we can easily handle the colors. That's nice. So we can do the same things to handle the brushes. Handle brushes. Brushes. We can copy this. Brushes. This will be brushes. Close the colors. Yes, brushes and the buttons. Yes, we handled the brush. Let's check. Refresh. Click 1, 2, 3, 4, 5. Nice. We handled the color and the brushes. Now we are ready to draw on our canvas. That's it for now. See you on next lesson. Hello everybody. In this lesson, we will handle the mouse events and draw on our canvas, our paint application. Let's start. So, to draw on our canvas, we need to handle 3 different mouse events. Mouse down to start our drawings, mouse move for drawing on our canvas, and mouse up to stop the drawing. So let's define the events on our canvas. Mouse down events, canvas at event listener, mouse down function events, console log events, and let's copy this for 2 more times. Mouse move, mouse up. Let's make this mouse move. Let's make this mouse up. Okay, let's check. Let's open the console. Refresh. And mouse move. You can see it works. Mouse click. Mouse up. Mouse click. Mouse up. It works. Nice. But you may remember we need to adjust the mouse position according to the boundings because the coordinates are not accurate. We need to adjust them according to our viewport. So I want to define a mouse X and mouse Y variables and then assign the adjusted coordinates to these variables. So let's come here. Specifications. As always, mouse X 0, mouse Y 0. Yes, they are initially 0. And then let's assign coordinates to these variables. Let's come here. Notice mouse X will be events client X minus boundings left mouse Y equals event client Y minus boundings top. We already did these calculations for many times in our previous lessons, you may remember. And I forgot the semicolons. Okay. Yes, we defined the accurate coordinates now, but we can create a function to prevent code repetition. You can see it repeats the same things. Let's create a function. Handle mouse coordinates function set mouse coordinates events. Let's copy this and let's call it in here set mouse coordinates events. Okay, It seems better now. We have a function that we can use to set the mouse coordinates from the mouse events. Nice. Now we are ready for drawing our lines. First, let's define the initial values of our color and brush to our context. So, context, stroke, style, black, context, line width, 1, brush color, brush width, initial, brush color, initial, brush width. Okay, let's handle the mouse events now, but also I want to define a boolean to track the drawing state. Let's define it is drawing false. Okay, let's start with the mouse down event. The drawing will start when we click on the canvas. Therefore, we need to make this boolean true in the mouse down event. And we need to make it false in the mouse up event. And the drawings will be between mouse down and mouse up event. In other words, in the mouse move event. So we can start the drawing. Context, begin path, and context, move to mouse X, mouse Y. That's it. We started to drawing our line, and we need to continue to drawing this line inside of mouse move event. But first we need to check that we are drawing or not. If we are drawing, we can draw, otherwise we wouldn't care about the mouse move event, because mouse move event is also triggered when we move our mouse on canvas. Therefore we need to be careful that we are first clicked and then we are moving. So this is the reason why we are checking in here. So we will make it context, line 2, mouse X, mouse Y, and lastly context, stroke. That's it. Let's check the canvas, refresh, click, and drawing. There might be some problem. Yes. Event is not defined, canvas 43. Sorry, my bad. Event, and event. Okay. Refresh, click. Yes, we are drawing. It looks awesome. We can draw on our canvas. Nice. Now let's assign the color and the brush to our drawings. They have no functionality yet. When I click on blue and start to draw, the color should be blue on the canvas. So we should make it in here. This is the color. Context, stroke, style, event, target, value. And also I want to add a fallback. Black. Remove this console log. And the brush. Context, line width, event, target, value, or 1. Remove the console log. Okay, we defined everything and we are ready to check. Let's refresh the page. and click the red and make the width as 5 and true. No, it doesn't work. Why? First thing I noticed, this should be brushes. I made a mistake when I was reversing the code, and it should work now. Refresh, click red, brush, but the color didn't assign. What's the problem? Context, stroke style, event, target value. Yes, it looks true. This should be double OR. I made a mistake. It was bitwise OR. Okay, let's refresh. Refresh. Click this and this. You can see the color is assigned. Yes, we did it. It works. That's purple. Yes, our paint application is almost ready. In next lesson, we will make these buttons works and finish the project. See you on next lesson. Hello everybody. In this lesson, we are going to clear and save the canvas. Let's start. First, I would like to create the event handlers of these buttons, these clear and save buttons. So let's handle the clear button first. Handle clear button. So first let's get the button as an element. Clear button document get element by ID and clear. Now we have the element, clear button element. Now we can attach the event handler to this element. Clear button at event listener. We need to attach a click event listener function, and let's write a console log to check that it works or not. Console log clear. Okay, let's do the same things for the save button. I would like to handle the save button. Handle save button. Save button. We can copy this. Let's make this save. Make this save. And also we can copy this and make this save. Save. Okay, let's check. Let's open the console. Refresh. Let's click the clear button, clear. Let's click the save button, save. Yes, you can see the events are working. Now we can add the functionalities to these event handlers. They are working. First, we need to handle the clear event. It's the most easiest part. We will just add a clear rect to our context. Context, clear rect, 0, 0, canvas width, canvas height. We did these clear operations for many times in our many previous lessons. You are also familiar with this cleaning operation. Let's check. Refresh, draw some things. Yes, I tried to draw a smiling face and clear it. Yes, it works. It clears the canvas. Okay, let's continue. We handle the clear button and we are clearing the canvas now. And then we need to save the canvas as an image. We already experienced how to get the canvas as an image. We did it in one of our previous lessons. We were using the toData_URL function to grab the data of canvas. Again, we will use the same function to handle the canvas. Let's handle the canvas data in here. Canvas data URL, canvas to data URL. Yes, we grab the canvas data to this variable. To save this data as an image to our computer, we will make a simple trick. We will create an anchor element. Then we will assign the canvas data URL variable to this anchor element. And lastly, we will click onto this anchor element and the image will be downloaded. Let's create the anchor element. Documents, create elements, anchor, and let's assign the canvas data URL to this anchor element. Canvas data URL, and we can define the name of the image, download, drawing. Lastly, we will click onto these anchor elements. Click. That's it. Okay, let's check the canvas. Let's refresh and draw some things and save. You can see we downloaded our canvas as an image. Yes, it is. You can see. But the name of the saved image is default, the drawing. I want to make it dynamic by taking the name from the users. So we will use the prompt function, which will ask the user for the name of the image, and then we will assign this name to this downloads attribute. So let's define it. Var image name prompt, please enter image name, and then I will assign this name to here, and I will make a fallback. Drawing will be fallback if it is null or undefined. This will be used. This will be better improvement for our Paint application. We will define the name of the image dynamically by taking from the user. Let's check. Refresh. Draw something and more thicker blue, and let's save it. Please enter image name. The name of the image will be Alperen, my name. Okay, and you can see the image is saved by the name of I defined. When I click it, you can see our image is saved. Yes, it works correctly. We can save the canvas whichever name we can give, and our project is completed. We built a simple paint replica, and we can draw anything we want by using these colors and the brush widths. We can clear the canvas. We can save the canvas as an image. Yes, it's very functional and very comprehensive application, even it looks very simple. Yeah, we did it. See you on next video.